Hello.
Hello. Hey, everyone. Welcome to another Svelte Summit. I'm Kevin. I host the Swedish Svelte Society meetup. Well, before COVID, I guess. And I'm joined by my co-hosts. Maybe you can say hello.
I'm Joe from London in the UK. So I'm involved in running the London Svelte meetup.
I'm Jen, actually from London as well, and I've just joined the Svelte London committee with Joe, and I'm also part of the organizing team for this. So I'm glad to be here. I'm new to Svelte, so yeah, I'm really looking forward to all the talks as well.
Yeah.
Oh,
you're muted, Corinne.
That's very COVID times. Things that happen.
I am Karine from Brittany in France, and I'm the co-host of Svelte Society Day France.
Nice. All right. So yeah, I guess I'll introduce the event and what we're going to do. So yeah, I'm going to remove all you guys so I'm focused here. Yeah, so welcome everyone. It's pretty cold here. As you can see, I'm wearing my hat and my scarf, but hopefully we'll make it through. So we're finally here. It's a new Svelte Summit event, and I hope you guys are as excited as I am, because I'm super excited. Even though I'm a bit stressed, it's been a lot of fun. So we're going to start off by thanking our sponsors, and first out is Filevine. So Filevine is a tool for, oh, I should probably bring up the overlay here so you can see the sponsors. Sorry about that. Yeah, okay, let's start from the beginning. Filevine is a tool for handling client workflow and document management. It's the work operating system for professionals. So check them out. And yeah. Oh, and they're also hiring. So I guess you can take a look at the link I posted. Next up, we have GitPod. They remove all the friction from the developer experience, so you're always ready to code. They make software development more collaborative, joyful, and secure. So they recently migrated their website from Zapper to SvelteKit, actually, and it's open source as well, so you can actually check out the code. I'm going to post a link to that right here. And then they also wanted us to mention that they're hosting a conference all about developer experience. And that's something that's pretty close to Svelters' hearts, I think. We all like a good development experience. So you can check that out as well. Right here. And lastly, we have Budibase, which is a low-code tool that helps you build internal tools on your own infrastructure in just minutes. And they're also hiring at the moment. But more importantly, the tool itself, it's open source, so you can check that out. And let's see here, right, if I can find the link. Should have had that here somewhere. 1 second. All right, and there's the link. Okay, so let's talk a bit about the event and how the conference is structured. So we'll start by doing a number of talks, and you've probably seen the schedule in the video description already. But we'll do talks for about 2 hours, and then we're going to have a breakfast, lunch, dinner break, depending on where you're at in the world. For me, it's going to be dinner, I think, maybe late lunch. But yeah, so during the break, we're actually also going to use a tool called Meetball, which is a how should I describe this? So this is like a tool where you sign up and you get paired up with Svelters from around the world, and you get to talk with them for a couple of minutes. And so I'm going to post a link, so make sure you sign up if that's something you're interested in doing. So that's a one-on-one video chats, pretty much. And of course, it's not mandatory to do it if you don't want to. But yeah, I'm going to post that in just a bit. And after the break, we're going to continue with more talks. And let's see here. Yeah. And then during these talks, we're also going to have a short quiz where you can test out your Svelte skills. Maybe win some cool magic internet points that aren't worth anything, but you can win anyway, I guess. And lastly, you should check out the Discord server as well. That's where a lot of the people hang out and talk. All right. With all of that out of the way, we can start our first talk of the day. It's about writing a book for high schoolers. So let's give it up for Erik and Glad. I think that's how you pronounce it. Well, I guess we'll hear.
Do you remember the exact moment when you started programming? Where were you? I was in a bathroom stall. The year was 2008 and I was at my high school. I'd found a page where I could learn HTML called W3 Schools, and to avoid being caught doing something nerdy, I'd found sanctuary in that bathroom stall with my laptop. A few steps into the tutorial, I was going to make an actual HTML file, which could be opened in a browser. I was pretty excited, so when I double-clicked that file and saw the words "Hello World" on screen, I giggled loudly. It was then that I remembered where I was and that someone could have heard me, so I slammed my laptop shut and left. That fall, I enrolled in my school's information technology class. Our teacher came right from a job as a web developer and taught us programming using the standard for interactive web content in 2008, Adobe Flash. Flash was like Microsoft Paint with superpowers. You open it and there was a blank canvas and a timeline. Not only could you draw, you could make the drawings move. My class would turn in over-animated homework solutions with lots of Easter eggs, because that was the web we knew. We were Generation Flash, raised on games and a more is more attitude towards design. I graduated from high school in 2010, the same year as Apple effectively killed Flash. Since then, the barrier to entry on the web has grown larger. Imagine that you're 15 today and that you've signed up for IT class. The first day you spend hours printing text in something called the developer console. You haven't seen it before and you're not particularly excited by it either. You move on to document.query selector in the next classes before you finally get to use a modern framework. You have to install stuff using the terminal, which you've never used before, so you have trouble installing everything. And when you're finished installing, you added a file by mistake and everything crashes. Your teacher doesn't have time to help, so you're just stuck. Contrast this with my experience of making animations the first day. A bad first impression could make a potentially awesome future programmer choose a different career. This is a cultural loss and an economic one, too. Many countries need more IT workers. My country, Norway, needs as many as 66% more by 2030, and we're on our way to missing that goal. Lowering the barrier to entry is an important step in turning this tide. And I'm not saying that we should dumb down programming. Kids will have to learn about the console and the terminal, but we have to let them gain momentum before they meet these barriers. I think we have a tool which could give kids that momentum, and that tool is Svelte. In the 10 years that passed after high school, I got a master's degree and a job in IT. It was at this job that I discovered Svelte through a colleague and was immediately infatuated. In 2020, I made a Svelte workshop for students and professional programmers. The workshop's goal was to show off Svelte's selling points, most importantly, the templating, reactivity, and animation. And we were going to make the game Snake. When I debuted the workshop for about 50 students, many of them were in their first year. Some had only programmed for a month or so when attending. What surprised me was that there were only few questions, and few questions is usually a warning sign, but it turned out that nearly all of the students had gotten Svelte and had finished the main tasks. Witnessing this was a blast from the past. A visual first learning experience with no great divide between the more and less experienced. It was almost like Adobe Flash. And a few years later, A few weeks later, I experienced a second blast from the past when my high school IT teacher got in touch. I'll let him tell the story because he's with me here today. And Glør, the stage is yours.
Thank you, Eric. Last year, I was contacted by the publisher Cappelen Damm. In 2017, we wrote a textbook for the information technology subject. And with a large change in the curriculum coming up in 2021, they wanted us to update the book. Before changing anything, I did a word count in the PDF version of the previous textbook we wrote, with vanilla JavaScript as the chosen programming language. I typed in the word document, as in document get element by ID, document query selector, and so on. Then I hit the search button and waited quite some time for Acrobat to process the query. And the result was scary, with over 500 occurrences of the word document. And it struck me that the poor students must have been bored to death while reading this book. What troubled me most as a teacher was the gap that arose each year between the students. Most of the students managed to hang on in the beginning, learning about variables and basic programming using console.log or alert for the output. As we moved on and started to manipulate the DOM, some students got it, but a lot just fell off the wagon. The confusion skyrocketed. Why is the input field a constant? Is it a reference to the input field? So the value from the input field is not a number, even if it looks like a number. Do I have to cast the value to a number? In Norwegian high school, IT is just one of many subjects. Many of these students will not be programmers or front-end developers. But it is important that they too get a pleasant experience with IT, and that they see that programming can be useful not only in the IT industry, but in a lot of other professions. So I wanted to radically change the book by replacing plain JavaScript as the teaching language with Svelte. But the work would be tremendous, and time was short. And this was where serendipity brought me into contact with Eric again. At this time, I was working as a lecturer at Christiania University College, teaching front-end classes. And I was at this meeting at Novit, ObjectNet, an IT consulting firm, discussing whether it was a good idea to use Kotlin in a new study program for app development. I mentioned Svelte and Svelte Native as an alternative, and they told me that they had a Svelte expert in the building. And this turned out to be Eric, a student of mine back in the Flash era of my life. So when we started to look for people to contribute to the textbook, Eric was an obvious choice.
I wholeheartedly agreed with Glør in choosing Svelte. There are 3 reasons why I think Svelte is more likely to get the students to be excited than any alternative. The first is Svelte's online REPL. There are no installs that can fail. You can even use it on your cell phone if you're in a bathroom stall. And you can use the URL to send code to friends to brag. The second is Svelte's briefness. You get your point across in fewer lines in Svelte compared to React, Vue, or plain JavaScript. And less code means less room for misunderstanding. This is a great advantage both for teachers and for the learners. The third is animation. Being able to add transitions and animations with only 2 lines is fun.
In the textbook, the kids start by learning HTML in part 1, move on to CSS in part 2, and start making interactive web pages in part 3. Simple as that. At the start of the chapter, we are assuming they know nothing about programming. And at the end, they are going to understand variables, arrays, objects, for loops, connecting input fields to data, making functions, and read and display data from an API. We also recruited another co-author, Hossein, a high school STEM teacher, to produce a varied selection of tasks and challenges for the textbook. For instance, to create an interactive calculator to find the area of different types of geometrical shapes, to create an automatic translator from Norwegian to Pig Latin, to create a piano where you can play tones by hitting the keys, an ATM interface, and an emoji search page that fetches data from an API.
Norway is a small country, so we know that the direct impact of our book will be limited. Our hope and our reason for coming here today is that our book will serve as proof to people abroad that Svelte is an excellent language for teaching programming. We hope that other publishers will place the same trust in Svelte as Cappelen Damm has. As I said earlier, a few precious seconds may decide a kid's future. We're certain that Svelte is going to tip the scale in the favor of programming. I was lucky to be a part of Generation Flash. Let's make this Generation Svelte.
Oh, that was
I
great.
really enjoyed that. That was great.
Yeah. What was your first language?
My first, I think actually mine was Java, well, HTML. I was using jQuery Mobile,
Right.
which
Yeah.
is great. jQuery Mobile and jQuery UI, fantastic tools. But
Nice.
I really enjoyed reading through the YouTube chat and seeing people, we've got everything from Turbo Pascal all the way to like a Discord bot, which is really awesome.
Yeah. Yeah, I think I started with Lua actually back when World of Warcraft first came out.
I was going to say World of Warcraft script.
Yeah. I didn't get very far though. I never made anything interesting.
Well, I think
All
that's
right.
the thing about games, right? Games are such a good way to get people into coding. Yeah,
Definitely.
Minecraft as well, more recently, I suppose.
I really like this talk. I hope it I hope it can travel across the border to Sweden as well, just by maybe translating the book. That'd be cool to have it here as well. All right, so should we move on to the next talk, maybe?
Yeah, absolutely. Looking forward to it.
Yeah, so that's the data science widgets with Svelte and Jupyter. That's going to be fun.
Yeah.
Let's see.
Have you ever used Jupyter notebooks before, Kev?
I haven't.
Cool. So hopefully we'll all learn some good stuff here.
Yeah. Let's see here.
Everyone, my name is Alex Cabrera, and I'm a PhD student at Carnegie Mellon University. I work on data science tools, especially for training machine learning models, and I've come to love using Svelte for creating interactive tools. Today, we're going to look at how you can use Svelte to create beautiful widgets for Jupyter notebooks, like you can see in this visualization. One of the most popular data science systems are computational notebooks like Jupyter, which use modular cells and widgets to make it easy to explore and analyze data. Jupyter notebooks have support for interactive widgets, but they use older web technologies and are difficult to code. At the same time, we've seen new libraries like Svelte make it much easier to create elegant reactive interfaces. By using Svelte to create these notebook widgets, we hope to make it easier to design interactive data science tools. Jupyter widgets consist of two primary components. The backend model is a Python module that connects to the notebook kernel. This backend then communicates with front-end views, which are JavaScript modules. In our case, we're going to write them as Svelte component. Let's walk through how to create a simple Svelte widget. We can first use this cookie cutter to create the basic template. If we look at the resulting code, we see two main components. The backend Python folder with the main file example.py, and the front-end folder source with the main file app.svelte. We can now install the base widget and see what it looks like. First, we install the Python package with pip, and then enable the widget either for Jupyter Notebooks or Jupyter Lab. When we run a Jupyter Notebook, we see a very simple widget with a value counter and button. As with the normal Svelte component, we can reactively update the value by clicking the button. But since this is a widget, we can also see and update the value from the Python code itself, since the Svelte component's variable is bound to the Python kernel. Let's add another variable to the widget to show how Svelte widgets work. In this case, we might want to add a units variable to the number that we're showing. In the Svelte component app.svelte, we can use the helper function createValue to create a store that is bound to the backend kernel. We can then show the unit variable next to the number, then also maybe add a text input to be able to update that variable. All we need to do to see our changes is run npm run build and refresh the page. We now see the new unit's description and can reactively update it with the text box, just as we did with the number. But if we try to access it from a Python cell, we get an error, since we have not updated the backend with our new variable. We can add our new variable to the backend in the example.py file. Variables in the Python code are represented by traitlets. which is an API for different data types. In this case, we create a Unicode traitlet since we're storing text, and we sync it to the front end. For changes to the Python code, we don't need to build anything. We just restart the kernel and run the cells again. Now, any changes in the Svelte component are synced with the backend, and any updates from the Python side are shown in the front end. The last convenient feature of using Svelte for Jupyter widgets is that you can use a development server for fast iteration. A whole Jupyter environment can be slow to load and refresh. If you're just changing the front end, you can actually just run npm run dev to run the Svelte component on its own. Like the normal Svelte dev server, any changes to the code are detected and the site is automatically refreshed. While this example widget is very simple, the Svelte widget framework can support complex projects and interfaces. A friend and PhD student in my lab, Venkat Sivaraman, is working in a project for comparing dimensionality reduction algorithms like PCA, TSNE, and UMAP. He originally created a standalone Svelte application with a few minor modifications made into a Svelte widget that can be used in Jupyter Notebook and Jupyter Labs. The tool is made up of multiple Svelte components and uses various imports like D3, just like you would do on a normal Svelte application. Data scientists can load the widget with their own data to compare embeddings and explore how data points move between them. To get started making your own Svelte widgets, check out the cookie cutter below, which has instructions and more details about the widget framework. Thank you so much for taking the time and listening to this talk. If you have any questions or suggestions, feel free to reach out. I'd love to hear them. And enjoy the rest of Svelte Summit.
Hey.
I was wholly unprepared for the dog at the end. That was fantastic.
Yeah, same here. So cute. Yeah, that seemed really nifty. I got to explore Jupyter. I've heard good things about it.
The interactive notebooks. Make it so easy to interact with the back end of the notebooks and then the front end.
I actually think that someone made a Svelte kind of thing called Alex that does something like that. Let's see if I can post it here in the chat.
I've not come across that.
Yeah, so all of these like interactive notebooky kind of things are super exciting.
Cool.
All right, next talk. So next up we have optimizing your Svelte community experience. That could be nice. Learn how to ask questions and get support.
Questions. Yeah, that's one of the best things about Svelte is the community is awesome, right?
Yeah.
The framework's awesome and it has the community to match. So super excited about this one.
Let's go. Let's see here.
Do you?
Oh, something went wrong there. My bad.
Hello, my name is Stefan Varese, and I've joined you here on the summit to show you how you can get the most out of the Svelte community. That means I will be showing you where to get support, namely Stack Overflow and Discord, and how you can format and phrase your questions to get the fastest response possible. But first, let's talk about GitHub. Sometimes people go to GitHub to ask for support. And then you get this. The Svelte team wants to keep GitHub for bugs and issues only, not for support. So, what can you find on GitHub? There is of course the Svelte repository itself, and the repository for SvelteKit, an excellent template to start working from, Svelte preprocess, which is used to easily add preprocesses for SAS, PostCSS, and others. The integrations repository links to a series of tools and guides to help you integrate Svelte with other technologies. And the RFCs, or requests for change, holds discussions about upcoming features and changes to the framework. They made excellent documentation and a tutorial. The docs are around 10,000 words and should take you about 2 hours to read and understand. The tutorial introduces you step by step to the core concepts of Svelte and also takes around 2 hours. Together, this is only 4 hours or a simple afternoon. There is no excuse to not do this. Another excellent tool provided by the team is the REPL. Here you can try out code and experiment with Svelte. If you log in with a GitHub account, you can also save your code for later and share it with others. Now, let's first look at Stack Overflow. To developers, this website probably doesn't need introduction. You ask a question and some random stranger elsewhere in the world who happens to know the answer will provide it to you. Tagging your question with Svelte, Svelte-Tree, SvelteKit, or some other combination will help other people to find it. It is important to note that due to the for now small community, there are not that many Svelte people active on Stack Overflow. This means you might have to wait a bit for an answer. Another option is Discord. Originally a chat application aimed at gamers, this platform is growing in popularity outside of games as well. If you go to the Svelte Discord, you'll find many channels and a lot of people. There are rarely moments that absolutely nobody is online. And this makes Discord a premium choice for many people to ask support questions. Just remember to ask in the correct channel. So how do you ask a question? Here is a 4-steps plan to do so. First off, give the right amount of detail. Sometimes people just go, "Help, I'm stuck. My code doesn't work. How to make this?" Other times, they spam the channel with a wall of text. When posting code, invest little time in learning how to format it. It is more pleasant to look at and contributes to a nicer atmosphere overall. You can simply surround your code with backticks and mark which language to use. For Svelte components, HTML works fine. This approach works very well for simple problems, but sometimes your issue is more complex, as several components talking to each other. For this, you can make a REPL and share it with the community. This allows them to see your code in action and fiddle around with it to offer you a solution. When sharing the link to a REPL, you can wrap it with angle brackets. That way, you do not spam the channel with the REPL preview. When sharing code, also try to reduce it to the minimum. It is unlikely all 20 components with thousands of lines of styling are required to understand your problem. In fact, trying to recreate your issue as simple as possible will often show you where you went wrong yourself. Also, give some context to what you are trying to do. Sometimes you are so focused on solving a problem, twisting it around and hacking away, that you do not realize your ultimate goal is easier achieved with another technique. Giving context to your problem might save you and everybody else hours in work and headaches. And finally, show where you are stuck and what you already tried. People are more likely to help somebody who has tried doing it by themselves first. This circles a bit back to point 1, where sometimes people ask how to do something without seemingly making any effort themselves. Here we have the 4 points again. Give the right amount of detail, share complex code with a REPL, give some context, and show what you already did. And of course, read the documentation and do the tutorial. Nobody likes answering questions that are literally in the tutorial. Here's also a quick recap of don'ts. And I want to stress again that everyone in the community is doing so on a voluntary basis. They all have lives outside of Svelte as well. So then tag or direct message people uninvited to get attention. I also want to quickly point out the Svelte Society website. Here you will find a collection of components, a cheat sheet, events, and a list of local groups around the world that also organize meetups and talks.
Okay, everyone, I'm being gentle. You can lower your volume now. All right, so what did you guys think about that talk?
You know, as a bench warmer for the Svelte team, I'm Robert Hall, by the way. I appreciate that talk. Everyone should watch that talk. Again.
Yeah, agreed. I really liked it. I love how he went up to the mountain.
Yeah, it's a good portrait of the community, and not to mention all the local meetups that are flowering everywhere in the world. We saw people from every part of the world in the chat, and I hope it will entice them to grow a local community as well and join the Discord.
Yeah. Yeah, the Discord is really, I think people underestimate how good the Discord is. It's really nice. It's a great community as well. So if you're not there, you should definitely join the Discord. All right. Are you guys ready for the next talk?
Ready.
Yeah.
All right. So the next talk is Svelte-NodeGUI. So it's a full talk, so it's going to be a bit longer. Yeah. So let's go.
I can teach you how to bewitch the mind and ensnare the senses. I can tell you how to bottle fame, brew glory, and even build cross-platform desktop apps with JavaScript. That's right. I'm talking about the hot new library, Svelte-NodeGUI. Put the logo up over there. This talk covers what is Svelte-NodeGUI, how do you set it up, how do you use it, does it have an architecture or something, how can I build my own Svelte renderer, and who is Jamie Birch anyway? Svelte-NodeGUI has over 2,000 stars on GitHub, so it must be good. But what is Svelte-NodeGUI? Well, it's a library that allows you to develop NodeGUI apps using Svelte, obviously. But what's NodeGUI? NodeGUI is a set of bindings between Node.js, that's the node, and Qt, that's the GUI. Together, you get a cross-platform desktop application framework that you code using JavaScript. Ooh, my favorite language. It feels much like developing for the browser, as it comes with things such as CSS and Flexbox. Sign me up. Come this way if you want to learn more. First, mosey on down to NodeGUI/Svelte-NodeGUI. Admire the number of GitHub stars, acknowledge the link to the documentation, and have a quick scroll down the README. It has links to the community on Spectrum, which will soon become the community on Discord. It also links off to React NodeGUI, Vue NodeGUI, but we don't talk about those. There's the logo. And it gives you a preview of how it looks on all the different platforms. Beautiful, don't you think? There's all sorts you can do with it, like putting coffee in a window, or finding out when it's going to be raining in Stockholm. Very nice. Anyway, let's go check out the documentation. So how do we get started? Well, if you've already set up your environment, you can go straight into the quick start, but if not, go through Learn the Basics and read through the Developer Environment section. This will take you through setting up things like CMake and GCC. It's different depending on whether you're setting up for macOS, Windows, or Linux. Anyway, once you've set all those things up, you can come back here to Quick Start. Following that through, you will find you need to clone the Svelte-NodeGUI starter template. Let's do that right now. I'm going to change directory to my doomed side projects. Next, I'm going to clone the Svelte-NodeGUI starter. That was quick. We'll go inside the Svelte-NodeGUI starter folder and install the dependencies. Let's get a big window for this. the first time you install NodeGUI, it may have to build Qt from scratch. This takes about 5 minutes. It's a good time to grab a cup of tea. This installation process may get faster in future, with the provision of pre-built binaries of NodeGUI. Having installed our dependencies, we can now run the Webpack build. And finally, in a new tab, start the app. Amazing. Oh rats, I need to go check on my potion. I'll hand over to Jamie from here.
Thanks, Professor. Good luck with that. From here, I'm going to give you all a lightning tour of the Svelte-NodeGUI development experience. We'll contrast it with Svelte for Web and get a sense of what it means to have Node as your JavaScript runtime rather than the browser. But first up, let's get an editor open. So Visual Studio Code has the best support for Svelte development, and I recommend that. We'll open up Visual Studio Code in the current directory and take it from here. As a web developer, this project structure should look pretty familiar. It's essentially a Svelte TypeScript project, though instead of using rollup as the bundler, it's using Webpack. Just as with Svelte for Web, your sources live in the source folder. However, your entry point is renamed to app.ts. In Svelte for Web, you specify a target element, such as document.body, to render your app component into, and some optional props to go with it. However, in Svelte-NodeGUI, document.body is a virtual element rather than a real element, and actually needs to be polyfilled into the Node runtime as well. So we provide this convenience function that will both polyfill document.body and render your app component into it. You can specify props for the component as usual via the second argument. The rest of the code down here you don't need to worry about. It's just some necessary stuff to support live reload and one-day hot module replacement. Now let's look at some component code. App.svelte is the container for the whole app. It makes sense to declare our main window here. So I'll go over what's involved in that. But first, let's have a look at the elements that we're trying to render, then go back and review the script that accompanies it later. Each primitive element in this markup expresses a wrapper around some Qt widget. So for example, the window element is a wrapper around the QMainWindow widget, and of course manages an application window. The view element is a wrapper around Qt's base widget, QWidget, and serves as a general purpose layout element like div does in HTML. Unlike div though, it only supports flexbox layout. We can also see the text element, which wraps QLabel, and of course finally in blue we have some nested Svelte components which behave just like they do in Svelte for Web. You can obtain a reference to any primitive element, allowing you to call imperative APIs on the underlying widget, just by using the usual Svelte bind syntax as we do here. Let's see how we use this. So let's quickly review our script block, which incidentally is written in TypeScript. We make a few imports, we initiate a variable which stores a Q icon, which we'll use later. And this is the important bit for the window. We create a variable that will be bound as soon as the Svelte onMount lifecycle runs. Now, ideally, we'd like to type it as NSV element rnWindow. For the curious, that stands for native script view element Reactive NodeGUI window, but that's internal architecture that I won't get into right now. However, the Svelte language tooling has a type conflict with that, so the best thing we can do for now is to type the variable as any, which it already implicitly is, and just reassert it later. Apart from the ref typings, the first gotcha to mention with window handling is that you need to store a reference to your window element somewhere that won't go out of scope to prevent it from being garbage collected, because when that happens, the window disappears. So that's why here we assign it to window, which is actually an alias to global, which would be more correct in Node.js, but anyway, that's what the template has. And that prevents it from disappearing. We also need to actually reveal the window because it's hidden by default. To do this, we first need to access the underlying widget, rn_window, via the wrapper class's native view property. This is how you get at the underlying Qt widget for all wrapper classes incidentally. We then call the show API on it to make it appear. Finally, for when the component is later on mounted, we need to return a callback to clean up any imperative actions we took on mount. This is technically unnecessary for the base level component of the app, but is good practice to get used to in case you start dealing with multiple windows. Here we clean up our reference to the window, our window upon the global this context, so that the widget can be garbage collected. And furthermore, hiding the window might also be necessary depending on your particular app logic, which would probably go something like, I assume it's called hide. Yeah, it's hide. So those are the gotchas with window management. Let's look at the gotchas with styling. Svelte-NodeGUI has various quirks with styling, which it inherits from Qt's own CSS implementation. So for one thing, element level styling must refer to the underlying Qt elements, such as QLabel, and not the wrapper elements, such as text that you'd actually be writing in the HTML syntax. So we can't, for example, write a rule for text as text color red, because although it satisfies the Svelte compiler, the Qt CSS implementation doesn't have text in its vocabulary. It's expecting QLabel. However, the Svelte compiler now is not happy with that because it doesn't see that you've used a QLabel above. So the best we can do is abandon scoped styles and go for global styles. That is really all we can do for the moment, though we hope that we can improve upon this in future, maybe with a preprocessor. Far more baffling is the quirk that certain CSS values need quotes around them. I'll have to demonstrate this to explain. First, let's clean up our old style and add a background color to one of our text elements to visualize the area it takes up. As you can see, it fills the full 100% width of the window. Now, what would happen if we were to set width to 50%? Well, you'd expect it to halve it, right? Wrong. Qt parses that as something else entirely. And so the correct way to write it is apparently by quoting it. This is really odd. I totally agree. So it's one of the first things I'd like to figure out and maybe get a preprocessor to implicitly put quotes in where needed. Contributions, of course, are desperately welcomed. Finally, I did write that classes are not supported yet. The strange thing is when I go to try to use a class right now, it does seem to work. So I don't know what I was talking about there. Maybe there's some more complex case of classes that isn't working, but just so you know, if classes aren't working for you, maybe it's a known problem, and maybe try another method such as inline styles. Of course, we do want CSS and styling to work seamlessly, so obviously these are issues that we intend to solve with time. Let's set this CSS back to normal and have a look at the nested components. So as a refresher, underneath the one.playAround component, we have the step 1 component, which is all of this stuff. Let's have a look at it. The step 1 component mainly demonstrates how we can display rich text with support for images by writing HTML into text elements. Note that this is not a web view. It only supports a subset of HTML4, but it's fun to think that you could create a rich text editor around this one element. For this image, we're simply supplying the source value as a data URL, as you can see here. Sharp-eyed viewers may be wondering why we've specified word wrap equals true, despite using line breaks in the text. Well, this is some smokes and mirrors to hide another issue that came to our attention recently. for certain camel-cased attributes like word wrap and read-only, but for some reason not all of them, because window title still works. The Svelte compiler rewrites them to lowercase before passing them on to a renderer, so it's unable to set the attribute properly. In summary, this actually does nothing, but the issue is being tracked and we hope to fix it in Svelte core. Back to Apple Svelte. The step 2 component renders a section below header number 2, debug, which is all of this bit here. Let's look at its code. Step 2 demonstrates two things: event handling and access to the platform via Node. It renders a button, which once clicked will open a URL in your web browser using the npm package open. Let's see that in action. Glorious! You may be wondering what a NodeGUI event looks like. Providing typings for these is another area of work still to be done, which may require changes to the Svelte language tools. But for the curious, the clicked event returns a boolean indicating whether an associated checkbox was checked or not. In this case, false, because it's just a regular button rather than a checkbox. Probably the last heads up to mention is with logic blocks. That is to say, if, each, and await. There's an issue at the moment with inserting and removing text nodes. That means that these may not work as expected right now, but I'll fix that soon enough. That should cover all aspects of getting started with Svelte-NodeGUI. As you may have gathered, it has a lot of rough edges at the moment, but they should all be fixed in time. Now, to help anyone interested in contributing towards fixes, and just as a matter of interest, I'd like at this point to go over the architecture. Svelte-NodeGUI's architecture consists of 3 layers, all working towards tricking Svelte into thinking it's rendering a web app as usual, despite the environment being totally different. At its base level is the NodeGUI part. All of this comes just by installing the NodeGUI npm package and all of its subdependencies. It consists of Qode, which is a light fork of Node that syncs its event loop with that of Qt, allowing you to call Qt functions synchronously. Next is Qt itself, and all of the Node.js bindings that let you call it via JavaScript. Last is Yoga, which provides Flexbox layout for all the Qt widgets. You can use NodeGUI by itself, but you'd have to be very familiar with Qt's APIs and happy to write code imperatively. To improve upon this, we implemented a DOM interface for it, allowing us to write with the hopefully more familiar DOM APIs. Of course, it's still just imperative at this level, so it's still not much fun to write apps with. The DOM interface consists of 2 parts. First, the React NodeGUI DOM. We reuse as much of React NodeGUI's existing DOM interface as possible to prevent reinventing the wheel. This implements all the basic operations of setting attributes and managing child elements for each of the NodeGUI widgets. However, we still need to do some extra work to implement basic concepts like document, element, and node, and this is where the NativeScript View DOM comes in. The NativeScript View DOM was designed for a similar purpose, and in fact an earlier version of it provides a basis for Svelte Native's DOM interface. I chose it mainly because I had used it before in one of my other projects, React NativeScript, so I felt familiar with it. The final layer is actually surprisingly thin. All it does is provide TypeScript typings and initialize the DOM interface. But with this, we have all the ingredients to render a NodeGUI app using Svelte. So the bulk of the work in Svelte NodeGUI, and indeed in any custom Svelte renderer, is creating that DOM interface. The cool thing about this is that it's common work that can be shared with any other DOM renderer, for example React DOM. So with some coordination, any non-DOM project can be adapted to all the major web UI frameworks. In the last section of this talk, I'd like to give some pointers about how one might go about creating their own Svelte custom renderer. So we'll make a basic text renderer, which transforms HTML into equivalent Markdown using Node.js. I've cloned the Svelte for Web starter template to use as a starting point, and have installed its dependencies. You can see I've already set the rollup build running. So I was thinking, let's just run it in Node rather than the browser and see what breaks first. Okay, let's see what we're dealing with here. Window is not defined. Okay, that's fairly predictable. I noticed that the thing that's accessing window is actually something to do with the live reload script. So to simplify things, let's just take that out of the rollup config altogether. Save that config, bring up the terminal again, and try running again. So yes, that does get us past the error. And now it's complaining about the fact that the document is not defined. So let's provide a placeholder for document, and I can see we're going to need document.body as well, and see if that gets us any further. Let's fold down this terminal, open main.js, and put something in. Okay, now we need to invent document.createEvent. So I had a look at the MDN docs for createEvent, and I think we could get away with an implementation like this for now. We take in a type param and we create a custom event class with that type. Let's save that and see how it goes. Okay, we're a bit further now. Now we need that event to implement init custom event. Let's just stub that out with a console log. Okay, we're further now. Next thing to implement is document.dispatch event. So as well as inventing dispatch event, we'll actually need to invent the concept of event targets. And I realized from reading the docs that document would have to inherit from it. So here's the implementation I came up with. Let's see where we are. So we set global.document to a new document. What is document? Well, it's a class that extends event target. Event target is a thing that implements dispatch event, which is a stub for now. And we've moved create event and the this.body assignment into document now. Let's see how it runs. And now that's very interesting because the next hurdle is to invent document.createElement. At this point, I stopped writing stubs and referred to the DOM spec. We don't need to implement all of it, so here's the subset that I ended up with. I rewrote my event from before to custom event, which extends event above. This is all just word for word from the specs. There's nothing special about it, just assigning fields. Event target from before remains unchanged. Then I moved on to node. I implemented enough of that just to manage the node hierarchy and text content so that Svelte can insert and remove nodes and update text. I then implemented just enough of text and character data above it to manage the data and whole text properties, which Svelte accesses when updating child text nodes. I implemented element so that we'd have support for attributes as well as CSS classes and element IDs. And finally, I added the following methods on document for creating events and nodes. We have create text node, create element, and create event. That was enough to get it to run to completion and log out the text content of the document body. So let's give that a run. Amazing. Now we're close to rendering some Markdown, but for an easy first step, let's render some HTML. Side note, I found a mistake. If we go to line 189, I've now added this in, which gets tag name working, which we'll need for HTML. So let's implement a new method on node over here, just above text content. And all this does is say, if you're a text node, return the data you've got. But if you're an element, return not only the data, but your HTML tag name and all the HTML recursively of the child nodes you have. What that translates into is a lovely readout from this. All on one line, we have the entire HTML for the app. Now, how can we make this output the corresponding Markdown instead? Well, first let's call this method getMarkdown, and we'll go to the implementation I've written in advance. For text nodes, we'll strip the leading white space. I think that gives a better result. And for element nodes, it's a bit involved. We'll have, just like an opening and closing tag, a prefix and suffix. For the section header elements, we will have a certain number of hashes as a prefix. For image and anchor elements, we'll strip out the link and then add these square brackets and an exclamation mark if necessary. Then for strong and emphasis elements, we'll have a certain number of asterisks. Finally, if the element lacks a next sibling, we'll add a line break. So we'll see how this goes. So that's really not that bad. It's clearly got room for work, but as a first attempt, it does the job. So I leave the rest of the viewer as homework. Thanks for watching. I'm Jamie Birch. There's no time left to say anything more than that, but if you want to find out more about me, you'll find me on Twitter and GitHub.
Oh, I thought that was a great topic.
Oh, hey.
Whoa. Wow. Wow, wow.
Wow, nice. What did you guys think?
I really enjoyed I'm surprised that we didn't just do the HTML and then use a library to convert into Markdown, but implemented the Markdown parser ourselves or serializer ourselves.
Yeah.
Yeah, I've seen this before.
That was a
It's too clever for me.
This is really difficult to do.
Yeah, definitely.
Where'd Kev go? Where's
This is what
Kev?
we do all conferences, right?
This has gone off the rails.
And we're only an hour in. All right, let's move on to the next talk. So next up we have Untangling Composition. That's going to be interesting. All right, let's go.
Hello, Internet. Today we're going to do a short yet deep dive into higher order components in Svelte. Ready? Let's go. My name is Isaac, and I'm a tech lead working for Pearson and located in Sydney, Australia. I lead a team of 8 engineers, and we all use Svelte in production for the last year or so, and loving it so far. I'm also the author of the library Svelte D&D Action, which is a drag and drop container for Svelte that you might want to check out. All the examples are available in the description of this video. Alright, so what is a high order component? Simply put, a high order component is a wrapper component that enhances a wrapped component in some way. There are 2 types of enhancements. Visual, which means that the high order component puts the wrapped component in some kind of a container or within some kind of layout, but doesn't communicate with it. It doesn't pass in any information. And functional, which means that it does pass in information, and that's usually done via props. Now, visual enhancement in Svelte is quite straightforward. You just use a slot, like you can see here. So we have this modal, which is the higher order component, and it displays this nice dialog box and the close button and the overlay. But the content, what you can see here, I am some content in a slot, is determined by whatever is passed in. As you can see here, I am some content in a slot, right? So we have the modal, we have the slotted element right here, and it's being displayed as a modal, as you would expect. This is pretty simple, but there is one tricky bit that's associated with it. And that happens when you want to dynamically style the slotted element. This is not supported out of the box, but can be done using CSS variables. We don't have enough time to cover it now, but I will include a bonus example that you can check out. So after we've seen that, let's look at some more complicated examples that include functional enhancement as well. Okay, so the example we're going to be looking at today is this mouse tracker higher order component. It does both visual and functional enhancement on the wrapped component. I'm going to show you 2 implementations. The first one is probably what you've seen in the Svelte tutorial. It uses a slot with slot props for the functional enhancement. Now, one thing we have to understand is that every time we define a higher order component that does functional enhancement, it defines a contract between itself and the wrapped component. In this case, the contract is I, the higher order component, am going to provide 2 props for you, the wrapped component, X and Y, which represent the mouse position at any given time. So we can see it in action. If we move the mouse around, see this cute cat image that follows the mouse around. And if we look at the cat, we can see that the cat indeed exposes X and Y, and it positions the image based on these X and Y. So it's pretty straightforward so far. Now, we also see visual enhancement, meaning the higher order component renders its own markup on the screen. In this case, it's these mouse coordinates that also get updated as I move the mouse around. We can see that happening here. And I even included an if block to show you that the higher order component can have its own prop and its own logic for its visual part. Now, as far as how the mouse coordinates get updated, you can see here the handle move function that just listens on the mouse move, and it's pretty straightforward. One surprising thing, and this is where it starts to be not so straightforward, is that when you look at this, if you're like me, you probably expect that the X and Y props are the same as these X and Y props, meaning that the higher order component passes them directly into the cat, the slotted component. But that's not the case. If you look at the app, which is putting both of them together right here, we can see this special syntax right here. What this means is that the app needs to be aware of all of the props that are passed into the slot. It says, okay, I take the prop called X and I rename it. In this case, I kept the same name to X. I take Y and I rename it to Y. And only after the app has done that, these X and Y become available to use within this scope, right here between the opening and closing tag. Then the app needs to take X and Y and pass them into the wrapped component right here. If I remove it, it will stop working. The cat doesn't show up anymore because now the cat does not receive any X and Y. Now this is interesting because it makes the app component or any component that consumes our higher order component some kind of a middleman that has to be aware of that contract between the higher order component and the wrapped component. If the contract changes, for example, if we add a Z coordinate, all of the consumers of the higher order component will need to change, not only all of the wrapped elements. So the app will need to change and do let Z, something like this, and any other thing that consumes the mouse tracker in order for it to be able to go in here. Right? In this case, it doesn't complain even though it does not exist, but I guess that's okay. Now, another thing to pay attention to is, let me revert this, event delegation. So you see that we listen, the app listens to a custom event called set, and it puts the event listener on the cat, which is the wrapped component. And as we click here, we'll see this alert. Now, if the higher order component is supposed to be a black box, which might not always be the case, but if it's supposed to be a black box, ideally I would want to be able to do this, so that the app doesn't necessarily need to know where this event is coming from. But if I try to do this, which the normal way to do that would be to use event delegation. So I go here and I say, yeah, I want to delegate the set event. This is not supported. And if I try and move it here, this does not work because the event does not cross the boundary of the slot. All right, so now I want to show you a different way of implementing the same thing. You can see that from the user perspective, it's exactly the same application. We have the cat, it follows the mouse. I can click this thing and get the alert. I see the mouse coordinates here updating. So it looks exactly the same, but the implementation of the higher order component is quite different. And it becomes noticeable immediately when we look at the app and the way it uses the higher order component. So this time around, we see that we have the mouse tracker here, but it's a flat structure. It has no children. The wrap component is passed in explicitly as a prop. As we said in the definition, right? A component that accepts another component, like a function that accepts another function. We also have a flat list of props. So all of the props, both the props that go to the higher order component and the ones that go into the wrap component, are being passed here into the mouse tracker. So the app doesn't necessarily know which one of them will be consumed by the mouse tracker, which one by the cat, Same goes for the event. So we saw that when we click, the app shows this alert, but it doesn't know that it comes from the cat. And if our mouse tracker would like to emit the event, in some cases, instead of the cat, the app wouldn't be able to tell the difference. So I'm not saying you always want this kind of abstraction, but when you do, it's very useful to know that this pattern exists. And the cat component is exactly the same. There's no difference. It's a copy-paste from the previous example. The difference happens here in our higher order component, the mouse tracker. So you can see that now this is being exported as a prop, the wrapped component, and it's being used here. Instead of having a slot, we have Svelte component, which just tells Svelte that whatever we got here should be treated as a Svelte component. We can pass props into it, and we can also enhance it with more props. In this case, it's X and Y, right? The X and Y that the cat expects, the contract that we have defined. Now here, I'll show you this trick in a second, but it's good to know that you can also simply spread $$ props if you don't mind passing in everything to the wrapped component. I think it's nicer to do it this way. And what I'm doing here, I'm just using the REST operator in order to only pass in the stuff that I'm not using in the higher order component. So we know that the higher order component uses these two, and we don't pass them in to whatever we wrap, just a little bit cleaner. So yeah, this is not documented as far as I know. And in some cases, it can give you a much nicer, much cleaner abstraction. When your higher order component wraps around some kind of a list or anything that has an each block, in my opinion, the syntax of slots with props becomes very confusing. So we can see an example here. This is a sortable list. And this is our higher order component right here. And this is the slotted element. And I remember seeing this for the first time, and I didn't understand how my list of items is represented here as a list. Yeah, I just saw one item here, and I saw this let item, but I didn't understand where it's coming from, and so on. So after we've seen the previous example, this might or might not look very clear to you. If you look at another way of doing it, which is this way, that uses the Svelte component, which I'll show you in a second, you'll see that the list looks like this. So we have the higher order component, and it gets a list of props, the item's data, the item component, and the event listener. And it's all flat. And in my opinion, it's way cleaner and way easier to reason about and understand. So like before, uses a Svelte component right here. And it passes in the item data that it got into the child component. And it works. All right, we've made it through to the other side. Thank you very much for listening. Feel free to reach out to me if you have any questions, and enjoy the rest of the conference.
All right.
Dollar
Not puppets
props
anymore.
Dollar props.
Yeah.
I have no idea about that.
Did you like the talk?
Yeah. I always found with Svelte the higher order components was just something that I never got really intuitively. But I think that helped having the 3 different examples, and also the cat example was just so cute. I just love the little picture.
Makes you focus a bit more, right?
Yeah, exactly. Focus on the cute cat.
Yeah.
I'm also really excited about the next talk, testing Svelte. In general, I find testing is one of those things that when you get a really good testing story, it means the library gets a much better story in terms of getting adopted by big companies and being used in more serious projects. I think that's something that's really exciting about Svelte, right? Is that it's just starting to get more and more kind of used in these bigger projects and bigger companies. So
yeah,
I'm
I just see always something people are asking for. How do I test yada yada with Svelte?
Yeah, absolutely.
Yeah. All right. So let's put on that talk. Exciting.
My name is Dmitry Vinik, and I'm a developer advocate on the Facebook open source team. Today we will talk about testing your Svelte app with Jest. So let's get started. All right, as I mentioned before, today we'll talk about testing Svelte with Jest. So the important question to ask, what developers like to do the most? Many will say drinking coffee, sleep, or more often than not, people will say it's coding. We'll focus our time on coding, but I hope that one day we'll really start focusing on testing more. And that's why we'll talk about Jest. Many people think of testing as an afterthought, something complex, tedious, but with projects like Jest, I'll be able to show you how quickly and easily you can test whatever web application you have, including Svelte. But I can't talk about testing without bringing up the test pyramid. It's a general guidance where you have a largest number of unit tests, where you're simply testing an isolated unit of work, a function, or you can even think of a component in your app. Then you have integration tests where you have multiple functions interacting with one another. And then you have end-to-end tests, actually going through user scenarios that your customers might go through when they're working with your app. The main reason why we think of it as a test pyramid is because, generally speaking, we consider unit tests to be the cheapest to run and to write. They are the fastest, but they give you the lowest level of confidence. Integration tests are a bit better, but ultimately end-to-end tests, top of the pyramid, they are usually the most expensive ones, the slowest, but also they give you the highest level of confidence. The reason why is because it's actual user scenarios that you have to implement here. I'm not going to go into details of what it looks like with Jest, and that's why we'll try to focus on this famous tweet saying that writing tests is important, but not too many, and mostly integrations. And that's why we'll try to take a look at testing Svelte, focusing on integration test with Jest. And for that, I'll try to do some demos. And the first demo will be around just simple DOM tests with Jest. Then we'll go into snapshot testing, and also we'll close with the end-to-end tests for Svelte with Jest. So let's get started. So first of all, I need to introduce you to the demo app. Demo app is fairly simple. It's a to-do list. You can add a new to-do item. You have 3 different states, 3 different buttons, all active and completed. It's basically filtering. For actual testing of Svelte with Jest, we need 3 main things. We will be using Jest, obviously, for testing as a test platform. Then we'll use the testing library for Svelte. It will allow us to render, to interact, press buttons, fire events, things of that sort. It all comes from testing library. And also we'll be using a nice Jest DOM package that will help us with some assertions like to be disabled, enabled, get access to the DOM elements directly without us writing those assertions ourselves. So a few nice utilities that you have to install. All right, now we're in our IDE in the VS Code. You can see I have a simple project. We go to source, we have an app, Svelte, we have components along with tests. First, we have a to-dos that combines all to-dos on the app. We have individual to-do items, but also we have filter buttons that you could see showing all active and completed items on the list. We'll begin with this simple component, and I'll show you how to test it using Jest, testing library, and Jest DOM. All right. First thing first, you have to create the test.js file that Jest will pick up automatically. We describe filter buttons, best name it as exactly as the component you're working with, even without the space. Now let's expand it. I'll have 2 different tests here. Basically, you use the render from testing library to render the component, and then you interact directly with the HTML that it produces. I retrieve container that holds the DOM that I need to work with, and I use the Jest DOM to find the text in the container HTML. In this case, I'm looking for text content all active and completed. To npm test, which simply just run in Jest. And here you can see that it found 2 tests, everything passed. But now let's actually make a change so our tests break. Now let's, instead of having all in the UI, let's change it to none and rerun our test. You can see it failed with very nice description. It says what exactly failed, what test failed. Now let's move on to the second type of test I wanted to cover. It's a snapshot test. So snapshot tests are exactly what they sound like. We render UI, we take a snapshot of that UI, and then we save it as a simple file and compare if anything changes. So let's say you change the text, you change the element hierarchy, it will be caught by a snapshot test. Again, we're describing filter buttons. Let's not have any spaces, so it's exactly the component we're working with. And we have 2 types of tests here. First test is the fact that it should render, the buttons should render. And it's as simple as render, filter buttons, and then basically expecting that your container matches the snapshot. And the second type of tests is a bit more elaborate, where it's similar. You render your component, but then You find a button, and in my case, I have to fire event, basically make an asynchronous code. But after clicking the button, I can take a snapshot of seeing how the UI would change. But now let's really run the test first. Everything succeeded because it's the very first run to generate those snapshots. And in here it's a single file for the single test suite. But let's change something in our UI once again. And instead of let's have none and rerun the tests, you can see the snapshots fail. It showed me exactly what has changed. And if I wanted to update it, I could simply do that. Or in my case, I would fix it. All right, that's basically the snapshot tests for Svelte. Whether, again, it's very similar to how you would do it in React or in Vue or most other frameworks as well. Now let's get going and see how the end-to-end tests with Jest can function. All right, so to show you, I'm gonna be using Puppeteer to run the browser, so I can actually see how the user would interact with the site. Puppeteer is an open source library that lets you interact with the headless browser, or in my case, I will be actually using it in the mode that's not headless. And I can see the browser being started and seeing how the app interacts with it. So in this case, I have my base URL, I have my Puppeteer that launches the site. I say slow-mo because I want to see exactly how the tests function. I initiate my page, and I want to make sure that I close things as well. So simple before and after closes. But here is for the test. For actually describing to-do list, I'll have the test where I want to make sure that I can add a new item to the list. So I can write the name of the to-do item and then press add and make sure it actually shows up on the list. Here, it's a bit more elaborate, but it's similar how you would use Puppeteer anywhere else. You go to a base URL, the localhost 5000, you find to-do app. In my case, I type the run test, which is basically the new to-do item. I press the button twice, it's basically the focus and the button press. And in this case, it's basically to find the new element on the to-do list. And ultimately, I want to make sure it has the name of my test. All right, you can see that it's opening, typing. I'm going to press add, and you can see that the number of items has increased. So that's the gist of it. Simple DOM test, snapshot test, and end-to-end test with your Svelte app while using Jest. So a quick call for action here is test your app. Don't just think of testing as an afterthought. It's going to give you confidence and a peace of mind. But don't overdo it. Don't have too many unit tests, even too many integration tests. And of course, don't go overboard with end-to-end tests. But more importantly, really contribute back to the projects. You know, all of the projects I've shown today are open source, including Svelte, Jest, testing library. If you're using them, please give back. That's about all. Thank you so much for listening. My name is Dmitry Vinnik, and you can go follow me on Twitter, go to my blog, LinkedIn, or email me directly if you have any questions or anything to discuss. Thank you so much.
All right. Testing.
Great.
Yeah.
I really liked it. I really liked that. I liked actually the really readable test output.
Yeah, testing is very
fantastic.
important. Definitely on any project. I remember when I was with Citigroup, actually, I headed a QA team, and we found a bug. And I had to fight for it because people were not believing us. You know, the dev team were not believing us, and eventually they did, and that actually saved the bank some embarrassment and yeah, money as well. So yeah, that's a very important subject. That's for sure.
Yeah, tests are nice. What kind of tests do you guys prefer? Just unit tests, or what's your favorite, Anthony?
Well, so personally, I do a lot of E2E, and
So
I do
Cypress?
E2E at different levels. Yeah, well, Cypress and a lot of just sort of mocker tests, basically just testing the back end. E2E being that I'll write the database and check that something's written there, just because it gives you the full flow. But I'll be honest, we're quite light on front end tests, so I might look at Jest because I really like the output, and I think that's the most important thing. I think just maintaining tests is hard always, but if it's readable, it gets a lot easier.
Definitely. All right. Are you guys excited for the next talk? It's declarative data visualization. It's a full talk. We're going to see some cool bar charts, I think. Let's see what's going to happen.
Hey, I'm Amelia,
And I'm Russell.
and we wanted to talk to you today about declarative data visualization. We both have a pretty long history building data viz using D3 to manipulate the DOM. And last year, we really hit our groove with building data viz using D3 and Svelte in a more declarative manner. And it's become a really nice workflow for us. We wanted to walk through an example, which is a bar chart race. We didn't want to get into all of the code and rewriting it. Some of it is fairly basic and might be a little bit boring for this talk, but we will link to the entire code base and you can walk through it at your leisure. We wanted to go through 4 things that were kind of game changers for us at a more high level. So looking forward to going through that. And Russell, do you want to walk us through what a bar chart race is?
Absolutely. So we chose to do a bar chart race because they became kind of like pop data viz a few years ago. It hit the mainstream, if you will. As you can see in Observable now, there's like over 700 notebooks that utilize it. And we chose to try to recreate this one by Mike Bostock, which Amelia can kind of break down as we play through it, how it works.
Yeah, so for this bar chart race, it's fairly simple. There's bars, each bar represents a brand, and they move back and forth with an X scale that represents the value of each company in millions of dollars. And as we can see at the bottom right, which shows the year, we're walking through different years to see kind of like which companies rise to the top, which companies fall off the list. It's all very exciting. And the different components are the bars, the labels for each bar, the year in the bottom right corner, and then the ticks, which give you the context of how many millions of dollars we're looking at here.
Yeah, and so we chose to recreate it with a different data set, something that was maybe a little more relevant to this audience. So we chose to use languages on the Stack Overflow and how many questions were asked about them each year. So as you can see, as we play through this, same look and feel. We maybe made a few aesthetic changes, but otherwise it's pretty much doing the same thing as the example we just showed. And we just added a few UI elements because it kind of comes a little bit for free with Svelte. Some of the things we'll talk about a little bit later. And so, yeah, we were excited to show you how we made this and some of the best practices that we learned with data visualization in Svelte. And before we jumped into the code itself, we figured we'd start off with a more high-level view of what the different components look like and how they fit together in our app.
All right, so here is a little schematic of the layout of our bar chart race. Each of these blue boxes is a component. So the biggest component that renders the rest of them is this big chart component, as we see in the background. And then the subcomponents that chart is directly rendering are bars, axis labels, ticker, which is that year in the bottom right corner, and timer, which controls the keyframes and kind of walking through those different years, which is why, so those blue texts with the arrow next to them are props that get passed from the parent into the component. And as you can see for timer, it has this bound prop called current keyframe, which it both receives from chart and updates. So that's what that kind of orange color and the bidirectional arrow is. And then the other kind of orienting bit here is that context is in pink, and we'll go into why we're using context to pass these down a little bit later. So anything in pink is context passed down from the chart. So not a direct prop, but still something that that component is getting from the chart component. All right, so the first thing we wanted to talk about was how to combine D3.js with Svelte.js. If you're unfamiliar, D3 is kind of the de facto library for creating data visualization on the web. As I said, Russell and I have a lot of experience using D3 only for creating really complex data visualizations And it's kind of like a big mind shift for going from using D3 to do everything, which is what most of the D3 examples do, to using D3 with a JavaScript framework like React or Svelte. So the first thing I wanted to say is a lot of people think they have to learn D3, and it's really overwhelming. So this is a visualization of the different parts of the D3.js API. So each of these bigger circles is an individual repo on GitHub, and they're all part of the, at least the purple ones are part of the core D3 bundle. And each of them is responsible for different types of things. So some of these are good at manipulating arrays and parsing your data. Some of them have color schemes for you to use on your data. Some of them are good at turning a geographical shape into a shape on your screen. Some of them are good at creating SVG shapes. So I think the mental model we want to get across is this is kind of just like a collection of really useful tools. And you can learn them one at a time. You don't have to learn D3, all of it all at once. You can kind of just like dabble a little bit whenever it's convenient for you. So first of all, don't be scared. Second of all, only 2 of these are solely devoted to manipulating the DOM. DOM stands for Document Object Model, I think, which is the structure of your web page. So there's the selection, so D3 select, and then there's selection multi, which isn't even in the core bundle, which is that tiny yellow dot at the top left. So these are the only ones that people use or with D3 to manipulate the DOM and to change what is on the page, which is the part that's really confusing because that's in D3 and it's also what Svelte wants to be responsible for. So when we combine D3 with Svelte, we end up just not using those 2 parts, and everything else in D3 we can use. Like we can manipulate arrays with it, we can format our numbers with it, we can, you know, format date times, use the colors, all of those things. So really the key to using D3 with Svelte is not using D3 selections, and you can pretty much use everything else. So that's the second point. So really the big takeaway here is just think of the D3 API as a collection of modules.
Yeah, so I like to think of it as like a Swiss Army knife, kind of like Lodash, where it has all these utilities and you don't need to know all of them. You just need to use the ones that you need for a certain little task or something. So, and kind of bringing that into our code, if you do a little search in our project that we've created, there's actually only 4 imports of D3, and we're only using 3 different functions from D3. So we're using it for formatting, scaling, and time parsing. So things that you could write on your own, but obviously D3 has got this down. It's its bread and butter. So a really nice thing about this way of just using pieces of D3 is that with tree shaking, the bundle size is going to be way smaller. So we don't have to load the whole D3 library as well. So that's it kind of in practice in our project. And I guess now, Amelia, you want to kind of take us through the declarative stuff that you were talking about a little more conceptually?
Yeah, so one of the reasons we really like to use D3 with Svelte or a JavaScript framework is when you write raw D3 code, you're writing it in kind of an imperative style. So you have to say, hey, computer, select this SVG, and then add some bars to it, and then add an axis. And if the data updates, then you also have to redraw these bars. And every step of the way, you're kind of telling the computer what to do and how to draw that data. Whereas if we look at our chart component, if we look at like what we're outputting in the HTML portion, we can look at this code and we'll know to some extent what the page is going to look like at the end. And this is more of a declarative fashion where we're saying, we don't care how you do it. Just make it so that the page has a figure and it has bars and it has an axis and all of these things. And it makes kind of a direct link between what you want and what's on the page. You don't kind of have to parse the JavaScript to see what you're drawing and figure out how to update that when the data updates. If you're doing it here with Svelte, it's just gonna look like this, and it's one less thing that you have to worry about.
Yeah, I think the nice thing about this for us is it feels a little more ergonomic, and it feels like it kind of lowers the stuff that you have to have as a mental model, because it is all, again, declaratively here. So if we just drill down, right, we know that the figure has some bars. What are bars? We look at that file. Well, bars is just clearly a loop through a bunch of bar components, which is what we can expect. And then we get down to the bottom, and it's actually just a div. So now it's kind of very clear to kind of trace what's being made where.
So often when you think data visualization, you think SVG. SVG is really great at drawing complicated shapes or circles, but it's not always necessary. And this is something that we find really helpful when we're creating data visualizations. Often when you look up something like a bar chart race or any D3 example, it's going to be an SVG, but we wanted to show that that's not always even helpful. So if we jump over to the code, we'll see that our bar chart example is built really just with divs. So for the bar, it's just one div. For the label, it's a div with some text inside of it. We have the name for the bar and the value. And then for the tick mark, it's pretty much the same thing. It's just a div with the line and then a value. So if we go back to the example, we'll see what that looks like. And we'll also see that we could have just put the labels inside of the bars, and it could have been some really easy positioning. There's some reasons we didn't do that, mostly because we started with SVG, and the stacking order gets a little complicated if we wanted the label on top of the tick mark. So I wanted to go a little into the pros and cons for SVG and HTML. And really just when you're creating data viz, use whatever is easiest for the problem. Even at the start, we had the bars as SVG rectangles and the text as HTML, so I'll often mix and match it. It's not really either or. So for SVG, it's really, really good at like complicated shapes, and the coordinate space, everything's basically absolutely positioned. So it starts in the top left and gets bigger as you go down into the right. And that coordinate space also scales really well. And there's little kind of aside things like adding stroke around text characters and adding complicated filters. But for anything else, really, HTML is a lot more ergonomic for web developers. It's what we're used to styling and coding. If you have a rectangle, HTML is great. It's really good at gradients. In SVG, you have to create a linear gradient and then use it, which is a little bit more work. Things like text wrapping, I'll always do tooltips in HTML and then absolutely position them on top of a chart. Stacking is easier because you can use z-index, which doesn't work in SVG. And a lot of things like images and responsive sizing. With SVG, you kind of need to know where everything lives and place it in the exact right place. But with HTML, you get like the responsive width and you can use, I don't know, it's just a lot easier. So here's our pros and cons list. I'm sure we're missing some things, but the basic takeaway is don't feel like you need to use SVG just because you're creating a chart.
All right, so the next thing we're going to talk about is data flow. So in terms of the data itself, we didn't do anything different than what you would do in D3 or any other environment, because there's nothing we get out of using Svelte specifically that changes that. So we'll talk more about how we pass the data around, because in Svelte, there are a handful of different ways of passing data around different components. that can sometimes end up being a little bit paralyzing in terms of which one you go with. But over the course of the last year, we've kind of come to a few different ways we'd like to do this that works best when creating data visualizations. So we'll jump into the code. And the first one we'll actually talk about is props. So this is kind of one of the first things you learn and one of the easier ones to get your head around. So it's really straightforward. So if we have our bars component and we want to know how many bars to render, we pass the prop bar count. This is very typical in other frameworks as well, and is really straightforward. The downside of this, and when we kind of sometimes want to get away from this, is there's a few reasons. So one, if you have a ton of props, if you don't want to put it in an object and you have to like list them out. So in this example, we have a few different props that we're passing. It can get really verbose. So it can get a little harder to just manage things visually in the code editor. And then it also just can make it a little bit more overhead to like instantiate a new component. So if you know you have to pass like a bunch of different things, that's just a lot more typing. So there are some ergonomics involved. So a big thing that we like to do that gets around this and also is just a little more conceptually clear is using context. So context is something that you can set once at the start, and it will pass kind of like cascading CSS, or thinking about it like an umbrella. It will pass that data down, and it's available to all child components, no matter how deep they are. Which is another thing. There's prop drilling where you can keep passing a property down through components, but again, you have to type that out each time. So with context, you can set it in the parent and it's just available in all the children. So you don't have to type it in a component. Each time it's just available to a child. And so, for example, here, we are just getting the context. So when the data changes, we know we can just use the data as is, and we know it's the same as in the parent. Something that we've kind of manipulated, or we've seen done a lot, and we love this kind of approach, is combining context with writable stores. Because when you do set context, it's fixed, you can't update it. So one thing we like to do is create these writable stores. So if there are stores within the context itself, as you see here, we have this dimensions property in our context, but dimensions itself is a store. So whenever dimensions updates and bars reference it doesn't here. So actually when the data updates, it's actually a store. So you see when we're rendering it here, we use the $sign for the shorthand reference to that store. It will automatically know it's changed and you can re-render it. So again, you don't have to manage the state and like make these update methods and stuff. It will just automatically subscribe to it. And another nice thing about this is because context is scoped, things can be a little more reusable, which Amelia, you want to kind of expand on?
Yeah, that's the gist of it. Is so if you have this convention with charts and you make a lot of charts, when you have an axis component, you can kind of just throw it in there and know that it will have access to context with dimensions and data. There's a few other things we had in there, but so anytime you have an axis, you can depend on it having scales. And then you can just use those scales within your reusable axis component and not have to, every time you put an axis in a chart, know that it needs to also be past the scales.
Okay, so the last piece of the puzzle here is talking about timing and animation, because everything we've showed thus far could just be done statically. But obviously the main thrust of the bar chart arrays is that it is animated. So this is a pretty crucial component and something that Svelte is really awesome with. So first, let's talk about how we handle the timing and how that kind of flows and controls things. So we created a timer component, which has a couple properties and this bound current keyframe thing. So let's take a look at the timer component. So the timer component does two main things. One, it actually does the internal figuring out when a certain duration is finished and like when we can move on, and that updates the keyframe that we're on. So that is kind of like the source of truth of where we're at in the data. And so pretty simply, whenever the keyframe should be updated, we just are kind of using math floor. So when we hit this next keyframe, it updates, and now chart knows that keyframe is different, and we can do all sorts of different stuff with the data because of the two-way binding. And then the only other thing that's happening in timer is, again, we mentioned there's a few GUI elements. So we've internalized them. So we can kind of handle the flow, like pausing and starting the timer from running, just handling it here with some user events. So that's kind of the gist of what's happening in timer. And let's jump over to how we actually have that manipulate the data. So we're doing a lot of reactivity and stuff in here, but Amelia, maybe you can walk us through how we're going about it and why.
Yeah, so timer is really responsible for the larger steps between the keyframes, but then we want to have a smooth transition for the bars between like a larger value and a smaller value. So what's doing that are these two tweens. So we're throwing xmax, which is the maximum x value, which is the % of questions on Stack Overflow, which really is going to change over time. So we want the bars to always be full width, but that full width could change. Say there's a smaller max percentage in 2008 than there is in 2020. We kind of move that smoothly. And the other thing we're tweening is data, which is interesting because it's an array of arrays. One thing we really like about tweens is that they work in a nested fashion as long as all of the values are tweenable and they stay consistent. So actually, no, our keyframes data is an array of arrays, but data, I think, is just a single array. So if we go down to where we're pulling that out down here, we're grabbing the current frame using the current keyframe, which is the one that's updating from timer. And we're setting our data on line, I think that's 47. So we're saying data set, and these are reactive statements. So whenever current data updates, then our data is being reset, and then it's going to tween for whatever duration we set in between that first value and that set of second values. And then the other interesting thing here is that we are also have a reactive statement setting the maximum x value, like we talked about before. But the fun thing here is that we're actually building that into our x scale. So every time that maximum x value changes, our scale tweens evenly between that first maximum x scale and the second one. And the nice thing about doing this on the scale directly is that our ticks are going to tween smoothly, our bars are going to tween smoothly, and our labels are going to tween smoothly. And we can be sure they're all going to tween together because they're all using that one scale. So tweens, we love them, they're great. The really important thing here is that we have that one duration that's getting passed to both timer and our tweens. Yeah, right there. So that every 300 milliseconds, it updates the keyframe, but it also takes 300 milliseconds to tween in between the previous and the next value.
There you go.
All right, so that was our talk. Just to recap really quickly on the 4 topics, the first one was D3 and Svelte. So when you're combining D3 and Svelte, or really any other JavaScript framework, the key is to let Svelte handle all the DOM manipulation and use D3 as a really powerful utility library. Our second topic was SVG versus HTML. Don't feel like you need to use SVG just because you're creating a data visualization. HTML is really great, especially if you're doing something rectangular or something with text.
The third topic was data flow. There's a ton of different ways to pass data around in your app, and we find that there's great use cases for everything, whether it's props or context or stores. So there's a bunch of different ways to wield those to make a powerful and easier to read and use data viz.
And our fourth topic was timers and animation. We mostly just wanted to share that a combination of intervals and tweens is a really good flow for a consistent animation that you also have control over.
Yeah, so that concludes our talk. All this code will be available on a GitHub repo that we'll share the link for. And just in case anyone out there is a Svelte developer or wants to get into contributing to Svelte, there are some really good issues that are still open around outro transitions and stuff, which would be a huge game changer for kind of doing a full conversion from D3 style joins to be able to do it more declaratively in Svelte. So we will also link to those if you are curious. That's it. Thank you.
Thanks, Al.
Can't hear you, Kev.
Oops. I did the old work from home Zoom mistake, muting myself. So what did you think about that?
Oh, I love that these two are getting into Svelte. I remember when, Russ and I go back, and we've worked on some projects in the past, and I remember when he first reached out to me and was like, "Hey, how do I do stuff in Svelte?" And I was like, "Oh yeah, you're getting into it."
That's great.
And
nice.
So yeah.
I really like the conversational style talk. It's really nice when they go back and forth.
Like I like that too. The first talk was that way also. Yeah, I think we should do more in the future.
Definitely. It's a lot more engaging as well.
Mm-hmm.
All right. So before we go to the next talk, I just want to remind everyone to, if they want to do the Meet Svelters Around the World thing during the lunch break, they should sign up to the Meetball link. It's pinned on YouTube at the comments. And it only works on desktop at the moment. So if you're on a phone, you should probably find a laptop or something. And I guess that's it. We'll move on to the next talk. So this is a talk where we get to hear some music. Exciting.
Oh, nice.
Yep. All right.
Everyone, I hope you are well and enjoying these inspirational talks here in the Svelte Summit 2021. My name is Francisco Bernardo. I am a postdoctoral researcher at the Experimental Music Technology Lab at the University of Sussex, and I'm delighted to be here to give you a lightning talk about the SEMA engine, a new technology that we're developing to support musical creativity, innovation, and live coding performance.
Specifically, we're going to talk about how we use the SEMA engine with Svelte and other components of the Svelte tooling ecosystem to build a full-fledged web playground for live coding, music, and machine learning. Here's some examples of languages that you can use and play in SEMA.
SEMA engine. First of all, it's infrastructural client-side code, or middleware, in the form of a JavaScript library built with Rollup. The SEMA engine has a concurrent architecture based on the Web Audio API, web workers, and shared array buffers to yield the best performance without interfering with the graphical rendering or the interactivity of the main JavaScript thread. Secondly, the SEMA engine is language technology. It provides a compiler and a meta-language for designing your custom domain-specific languages for audio and music. For that, you can specify language grammars using the Nearly Grammar Specification language and compile to high-performance JavaScript and WebAssembly code. Additionally, the SEMA engine provides machine learning libraries such as TensorFlow, Lalolib, and other numerical computing libraries, and user-friendly and useful ways to integrate them with your custom languages.
The SEMA engine was initially developed as an internal component of test applications and early versions of SEMA. There were no frameworks, no bundlers, just HTML, CSS, and vanilla JavaScript, 2 instances of CodeMirror, and an early version of the audio worklet-based engine. And TensorFlow was also linked with a script tag. Also, there was no intrinsic language design workflow. Instead, there was an independent process that users had to execute on their command line to compile a library for manual integration. In our first workshops and user study, we found that this process was considered very cumbersome and should be designed and integrated in the application. This led to a new workflow and more complexity of the UI architecture, with a new editor for the grammar specification and several panels for specific feedback and verification of errors. At this point, I started looking for a framework. It should be aligned with the principles of our tool, a real-time music instrument, and a design tool too. It had to be fast, lightweight, and load fast. It should provide a gentle learning curve to be picked up easily by newcomers in the developer community. And they shouldn't have specialized knowledge of JSX, but general JavaScript, which would be much easier to find. My previous experience with React and Redux, they left me unimpressed with all the boilerplate and idiomatic JavaScript, although I thought that modularity and functional components were a must-have. And around that time, I found that inspirational talk by Rich Harris, Rethinking Reactivity, and I found out about Svelte and Svelte components like Svelte Grid and other elements of the Svelte tooling ecosystem, such as Routify. So now, SEMA is a single-page application with Routify handling the client-side routing between the main pages Playground, Tutorial, Docs, and About. The Playground page offers a free-form exploration dashboard of components, which is very flexible, fully customizable, and offers commands that allow the user to spawn dashboard items. This is supported by the Svelte Grid component. All dashboard items are Svelte components. For example, the specialized code editors for the live coding languages, machine learning, and grammar specification are instances of the code editor code mirror wrapped as a Svelte component. Additionally, there are audio analyzers that render the waveform and the FFT to a canvas, and debugger tools for instant feedback and error reporting about each editor coding process. The last version, which is still on the mic, adds state management for the playground, and the tutorial is a more constrained environment that follows a table of contents, and it's inspired by the Svelte tutorial, enables the user to have a more friendly learning experience. Without going much into depth about the internals, it might be interesting to note that each editor spawns its own worker with a specific processing and utilizes either the stars to sync up and get synced up about SAMA's application state, or the shared array buffers in case of high throughput data streams. There are UML sequence diagrams in the repo for whomever is curious about that. In the end, SAMA is mostly a shell, a projection of all the features that the SAMA engine exposes.
More to talk about the SAMA engine and SAMA. If you'd like to reach out after the Svelte Summit, you can do it through the SAMA community Discord channel. You can find the link on the sama.code's about page. Thank you for your attention and stay well. And happy live coding!
That was super awesome.
Yeah, that was fun. Music is not something I'm very knowledgeable about.
Yeah, I'm not very musical in my bones, but I enjoy listening to good music, but I just can't make it for those.
Yeah. Yeah. Pretty much the same.
I love web audio. You can do so many awesome things with it. And then you compile your WebAssembly and then you've just got really high performance audio stuff in the browser. It's just great.
Yeah.
Yeah.
It's cool music as well. Like I like the chip tuniness. I don't know. Is that
I couldn't really comment.
I don't know
think someone in the YouTube chat said that, but I couldn't say.
Yeah.
So we've got
nice.
Meatball now,
yep.
right?
I'm gonna drop the link again in the chat for people.
Yeah, Meatball's really, really awesome. So if you're not sure if you should sign up, you can like quit at any time. So don't feel like you're getting forced into something. But basically you get to hang out with a bunch of other Svelters just one-on-one, and then it takes you through some questions, and then you go and meet the next person. Yeah,
it's nice.
It's great.
So that's going to start in about 10 minutes. So if that's something you're interested in, just make sure you're logged in and just go to the meeting and just wait. That should be it.
Just click the link again, even if you've already signed up, and it should take you to a thing. It'll say you can join in 10 minutes or so, and then go make yourself a cup of tea or coffee or make some food or something.
That sounds good.
Cool.
All right. Cool. I'll put on
see you all on Meatball.
Yeah. And we'll be back. Oh, yeah. We'll be back at, let's see here. So 45 minutes past. So in 45 minutes or so. All right.
Good.
Take care.
Hey.
Hey.
What did you get up to in your break then?
Well, I had the meatball experience, of course.
Yeah,
What,
of course.
what about you?
Yeah, I did a bit of meatball, and then I went off to get a snack because it's a bit late here for not having had lunch. So
yeah, it was great.
Hey, Green.
Yeah, I did a bit of meatball, and then I went off to get a.
Oh. Did we caught you off guard there, Karine?
I couldn't get paired with someone, but
Oh, that sucks. Yeah. I got to meet like I think I did 5 or 6
really
pairs.
from
Yeah,
around the world.
Yeah.
Wow.
Yeah. So I met some guy from Alabama. I think 2 people from France, and what was the other one? Yeah, I met Andrew, but we met before, so that doesn't count. Yeah.
Can I just say, Karine, there's some, I think, modern etiquette, which is if there is an animal in the frame, the animal has to be introduced. It looks like there's a cat behind you.
Okay.
What's the name of the cat? I'm sorry, when I see a cat, I need to.
The name is Yahoo, like the search engine.
Oh, I see.
I believe my cat geek names. Wow.
Sure.
All right. So are we excited about the next talk?
Yeah, compiling, right? I was reading some YouTube comments earlier, and they were saying they were scared of compiling. So there you go. Go in the Svelte community and learn how to compile. So.
Exactly. All right. Let's see.
Hi, my name is Miguel Camba. I am a senior software developer at TalkJar, a digital agency that has been doing some interesting things with Svelte lately. So the title of this talk is Svelte Can Compile and so can you. But before getting to the topic, let's start with a story. I was building my first non-trivial Svelte app, and so far I was delighted with the experience. The developer experience was nice, the app was very fast, very responsive, the code looked concise and understandable. And also when I look at the network tab, I saw something like this. The entire app was less than 40 kilobytes of JavaScript, and this was a medium-sized app, and that was including 7 kilobytes of inline SVGs, which is extremely impressive considering a previous attempt on a different framework was well over 200 kilobytes. So you can imagine, I was very, very happy. There was only one feature left to add on the app, and that was internalization. So I thought, okay, let's research the libraries and pick the most popular one and carry on. And when I did, this is what I found. Just by adding an internalization library and maybe 30 keys, my app grew from less than 40 to more than 50. That was almost a 30% increment over the original size, and that was again with very, very little keys, very, very few keys. So I wonder, okay, this is surprising. How come an app, by just adding this library, can grow so much? What is making it so expensive? At first I thought that maybe I was doing something wrong. Maybe it was the library I chose that was particularly big. And that wasn't the case. Or I tried some other alternatives and they all move around the same numbers. Then I thought, okay, maybe I am including every language for every person, despite of only needed one. But that wasn't the case as well either. I was including only one language and I was lazy loading the rest. So then it struck me, it's not that this library is very big, it's that libraries of this kind has always been this big. And it's only now that I realize, because Svelte apps are very, very small and optimized, so it suddenly becomes evident that they are surprisingly big. And why they're so big? I started digging into how these kind of libraries work, and it's always the same. When you ask a library to translate a key, that key is looked up on a dictionary to get the ICU string for that key, and then that string is passed to a parser and tokenizer functions that generate some abstract representation that is then passed into an evaluator and fed with variable arguments, so it can generate the actual string you see on the screen. And all of this is pretty complex and expensive because this happens at runtime. And I thought that there was no need for this to happen at runtime. I thought, why are Svelte apps so fast and so small? And the reason is that Svelte analyzes and compiles your app at build time, so it can ship only the minimum amount of code that your app requires. And I thought this was a natural fit for internalization libraries. We can analyze them in backend, at build time. So if Svelte can compile entire apps, we can also compile, even if it's just ICU strings, into something we can run on the browser. So I want to introduce to Svelte Intel Precompile. It's a new internalization library built for Svelte. Its API is 100% compatible with Svelte 18N, which is one of the most popular 18N libraries for Svelte. It supports all the features of the ICU message syntax, and is built on top of the Intel API present in the browser and Node natively. So it can format dates, number, currencies, and whatnot. And like Svelte, it's not actually as much as a library as it is a compiler. So let's check out how it works. This is a classical example of an internalization with some logic in it. You have count, which is a given argument. We have plural, which is a helper. We have the three possible paths that this translation can go depending on the value of count. And we have static bits that are in blue, like I have no cats, one cat, and the number of cats. So at build time with a Babel plugin, it's very easy for us to get this string, tokenize it, parse it, and then output an inline function that we can invoke directly from our app. And it's going to be extremely efficient because it's just a function call, instead of having to go through a parse step and an evaluator function after that. We just call a function. That's perfect. And even better, it's not only saving us from shipping a parser to the browser and having to parse things in runtime. Once this is passed through a minifier, it becomes extremely compact. So compact that if you look at this and remember how long the original string was, the result is actually smaller than the ICU string this thing came from. So it's a win-win situation. The results were even better than I anticipated. For a baseline app of around 12.5 kilobytes with no internalization library, adding Svelte Intel Precompile barely adds 2 kilobytes to the final bundle, and that is including the translations, whereas Svelte 18N adds more than 40 kilobytes, almost more than doubling the size of the original app. And it's also extremely fast in runtime because it can skip completely the parsing step for rendering strings. So on first paint, it's 2.6 times faster. On render, for rendering new keys, that is keys that haven't been seen before on the page and haven't been cached, it's 4 times faster. And re-rendering cache keys that has already been parsed is still 25% faster because it doesn't have to go through a more complex evaluator function. So this is a proof that the Svelte ideas can be applied to other domains of web development, yielding very similar amazing benefits of extreme performance and minimal bundle size. So that's what I have. I want you to give it a go. Let me know what you think. This is the link where you can find it. It works on SvelteKit right now. And thanks.
That was
Hey.
cool.
Right?
It's just like a little
Awesome.
bit more code, and suddenly everything's faster and better and shinier.
Yeah. Yeah, I really liked it. So this wasn't the compile session that you thought it was, right?
Yeah, I think that's true.
Yeah. But that one
with the agenda.
Yeah, it happens. So I think next up we have Fred Schott with Svelte without the JavaScript. I think that could be a lot of fun.
Yeah,
So
we'll just replace it all with TypeScript instead.
Sorry?
Just replace it all with TypeScript instead.
Yeah. All right. Let's see what it's about.
My name is Fred Schott, and I'm really excited to show you a sneak preview of Astro, Svelte without JavaScript. This is something that I've been working on for a while now, and I'm really excited to share it because I think it's a really interesting approach and a new take on what it means to build a website in 2021. You might know me from my work on Snowpack, if you've used Snowpack. If you haven't, it's a better, a more modern take on web tooling that helps you get up to speed faster and make faster changes without a lot of wait time. The other project that I really love is Skypack, which is a new take on a JavaScript CDN, which lets you stream down NPM packages without a lot of bundling processing on your end, essentially on-demand NPM packages without no tooling needed. Obviously, I love JavaScript tooling, if that's not clear. And this is a really cool new kind of entry in the tooling space because we're not necessarily just bringing ESM or bringing some modern tech to how you build a website, but we're actually revisiting what it even means to build a website in 2021. So there's some really cool, maybe even controversial, interesting ideas here, and I'm excited to get this out there and see what y'all think. The TLDR 30-second summary of what Astro is that Astro is a modern take on server-side rendering for your website. This is, and I say with an asterisk here because there are no new ideas. I'm not claiming that we've reimagined everything, but we are bringing some old ideas into the mix and seeing if they have a place in modern development to help you build a faster website. By looking at this space, this problem of how do we server-side render and send HTML to the user faster. So I'm really excited to dig into what I mean there. One of my favorite things about Astro that we really wanted to get right was this idea of bringing your own framework. So it's Svelte Summit. I got to give our love to Svelte and the Svelte framework. Astro comes with first-class support for Svelte, in addition to others like React, Vue, Web Components. This is a really cool model because it means that you don't need to kind of throw out everything you know. You can bring your favorite framework to Astro and use that, and there's not a lot to learn on top of that. It's really a bring your own kind of skill set and whatever you feel comfortable with to us, and we will build a website for you. What are we building is the really interesting thing here, because what we want to do with Astro is make it easy, drop dead easy, for you to build sites with zero client-side JavaScript by default. So instead of thinking about how do I optimize or how do I make sure I'm rendering and all of these different things that go into shipping a modern JavaScript app, we want to flip that and look at what it would take to build a modern website using zero client-side JavaScript by default. We do this by being one of the first web frameworks to implement something called islands architecture. And then the feature that gives us zero JavaScript by default is something called partial hydration. That's essentially the secret sauce and the magic of Astro and how we can deliver this without a ton of extra work on your end as a developer. So partial hydration, islands architecture, throwing a lot of terms out there. What does it all mean? Islands architecture is actually a term coined by Jason Miller from Preact and at Google. Jason, about a year ago or so, wrote this article called, or really a blog post digging into island architecture. And it was a term that he'd seen around, but maybe not ideologically defined. It was kind of a loose term for this idea of a website that had been kind of, not forgotten, but certainly fallen out of fashion with the rise of Next.js and this idea of a web application builder. Island architecture is essentially the idea of treating your application not as one big, or sorry, see, I even did it there, treating your website not as one big application, but as a series of components on the page. It's already how we're thinking about sites. We build in components, whether they're React or Svelte. But this is really taking a look at what you're shipping to the browser, not just being, okay, here's my big application, but more a document containing these components. This image, I think, sums it up really nicely because what you have here is a page, right? And it has a header, it has a sidebar. Some of these things are dynamic, but some of them are also totally static, right? How much of our page really is fully dynamic and fully needs a lot of JavaScript to run? This is the interesting approach of Islands architecture, which is that if you don't need JavaScript to render a part of your site, any sort of island here, we just don't send it. We server render the HTML and send it to the user, and that's the end of that story. If there is some sort of dynamic behavior, well, then we treat that as almost an island on your page, a isolated rendering component. And what's really nice about that is, A, obviously you're opting in, so there's not a lot of unexpected or unnecessary JavaScript being sent. But also because these are isolated from each other, you're not actually paying a huge cost to render that is shared across them. Each component, an island, essentially pays its own price to load. So you can think here in this example, the header being a really lightweight, maybe you hover over the search bar in the header and confetti shoots out. And then in that same app and on that same page, maybe the image carousel is like this really heavy, hundreds of kilobytes, maybe even a full megabyte of JavaScript that needs to load. In a traditional world, your whole page is thought of as hydrating, and the cost of downloading that onto the browser would be shared across all components. There'd be that sort of uncanny valley where the HTML had been delivered, but the site wasn't actually functional. In this world, in the world of island architecture, each component on the page renders individually, which means they're non-blocking. So a really lightweight header would be hydrated and become dynamic as soon as that had loaded, while the image carousel would take its time to hydrate and wouldn't block necessarily the rest of the page. So this is a really nice architecture for a site, because you're not taking a lot of complexity and jamming it into your entire page, and one component can block the rendering of something else. Instead, everything kind of pays its own way. A heavy image carousel obviously slows down your site, but it doesn't necessarily block the rest of it from loading. And partial hydration, again, is this idea of partially hydrating the page. So really what I'm talking about here is partial hydration. But we take it to the kind of full vision, which is that the user is only getting HTML. And then you're partially hydrating different parts of your site without having to send down the entire JavaScript app that rendered that page. So you're opting in the Svelte world to different Svelte components on the page without paying the full price of the entire page itself and every single thing that might have contributed to your final HTML. The result there is obviously a much lighter payload for the user, and really what we care about is a faster experience for the user. Components hydrating, paying their own way, and not being bogged down by one maybe heavy component or the sum of all things loading at once, blocking everything in that kind of larger way. And really what we're conceptually getting at, if we take one step back from there, is this idea of challenging the foundation of what we're building here. Islands architecture, partial hydration, and Astro as a framework are all taking the stance that there's a lot of cool stuff when you start to think of static HTML as the foundation of what you're building. And the full web application framework world of Next.js or a SvelteKit or Sapper, they obviously get a ton of power out of JavaScript, right? It's the scripting language for the web, so anything that you might want to add to your site, routing, translations, full SSR engines for an entire application, there's all of this power that comes from thinking in JavaScript as your foundation, right? Svelte is a framework for JavaScript components. But static HTML is this really, it's kind of the perfect thing to send to the user when you can, right? It doesn't need to be executed. It doesn't need to be parsed and turned into something that can be run. It's the most efficient way to get the user content that they can show and see in their browser as quickly as possible. And so we're trying to fill the gap here or bring these two ideas together, that what if there was a way to get the expression and power of JavaScript, but the speed of a site that is just sending static HTML down the wire? Is there some way to bring those two ideas together? And conceptually what we're talking about is this idea of web applications versus websites. And we're starting to get into the world of terminology and naming, and you could define these in many different ways. But what I really mean by this this difference here that we're looking at is a web application being this JavaScript application, and thinking of what you're building as a JavaScript application. There is, again, a ton of power to thinking that way, because you can think about applications having a lot of power, flexibility, expressiveness. But what the user sees at the end of the day is a page, right? They come to your site and they want to see content. Obviously, depending on what you're building, maybe it's a full application, or maybe it's really just about that content being loaded and looked at, interacted with. It all depends on what you're building, but the user primarily wants something to look at, and they want content. And when you start to think in the world of applications, well, now you have a really complicated problem on your hands. How do you ship a slice of a larger application to the user? And how do you do that performantly? And how do you do that efficiently? And at the end of the day, in a way that's fast, and the user doesn't even, they don't want to feel like, oh, a loading screen and the application loading just because they wanted, a fun top 10 list or something that they wanted on their phone or on their lower powered device. So the world of web applications is a super powerful world, but it's a world of complexity. It's a world of how do we optimize this application to not feel like an application to the user, but to feel like many disparate pages loading as quickly as possible. And to be fair, again, I cannot stress enough how much power you get out of the web application model. 11D and Hugo and different static site generators are probably the best website builders that I can think of. Which if you haven't used them, they're static site generators. So they help you build, take your content and create HTML and CSS, usually from something like Markdown. The problem with them is that they get that speed, right? Some of the fastest sites are built with those types of site builders because it's so HTML focused. But the end result is that if you want to start building more dynamic content, bringing a modern dev environment for JavaScript into those sites, you end up smashing two tools together, right? You have 11D responsible for the site building, but then they're just, hands off. We don't really do JavaScript. That's not really our thing. And as a result, you then have to bring something like Snowpack or a traditional bundler to try to bring a modern JavaScript dev environment into this world of static HTML. So we, for our own doc site on snowpack.dev, use 11D and it's great, but we also want some JavaScript, so we bring Snowpack in, and you can feel the edges where these two tools collide. It's not the same seamless experience that you come to expect from a SvelteKit or a Next.js. So this is where Astro finds itself. There's these kind of bigger questions going on here as these web application frameworks become more established, which is this the best we can do? Is there a way to get this power, but without the complexity of trying to make it performant, right? Can we get the expression and the power of JavaScript web applications with the speed and simplicity of essentially generating HTML documents and sending them to the user? This is where Astro finds itself, and Astro is our attempt to answer this question for developers, to challenge the kind of hierarchy of how we think of websites today, with web applications being super powerful and web sites being really kind of rudimentary and simple. Is there a better way to think about what we're building that doesn't force us to bring in that complexity of the web application, and instead lets us think more like a website, but with all of our favorite, what we've come to expect from a modern dev environment? So I'm done yapping. Let's get to the demo, and I'll show off what Astro is. All right, so let's jump into the demo. What we have here and what we're going to build is the premier Muppets blog on the planet. All things Muppets, all the hits, all the movies. This is our demo app where I'm going to show off what Astro can do. And we don't actually have this yet, so I'll spin up the dev server and we'll refresh, and here's where we're at. So let's build our way up to become the best Muppets blog in the world. Because performance is so important, I'm going to spin up the network panel and just have this open so you can kind of see, again, a lot of the pitch is zero JavaScript, and I want to show you with this panel that is what's happening. No JavaScript. With a site this simple, it's really just the HTML coming down the wire. Zero JavaScript. So every Astro project essentially has two different directories. The first is your public directory for your kind of just assets. Some images here. We got all the Muppets are here. We got all the good ones. This is just where sort of assets live. The Astro directory, and I gotta get Kermit off the screen. There. Whew, okay. The Astro directory is where all the content lives. And so what we have here are components, some data, layouts, and pages. And this is primarily where the sort of magic of Astro is. So we'll start in pages. We use file-based routing, so similar to others, right? Anything inside of pages maps to its URL in your site. So index.astro would be the homepage, right? Your index. Now you might right off the bat notice .astro. What's that? That's our file extension for an Astro file. As you see here, an Astro file is really just HTML, but it's a superset of it. So we're going to extend the language in a couple ways. But the big distinction here is that we're not compiling this to JavaScript or anything more complicated than just, at the end of the day, you get HTML. So we're staying true to that vision. But yeah, as you can see here, right? Hello world in an H1, and that's what you got on the site. Now let's bring some of that expressiveness of JavaScript into Astro and see what that looks like. Similar to Svelte, we have an idea of a component script, although we do ours a little bit differently. In Astro, it'll be something a lot like front matter here, where inside of this, you can write as much JS as you'd like. This does not get sent to the client. This is fully server-side scripting. So this defines the behavior of something that at the end of the day will be compiled to HTML and sent to the client. So even though we have some, and we'll even, like let's bring in a title equals, we'll just copy this in. Right, this only lives and serves to help you generate your HTML. And similar to Svelte or JSX, you can include variables in your final HTML. So you can see here now that the head, and we'll add a little exclamation mark so you can see that it happened. There you go. And again, no JavaScript, this is the component server side. You can also, though, and speaking of components, use components. So similar to a Svelte, you can import something, and let's go ahead and import our site header that we're going to use. So you can see here we have a nav.astro. Let's import nav from the components directory. What's really nice about this is we're fully ESM, and just like you can use a variable in an expression here, you can also include a component on your page. So let's bring in the nav component. And just like that, we have some HTML and CSS coming from this component. There's not a lot of screen real estate right now on in the window, but you can see here that, again, an Astro component is the same as a page. They're one and the same, and it's just HTML, and here we have some styles. A couple of cool things to point out. One is that we have Sass support built in by default, so you just add this lang tag attribute to enable that. Do all the kind of sassy things you want to do there. The other is that this, just like Svelte, has that scope CSS built in by default. So you can define classes here and rules for those classes without worrying about this somehow bleeding out of the component. By default, the CSS is scoped, so you don't have to worry about that. You can see this nav component being used now, so we got it on the page. That's great. But this is Svelte Summit, so let's bring in some Svelte and show you. I pitched first-class Svelte support, but also zero JavaScript to the client. What does that mean? Let's just jump into it because this is one of my favorite things. So import in, you can see here we have a counter Svelte component. Really straightforward. I think I grabbed this maybe from the doc site, right? It's just going to give us a simple counter and a button to click to increase that counter. So let's import that. Components.counter.svelte. I'll shrink this just a bit so we have more screen. There we go, look at that. Give ourselves a little more room here. Okay, now nothing's gonna happen because, oh, what do we have here? I spelled it wrong. There we go. We haven't added to the page, so let's add it here. And we can just remove this hello world now that we've kind of got some content on the page. Aha, there's our Svelte counter. Now, the obvious kind of WTF moment is, wait, this is interactive, right? You said zero JavaScript on the client. I see zero JavaScript. that would be evil web magic to say that this would somehow work, and you'd be right. So most components, right, aren't going to have a lot of interactivity, right? Their content, their layout, their CSS, their structure. But obviously some things do have interactivity. We can't just say we're only building zero JavaScript. JavaScript is an essential part of the web. And so what we do here is we actually have the ability to, again, opt in components, right? This component needs functionality. So what do we do? In this case, we're going to just add, you can think of this like a pragma, a modifier to the counter component that says we actually do want to load this on the client. And when I refresh this, you'll see a couple things. One, the button works, which is great. And I'll just make this bigger. All the glory of this button and its unstyled beauty. But also you can see we've now shipped some JavaScript to the browser to make this work. This is development, so this is unbundled. You'll see a lot more files here than you would in production. But in production, this would essentially be the counter.js, right? This would be the JS that's needed to run this component. But that's not all. So here's my favorite part about this is you can customize this behavior, right? Because, okay, loading on the page, that's great. But you can also set it to idle so that only hydrates once the browser has finished loading. So the content loads and then the JavaScript loads after. That's really cool. But here's the best part. So we also have visible. This has this idea of hydrating only once it becomes visible in the browser. So obviously, first load above the fold, it immediately interactive. But let's just be silly here and put a bunch of these line breaks and breakpoints, and I can't remember what BR stands for. Again, this shows how out of HTML we've been. But essentially, let's add some vertical space. I just know someone's watching this should be like, I know what it stands for. I'm sure the Discord chat is like blowing up. Please tell me what it means. Okay, but you can see now we've refreshed the page and there is zero JavaScript loaded. So again, we're back to the world of zero JavaScript. But as I scroll here and once it comes into view, boom, rendered. And actually that wasn't a good example. It's always rendered on the page. Good distinction. It kind of came out. I wonder if I can like really just tease it. It's loading too fast. We ship the placeholder regardless, but then we hydrate it once that comes into the frame. So you can see here that once we, before, nothing, and then once we scroll down, it appears. And again, this is by component, right? So you could essentially build your whole app with this, and if you had that expensive image carousel, right, that we talked about at the beginning, under the fold, it's not going to block your site. So this is a really cool idea of using intersection observers automatically to give you this kind of zero JS experience. Obviously, we ship some JS to power the intersection observer, so it's not fully zero JS, but it's inlined into the HTML. You can even see it here inside the body here, right? We have this idea of a script here that essentially sets up the intersection observer for you. It's inline, pretty lightweight, and it doesn't trigger a new request until that visibility is achieved. There's a ton of cool stuff here. I'm running out of time, so I don't have that much to show other, obviously there's a lot more that goes into a blog here. How we use Markdown is really cool because you can essentially load any one of these. Okay, let me see. I'm gonna copy and paste a couple of things just to get us here. For this, we have this idea of Astro, similar to Deno, if you've seen Deno, having a kind of global that we can access for a lot of different Astro things. In this case, we're going to load all the posts. So let's get rid of some of this, and we'll keep our counter just for fun. But then let's, what we've done here is we've fetched all of our posts. So again, we're a blog. We want to have a list of content here. And then, again, I think I'm going to steal a component here for this, but I'll show you this really cool thing. So first of all, we support expressions inside of your HTML. We really mean that. So this is a little less Svelte and a little more JSX. But here, right, it's just JavaScript. So inside of these expressions, you can go full JSX, full expressions. There's no special custom syntax here. And in this case, what we have is this idea of mapping over our posts, and I'll make this just a bit bigger, showing a preview and sending props down. So we have this post, and we're going to send some author data. That reminds me, let me grab some author data here. Again, copy and pasting just to save some time here. All right, hopefully this loads without too much trouble. The post preview component we got to pull in. Let's grab that. Okay, so again, we are bringing this functionality into the site, which is to actually fetch these posts and give you this index of everything. Again, screen real estate is a premium right now, but maybe I'll just take over here and you can make the smaller, right? And then go to one of these posts and read the content. All of this with just a couple lines of JavaScript. I didn't even get into this layout. There's more to uncover here, but this is the meat of how Astro works. 0 JavaScript being sent by default, and you opt in to these islands of functionality. We really want to get this like site builder concept as our #1 story here. So you can see the blog, documentation sites. These are all great things to start building on Astro today. And we're only going to start adding more and more dynamic content, more and more dynamic behavior, and support as we grow. So really exciting kind of early times for this project. If you want to learn more, the shine is worn off. You're just seeing Keynote now. We have an early preview going on at astro.build. So this is our Discord, essentially a link to our Discord server. Invites are going out there. There's an invites channel. There's a conversation going on. Please join if this is at all exciting to you, because we really, really are passionate about this new take on web development. So I hope you liked all this. I hope this was exciting. To learn more, go to astro.build. And thank you again for watching.
Hey.
Hello. I liked Fred's humbleness in that talk. He said you might know me for my work on Snowpack. Not I made Snowpack, like it's my thing. It's pretty impressive, to be that humble. Cool. Yeah, so interesting. Astro's really interesting. It's definitely a different thing. I saw a lot of the chat on YouTube. It's a very different direction to where SvelteKit is intended to go and where it is going. Yeah. But it's really interesting because it's sort of taking us back to purely server-side rendered content, which is a completely different approach, but also something that for those sort of scenarios, great idea.
It reminded me a bit of Elder.js, but in a more it looks more like a standard Svelte way, in a sense.
Yeah. It's taking a lot of ideas from how Svelte looks when you're writing it.
Definitely.
Sort of the low tooling approach or something like that. But it's quite a different approach to doing it. So interesting.
Yeah. Okay. So from Astro to design engineering. So this is actually a talk from across the pond. So that's, I think, from Mexico. I hope I got that right. I guess
we'll find out.
Yeah. So it's actually partly in Spanish with subtitles.
Cool.
Yeah. So
have to learn Spanish as well.
Yeah. Let's see what it's about.
Hi, my name is Rodrigo, and I'm team coordinator and lead developer in Laboratorio Web in Centro de Cultura Digital in Mexico City. We'd like to present you our design system, a themable component library written in Spanish using Svelte. It has now matured enough that allows us to share our experience building it. In due time, we will share it in international language as well. This video will feature fellow team members in order to give you a more complete perspective. Our workplace, Centro de Cultura Digital, is a state-run center for digital and technologically based artists and cultural agents. It has always had very high design standards and a very progressive mindset. Since we must deliver multiple projects per year, each with a consistent visual quality, we decided to invest in creating our own design system. Svelte has been an irreplaceable front-end tool for successfully bringing together a very diverse team with varying levels of experience. The way this framework is created has allowed us to easily delegate tasks according to each collaborator's skill level, from interns to senior developers, and to allow them to easily find their own path. We favor community-driven projects and loosely opinionated tools with a sharing-free and empowering mindset. Svelte was sort of the perfect match for our organization. The independent spirit behind it, the community dynamics, and even its humorous documentation were a sign that this was something we wanted to invest in, and that we find it aligned with our values in an institution that has a very critical perspective towards technology. We decided to develop our design system in our native language in order to make it easier for local developers and designers to contribute. We take great effort to develop a Spanish-speaking technological language across our organization. Coding in Spanish has a lot of problems, not only in new years, so it brings the need for a lot of convention setting. One of the biggest challenges is to avoid using mixed languages, since that creates a situation where you don't know which one you chose, and that brings a lot of bugs. In order to explain what this design system is, one of the most important aspects to talk about is theming, or the application of themes. Our team needs to deliver quite a lot of projects per year, so we needed a way to build UIs in which we could easily quick build and apply visual identities. And this we did with the help of Svelte Themer, which we forked, because we added a couple of functionalities like a deeper nesting of hierarchies and additional property families. This is one example of a task that we as a small team have not had the time to do, which is basically to update our fork and try to send a pull request. We hope we'll manage soon so that community could benefit from our effort. And well, this is also an example of one of our most complete components, which is forms component, or formulario, which has a lot of different options, validation, optional. Even we have a step-based form in which users must complete correctly each step to be able to continue. And it's built by having this input component, entrada we call it, which uses some like plain HTML inputs as well as complex components that we can add to it. And this is why we can have like a calendar or complex components. And also we have a field component which does a lot more, even has the ability to like perform arithmetic operations and check against results. And when you send a form, it does deliver a very nice plain old JavaScript object. So this form is quite complete, robust, and one of the biggest challenges in this design system has been building this. One big aspect is the fact that in order for it to be able to store your state or your past interactions, or be able to change steps, you need to store certain information in your store. And this creates a sort of anti-pattern in which we have a store inside of the form as well as some store inside of the main application. And this is a situation we haven't theoretically fixed yet, but we do have a workaround for, which is to allow to just vertically pass some state to the form if you don't want it to handle it internally. But this we have been able to apply this form successfully in a bunch of projects, even for complex statistic purposes. So I hope we have a better solution for the state in when we talk again about this. Now our team, Laboratorio Web, will show you the inner workings and decision-making processes behind this project.
Hi, I'm Jose Carlos Hasbun, and I'm a front-end developer working at Centro Cultura Digital in Mexico City. As a contributor to this design system, I will give you a brief introduction to it using one of our main components as an example. Well, as you can see here, we are using Storybook for Svelte. Here is the card, full card with all its elements on it. With Svelte, it's very easy to have many options of the same components, so I will show you just some stories, but what about using a video instead of an image? Or maybe you want a real simple card with just an image and a title? What about adding some action to it? Or maybe a list of actions? And you can go on, but what about showing all the elements of this card or component, but in a horizontal way? So you have it. Then I want you to see that we are importing the elements from our design system, and we use these props. We're also using some reactivity here, also using a lot of CSS, and then we have this HTML which has JavaScript injected on it using the elements from our design system. I hope you enjoyed this design system, which is written in Spanish, and well, thank you for your attention.
La versión actual del sistema de diseño lleva 1.5 años trabajándose, aún no está documentado y es probable que cambie, por lo que creemos que aún no está listo para compartir, pero ya se ha implementado en al menos 7 proyectos que han estado o están en producción. ¿Cómo comienza? Comienza diseñando los componentes que requiere cada proyecto que estamos trabajando en ese momento. A lo largo de este 1.5 años hemos trabajado distintos proyectos paralelamente. Entonces, cada uno tiene necesidades y requerimientos distintos, por lo que los componentes evolucionan en términos de su complejidad y de su funcionalidad. Un ejemplo de esto es el componente de formulario, que comenzó como un formulario de contacto en un sitio con elementos básicos, un campo de texto, un correo, un asunto. Después se convirtió en una herramienta de inicio de sesión o registro, y en el proyecto más reciente este formulario de la mano de un módulo backend de código abierto basado en Keystone creció hasta convertirse en toda una herramienta compleja, un sistema generador de formularios que recaban información estadística. Entonces, el sistema de diseño para nosotros es un proyecto por sí mismo y lo trabajamos como tal, con sesiones y contribuciones específicas, pero en su día a día crea simbióticamente de la mano con los otros proyectos que necesitamos trabajar. Entonces, al utilizarlo hemos encontrado que crea una coherencia entre los distintos proyectos y cada elemento que hacemos. Además de que nos ayuda muchísimo porque cuando resolvemos un problema de usabilidad o de compatibilidad, se resuelve simultáneamente en todos los proyectos. En el proceso de bocetaje y de concepción y de armado de una propuesta con componentes ya existentes, nos ayuda muchísimo para limitar las opciones, para repetir componentes y patrones de uso que ya tenemos establecidos. Esto nos posibilita como equipo para realizar múltiples proyectos y sostener la carga de trabajo. Todo esto está respaldado por soluciones de diseño y principios colectivos que tenemos como equipo, basados en la experiencia e investigación de usuarios. Y esto es porque sabemos que tienen implicaciones profundas en el centro en el que trabajamos y en nosotros como equipo.
Hola, mi nombre es Irena, soy diseñadora de experiencia en el Centro de Cultura Digital y en esta charla me gustaría platicarles un poco sobre mi participación en la creación del sistema de diseño. Y nace de la necesidad inmediata de poder operar en una modalidad de trabajo multiproyectos. Este sistema de diseño también nace de los esfuerzos profesionales y de persuasión para trabajar en una modalidad más ágil, centrada en las personas y con tecnología y código avanzados. Cuando concebimos el sistema de diseño, necesitábamos una fuente única que nos permitiera centralizar los elementos y los componentes básicos que solemos utilizar en el desarrollo de nuestros productos, pero también reglas y principios que nos acompañen en el camino para saber cómo están construidos, cómo crearlos y cómo implementarlos en los prototipos y en el código. Atomic Design fue nuestro primer amigo para hacer despegar el proyecto. Esta metodología modular nos fue útil para crear estructuras y ordenar los componentes que formarían parte de nuestro sistema de diseño. Y conforme íbamos construyendo componentes, paralelamente estábamos tejiendo principios de diseño que guiaban a la toma de decisiones y eran vitales para que el sistema de diseño pudiera vivir y operar en el contexto mexicano. Pese a los obstáculos, el arranque lento y el paralelismo de diseñar y crear nuevos componentes conforme fueran surgiendo necesidades en nuestros proyectos, podemos decir que el sistema de diseño del Centro de Cultura Digital es primero flexible porque busca adaptarse a cualquier escenario, está construido de manera modular y sus aspectos de diseño son consistentes y funcionan perfectamente entre sí. Es interoperable. En el sector público cultural es muy común tener plataformas o proyectos en desuso por la dificultad que tienen los equipos para entender la estructura y la composición. Su objetivo es equipar a otras comunidades de principios, de conocimientos y herramientas para resolver los problemas sin el equipo de diseño mediando su uso. Y esto va a marcar la diferencia entre un sistema de diseño exitoso y uno que no sea exitoso. También es consistente un sistema de diseño que sea homogéneo con la guía de estilos, las proporciones de diseño, el comportamiento y un etiquetado correcto facilitará la curva de adopción por parte del equipo y además enriquecerá la comunicación interna. Es accesible. Todas las personas, incluyendo las personas con algunas discapacidades, deben tener acceso a contenidos legibles. Verificar el contraste de nuestra paleta de color, usar fuentes claras, asegura un tamaño de fuente legible, aplicar principios editoriales para web, garantizar áreas comprensibles para elementos cliqueables, pueden marcar la diferencia entre la permanencia de un usuario o un rebote más a nuestras estadísticas. Y por último, es tematizable. Hacerlo tematizable nos permite generar rápidamente sistemas de diseños locales que son hijos del sistema de diseño principal para ofrecer a todos los proyectos una plataforma personalizada basada en sus propias guías de estilos. Fijar metas en torno a estos principios nos ha traído grandes beneficios como economizar en tiempo, tener alcances más realistas, mejorar la experiencia de las plataformas, gestionar eficientemente la modalidad de trabajo multiproyecto, usuarios y clientes más satisfechos y por último incrementar la comunicación entre las distintas partes del equipo. Muchas gracias.
Hola, voy a hablarles sobre los elementos y los componentes de nuestro sistema de diseño. Para esto, haré una muestra breve de solamente algunos, tratando de explicar la estructura y cómo se ve la interfaz en Storybook. Antes que nada, me gustaría decirles que para la construcción de estos elementos y o componentes, siempre colaboramos especificando la estructura de datos previamente. Lo que estamos viendo ahorita en pantalla se llama imagen subir. Es un componente que permite subir imágenes y ser conectadas en un frontend. Y una de sus funcionalidades complejas sería poder controlar el máximo de tamaño del archivo y también poder hacer una revisión de headers para asegurarnos de qué tipo de archivo queremos subir. Revisando el HTML podemos ver que tenemos un input que funciona de manera oculta para garantizar la accesibilidad. Lo que vemos nosotros en Storybook es precisamente un componente ya diseñado y que tiene variantes, como por ejemplo circular. ¿Okay? Y de esta manera ya el contenedor de imagen está funcionando. Bien, bueno, a continuación me gustaría mostrarles esta familia de elementos de textos. Tenemos precisamente el elemento texto, que nos permite, más que párrafos, tener textos en formato HTML. Esto es, podríamos pasar nosotros un link o podríamos pasarle cualquier elemento HTML dentro de un texto específico. Así como pueden ver aquí, estamos utilizando el hecho de que acepte, por ejemplo, variantes o también poderle pasar los elementos de estilos. Okay, entonces aquí tenemos, por ejemplo, una variante como texto auxiliar con sus características ya predeterminadas en tamaño y en color, o un texto secundario, ligeramente más pequeño, o compacto, que viene, digamos, de tamaño pequeño, pero en mayúsculas. Y a su vez, pues bueno, algunos ejemplos de cómo le podemos pasar ya nosotros estilos directamente a este texto. Bien, continuamos con el elemento de lista componentes. Este elemento es muy específico, pero también muy interesante y poderoso a su vez. Esto nos permite tener una lista, un listado en Flex de manera default que acepta componentes. Y eso es muy importante porque tanto puede, en este ejemplo donde está jalando tarjeta, por ejemplo, también a nivel de proyecto puede jalar cualquier tipo de componente creado con Svelte. Utilizamos este tag especial de Svelte llamado component y bueno, configurado de la manera correcta nos permite justamente tener nosotros componentes enlistados. Desplegable sirve muy bien como para elementos ya sea de un menú, desplegar algún contenido a manera de acordeón, por ejemplo. Características que tenemos es que podemos nosotros pasarle los iconos y los enlaces, la cantidad que sean, y que se cierra cuando uno da clic fuera de él. Para hacer esto, digamos, hicimos una función que nos permite ser reutilizada en varios elementos donde querramos que se cierren dando clic fuera del mismo elemento.
Dentro del sistema de diseño, las áreas que están por comenzar son accesibilidad. La tecnología, al ser parte integral de la cultura, debe poder ser accesible y utilizable por todas las personas, independientemente de sus capacidades o sus discapacidades. La discapacidad es un estado natural, ya sea temporal o permanente, en la vida humana. Por ello, la accesibilidad no debería ser una opción, sino un estándar aplicable en el principio de cada proyecto. Estamos por comenzar a implementar principios de diseño universal, en el que el perfil de nuestras usuarias incluirá distintos rangos de discapacidad, ya sea visual, motora, auditiva y cognitiva. Algunas de estas implementaciones son maquetación semántica compatible con lectores de pantalla, screen readers, aplicación de etiquetas en marcado HTML, descripción de contenidos de imágenes, subtítulos para videos y transcripción para audios, e interpretación en lengua de señas mexicana. Al crear plataformas que puedan ser navegadas y comprendidas, reducimos la brecha digital al cumplir con el acceso igualitario a la web, un derecho de todas las personas que viven con alguna discapacidad. Lenguaje incluyente. Según la Real Academia de la Lengua Española, en español, los plurales masculinos son una forma de universalidad en la cual está implícita la mención a hombres, mujeres y personas no binarias. Sin embargo, cada lengua pertenece a sus hablantes y son ellas quienes deciden cómo utilizarla. Un ejemplo de lenguaje incluyente en español sería escribir usuarias en vez de usuarios. Realmente no existe un consenso de cómo pronunciarlo ni de cómo escribirlo. El lenguaje es una tecnología, un código, y como todo código puede modificarse, reescribirse, expandirse. El español, como la mayoría de las lenguas habladas hoy día, es una lengua viva y es propio de cada lengua adaptarse a su contexto. La internacionalización. La internacionalización es el diseño y el desarrollo del contenido que permite que su funcionamiento sea adecuado al ser adaptable para comunidades usuarias de cualquier idioma, región o cultura, de forma que se eliminen las barreras de localización. Por otro lado, las traducciones. En el territorio mexicano, además del español, son habladas 68 lenguas originarias y 364 variantes lingüísticas. Es importante intentar traducir a las lenguas originarias donde tengamos conocimiento que nos visitarán. Si tendré usuarias de Tlaxcala, puedo intentar traducir a las 4 lenguas originarias que se hablan ahí: náhuatl, totonaco, otomí y zapoteco, por decir su nombre castellanizado. Esto va de la mano con conocer cuáles lenguas habla nuestra audiencia. Todo esto ofrece un reconocimiento a la labor de la traducción y coadyuva a su profesionalización, así como a la descentralización idiomática de las tecnologías de la información. El diccionario de microcopies. Implementamos un diccionario de contenidos estáticos, que son aquellos textos que estarán de forma permanente en una página web. El diccionario consiste en albergar los textos fijos de la plataforma que estemos desarrollando. El objetivo es que en todo momento exista una concordancia entre el prototipo de Figma y en el sitio web, siendo el diccionario una única fuente de verdad. Asimismo, facilita la labor de cotejamiento y verificación de los contenidos textuales y la detección de posibles erratas. Gracias.
Como desarrollador full stack con principales responsabilidades en el backend y en la integración con el front, me ha beneficiado mucho tener un sistema de diseño al realizar una funcionalidad que integre ambas. Al momento de programar una funcionalidad, reviso la historia de usuario, valido o actualizo la arquitectura de datos y realizo una prueba de concepto con componentes de Svelte sin diseño visual. Dejo los datos de la misma manera que los reciben los componentes del sistema de diseño y es muy satisfactorio cómo esa funcionalidad cobra vida fluidamente. En caso de no existir un componente en el sistema de diseño, es sencillo dejar un componente vacío con los datos que recibe y los que pinta y pedir a alguien en el área de interfaz que complete el diseño. Si algún componente evoluciona con nuevas funcionalidades como validación, animaciones o mejoras de usabilidad, etc., actualizar el mismo componente en proyectos previos, basta con hacer un npm install, correr las pruebas y listo.
A futuro, en el sistema de diseño queremos implementar una API en inglés. El código interno va a permanecer en español, pero queremos implementar esta API. También trabajar en convenciones de nomenclatura que son profundamente importantes en el contexto, por ejemplo, en el que estamos aquí, de estar creando un sistema de diseño en español con Svelte, y queremos pulirlas lo mejor posible. Y por último queremos trabajar también en la socialización interna, ¿no? Socialización del sistema de diseño dentro de nuestro equipo y dentro del centro.
Hey.
All right.
Hi.
So that was, hello there.
Hey. Hi.
That was a great talk. So I just wanted to ask you, how's the Svelte community over in Mexico? Are there a lot of people using Svelte over there? Or?
I don't know many people using it. Mostly enthusiastic people who found it would like to implement it in their jobs or something, but they probably will never do it. So since we got like a blank slate team building situation, I just decided to go ahead and just use Svelte for everything because it was so much more democratic.
Yeah.
What was the biggest surprise that you had from using Svelte to build the design system?
I don't know. Maybe just the fact that we could put together like people who just barely had learned HTML and maybe couldn't even speak English, and we could like, put the director of our center designing interfaces with little printed components, and then have like a junior intern build a site. It was just amazing. Of course, it wasn't so straightforward. It took like 6 hours, but
it sounds good. It sounds definitely sounds like something Svelte does well. It's very easy to understand.
Can you hear the soundscape? This is Mexico City.
Yeah.
They're selling you used trash. You can, well, it's not trash. Your sofa, your bed, you can sell it.
It's a
there's
second
truck.
hand?
Yeah, but they go around, like, especially Sundays, a lot of
wow.
soundscapes, Mexico City.
That's cool. I'd like to go to Mexico City sometime. Never been to Mexico at all.
Please do. It's a beautiful place, and it's always growing and getting to be more international opinions mixing. So it's great if you come.
Yeah. All right. Thank you for the talk.
Thank you for listening.
Yeah. Bye. All right, Joe.
Got the quiz.
So it's time for the quiz.
Very exciting.
Who's going to be on here? It's Karine.
Hey.
Robert's there as well. And
Hey, Robert.
I think Anthony, and is Grigor here as well?
Yep.
Yeah.
Hey.
Am I missing someone that should also be on here?
I think that's everyone. Kevin, are we demoting you to slide monkey? Is that right?
Yeah, that's correct. That's the only thing I know how to do.
So I think we also should make clear. This is something Karine, I think, wanted to make clear about winning this quiz and what that might mean.
Yeah, it means nothing because there's nothing to win. Okay, just amazing, like glory points for yeah.
Svelte community glory points. You can
Exactly.
put in your name tag. You have permission to say, "I won the Svelte Summit quiz."
Yeah, no prize, no nothing. I don't think we even count points, so
It's question and
it's
answer.
the unquiz. So before that, we should definitely point out that people should join the Discord channel, because if you want to be able to play, you'll have to post your answers on the Svelte Summit channel on the Discord server.
I'll be monitoring.
Yeah, Robert will be.
You get double fake points for funny answers, I think.
So yeah, tune in on the Discord channel, and I don't know, maybe we'll wait for a few seconds so that people can grab the link on the top of the comment section on YouTube. And
So make sure you're in the Svelte Summit channel within the Discord server. It's at the top.
Yeah, it's pinned to the top now.
Great. Okay, so is everyone ready? So yeah. So Kev, you can. So the rules are pretty simple. There are 10 questions to test your level of Svelteness, and as we said, absolutely nothing to win. And so we can maybe start with a very easy one. Let's go to question 1. Okay, so question 1 is, what does Svelte mean? Answer A, fast and furious. B, slippery and dangerous. C, thin, graceful, and slender. And nothing.
We've missed that Svelte, just the option that Svelte means popular among puppets.
Yeah, no, I thought that was the answer.
Yeah,
that's the correct answer. Yes.
Option E, what happened to that?
So what do you say, Robert, Anthony, and Greg?
I think we're getting a lot of C's.
We're getting a lot of C's, we are.
And E's.
Yeah.
Which is interesting because it's wrong.
Yeah. So, sorry, Didier, but it's not the right answer. Yeah, answer is C, thin, graceful, and slender. And actually, I should point out that it's a French word. French word. Actually.
And it describes rich, right? Thin, graceful, and slender. Yeah.
Yeah. You'd be happy to hear that. Okay, next question. So who is the creator of Svelte? Is that Mitch Harris, Obi-Wan Kenobi, Rich Harris, or Rich Barris?
Did we give away the answer in the last question? Is that like a massive hint?
I think so. Okay. There are some bees. Yeah. and James.
Popular among puppets.
They're all right. They're all correct.
We're getting a separate.
Okay, I think, yeah, answer C is correct, of course, though I think Rich might have been inspired by Obi-Wan Kenobi.
Yeah.
Like, this is the framework you've been looking for.
And with the hair, right? You can kind of see that with the hair. The old hair.
Yeah, the hair. Yeah, great. Okay, a bit harder now. So which city held the very first Svelte meetup? Is that A, New York, B, London, C, Paris, or D, Stockholm?
I actually didn't know this one.
You didn't know this one. You didn't know this one.
Oh, now we're getting all over the board. Some people think it's New York, and some people think it's Stockholm.
What do you say, guys?
I'm going to stay quiet for this one.
That's
I didn't know this one. I didn't know. I had to look it up.
So, what does the community say?
There were a few people said B.
Okay,
it was my
yeah,
meetup.
B.
It was my
Anthony, we have you to thank.
Thank you, Anthony.
That's why meetup.com/svelte is.
And when was that?
Yeah.
Was that a long time ago?
Oh, it was before lockdown, so it was a good two and a half years ago, maybe 2 years ago. Let's say 2 years ago.
Okay.
Yeah, and actually, the New York one was on the next day. Sorry, on the same day, but in New York time. So it was a few hours later. So they fell on the same day, just with a delay.
And the Stockholm one was the day after. So
really,
that was a very tricky question.
Very close.
So sorry, I'm going back to my holding.
Okay, next question. Okay, what's the name of the Svelte podcast? SvelteCast for A, Svelteland, B, Svelteverse, C, or D, Svelte Radio? Okay.
SvelteTube.
SvelteTube, yeah. Do we need?
Is this an announcement of a rebranding?
Yeah, maybe that's what it is.
Getting a lot of D's.
No, Ken says no. He votes against SvelteTube. All right.
I think we've got a bunch of
I think everyone got D. Use Svelte, Svelte Web Audio. Okay, great.
And
24 episodes, I think, until now, and of course the URL is svelteradio.com. If you haven't heard.
Go subscribe.
Okay.
I'm sorry to interrupt.
Who wants to join in? Danny.
Okay. Next one. What's the title of Rich Harris' founding talk on Svelte?
If you were paying attention earlier.
Yeah, rethinking reactivity? Is it the return of write less, do more? Is it RIP jQuery hello Svelte? Or is it computer build me an app?
I'm seeing a lot of A's.
I see an answer here. A.
Yeah.
Yeah.
So what's the answer?
Yeah, computer build me an app. Very, very good talk.
I think most people flunked that one.
Yeah, most people are thinking of the Svelte 3A talk for rethinking reactivity.
Which I think was the talk that kind of pushed Svelte into the limelight, right?
Yeah.
Yeah.
There's a funny moment in computer build me an app. Well, not a funny one, but nothing is working on the demo part, and Rich is really like hyper zen, and he gets through, but it's really a challenge. Joe, will you take on from here?
Take on the next ones. Cool. So, Kev, yeah. When was Svelte first released?
This is a tough one, isn't it?
2017, B 2018, C 2019, or D 2016. So I got this one wrong. 2077.
So someone linked the video to the talk on Discord, so that might have spoiled the answer. For
Don't look at the video. Cheating.
But also, just because Svelte feels like it's from 2077 doesn't mean that it is.
Yeah.
Kind of getting across the board.
Yeah.
Jamie
said after the Wizard Wars.
After the Wizard Wars. Cool. We've still got a couple of answers coming in.
BC was what somebody answered.
BC 2000, yeah.
Yeah. EAB.
Cool.
Yeah, very mixed.
So the answer, yeah, D 2016. Which I thought it was 2017 when I first went through this. I thought 2017 might even be too early, but
1995, someone.
Cool. Next question. What is the name of the predecessor to Svelte? So actually, this is I used to use this library at work, and it's kind of where I started following what Rich Harris was building. I got very excited when Svelte was announced. So, A, jQuery, B, Reactive, C, Mootools, or D, Prototype.js.
And for bonus points, why did they call it React? The predecessor. The thing that came before Svelte, and Svelte appeared and is better.
So I used to write in this framework in the front end, in JavaScript obviously, and it was with a C# backend. And we would combine the old MVC C# server-side rendering stuff with Reactive, which was quite exciting.
Yeah, it's still going. It's still used.
It's reactive.js.org, I think, is moved onto JS.org.
And it looks very similar syntax-wise, isn't it?
Yeah, but the lots of two-way data binding by default, which ends up making things more messy. Cool, some code questions. They're ones we've all been waiting for. I love these Figma animations. It's great. Which of these is Svelte? I'm not going to read out all of the code. So we've got A, B, C, or D.
I mean, clearly the first one.
What's Svelte-NG?
Although I don't think people are agreeing with me.
No? That's weird, isn't it?
Funny that.
Although there's a hint, even if you don't, read the code, you can guess.
Yeah. The magic one.
Yeah, people got it right. Gee, I wonder why.
Cool. Yeah. The answer is...
So, I have a question for y'all. What are the other ones?
Yeah, that's a good one. Good question.
I think the top is Vue. I'm not sure. It might be Angular.
It's Alpine JS.
Alpine.
Alpine.
And the second one, I think it's Angular. And then the third one.
Where is it? Yeah, C's React.
I mean, that third one looks like React,
yeah.
Right, yeah, makes sense.
We
haven't got jQuery in here.
Yeah,
open brackets, selector.
And we haven't got vanilla JS either.
That's true.
Could have thrown that one in.
We have the next best thing, Svelte.
So what Svelte feature is most appropriate to implement in Nested File Explorer? I think this is actually pulled from the tutorial. This is used in...
Oh, there's a fast answer.
Pardon?
From Didier, there's a very fast answer from Didier on Discord.
A, B, well, C. Lots of A's.
I'm seeing mostly A.
Yep.
Yeah. I think there we go.
All right.
So who won? Or is there another question? Is that it?
Yeah, last one.
the tiebreaker.
The winner takes it all.
Yeah, all of the nothing. Which of these is not a template tag? So which of these is not valid in Svelte?
I didn't know you could use ... in a template tag like that.
Okay, looking fairly consistent. Not everyone, but lots of.
There's a few.
We have a sea of C's, yes.
Some B's.
Some B's.
Some B's.
Cool.
B or C.
There we go.
So the reason for this question, the B actually is something I didn't realize was there until not long ago. But key is like if you want something to be, if you want to say that the things nested inside it, that they're reactive, and what they're reactive to, it's like a sort of wrapper tag. It's very interesting.
B is probably one of the newest template tag. If I'm
It's
not
got
mistaken.
to be, yeah.
Yeah, most people are probably more familiar with its original version, which is by hacking it and using an each block.
Yeah.
And then like a single array item.
Yeah, to get that same reactivity.
Cool. There we go.
And that's all. Well, thanks for playing.
Yeah.
Lots
Thanks
of
for putting it together.
That was a lot of fun. Right.
So everyone wins a Svelte puppet, right?
Yeah. Just email Kev. He'll send it out to you. He's responsible.
Wait, what? All right. So we're going to introduce the next talk. I'll remove you guys. Sorry.
No.
Bye.
Oh, hey, Jen.
Hi.
What's up?
I think everyone won.
Yeah.
We're gonna introduce prizes. Okay, so I guess we're going to get on with the next talk, right? Which is compiling for accessibility with Svelte. Of course, accessibility is a very important aspect in terms of what we do as developers. And the person who's actually going to be presenting is Anthony, who is the one of the organizers or co-organizers of Svelte in France, so which is great. I think the Svelte groups or Svelte Society groups are growing in terms of number. I believe there's one in Japan, in India, and other places. So that's really good news.
We're taking over the world.
Yeah, definitely. So I think we should just queue up the presentation. I believe. I know we're a bit ahead of time, but
let's do it.
Yes, we can get started.
All right, let's go.
Hey, if you are concerned about accessibility and you work with Svelte, you probably stumbled upon something like this. It's a warning. It tells that your application source code contains an accessibility issue. Here is maybe the most common warning you can see, one of the first added in Svelte. In fact, it tells that a textual alternative is missing on one of your images. There are many other accessibility checks that Svelte can do for you, and this is what we are going to talk about in the following minutes. I will also show you how this is done inside of the compiler. Hi, I'm Anthony Legoas. I'm from France. I'm a web developer and CTO of Zenica in the city of Brest in Brittany, and I'm also co-organizer of the French community of Svelte Society. I recently dove into Svelte source code and precisely in the part of the compiler that deals with web accessibility, and I will show you what I've discovered and what I've learned. The beginning. Let's start by the beginning of the history. Everything starts in March 2017. At this moment, this issue was opened by Rich Harris, I guess you know him, and he explained his frustration about web accessibility. He says he's not good at it, he got no disabilities, so the non-accessible web looks fine to him. So he wanted to be helped about this, like most of developers, I guess. And this observation leads to the following idea: what if Svelte could help developers to build more accessible applications? It looks like a very good idea, and for Widgets, it's also an opportunity to educate developers about web accessibility. Then the subject was added to the roadmap published in June 2017. This is the starting point. Svelte will be a good citizen of the web, not treating web accessibility like a side concern of web development, but it will be really at the heart of Svelte. It will encourage web accessibility best practices. Now we have to look at how this could be made inside Svelte. And you know what? Because Svelte is a compiler, we can do something very interesting. We can do some checks about web accessibility issues at compile time and then display some warnings to the developers. The decided plans of action was to implement checks from the ESLint plugin JSX-A11Y, which is static checker for accessibility rules on JSX elements. Widgets made the first implementations, and the Svelte core team is still open to contribution for the remaining checks. Now let's move on to the source code. Okay, now we are inside Svelte source code, and we are going to open one file, the elements.ts file. As you can see on the left, we are in the compiler part of Svelte source code. Let's take a look at this file. So at the beginning of the file, we have a list of variables which are declared and which are useful for accessibility checks. We have area attributes, area roles here, and a list of required attributes on HTML tags. For example, we have here the health attribute, which is required on image HTML tags. Okay, so this file defines what is an element inside of Svelte. We have here the class element, the constructor here, and then we have this function, the validate function. This function performs a list of checks, including accessibility checks. We can take a look at this function, validate special cases. And this function in particular includes some checks on accessibility best practices. We have here, for example, some checks on the links. We can retrieve some attributes on the element. For example, here the href attribute, and then we have here a check on the href value. And if the href value is detected as not valid, we can display a warning to the developer inside the console. Okay, as you can see, the code is quite simple. It's simple because we have everything we need here to perform the test we want to do about web accessibility. Now I want to contribute to Svelte with you by adding an accessibility check to the compiler. We are going to add a very simple check on ARIA roles. Maybe you know it, but abstract roles are forbidden on HTML tags, and we are going to add a check on that. So I have created the test files. Here is an example that should fail. We have a warning on it, but we want Svelte to be more precise. And here is the expected warning. We can run the test. And it failed. It's okay. We have the previous version of the warning. We can now write the implementation. Let's start by adding the list of abstract roles at the top of the file. And then we can write the rule. We can rerun the test. It's okay now. As you can see, the test is green. As you can see, it could be very easy to contribute to Svelte, so do not hesitate to do it. Now let's go back to the presentation. Now the limits, because yeah, of course there are some limits with this approach. You know, web accessibility is a very complex subject. We have a lot of rules to respect to build accessible web applications. And almost everything in accessibility is about the context. To do very efficient checks, we have to know the context in which an HTML tag is used, for example. If I go back to the example at the beginning of the presentation, we can check if the textual alternative is used or not. But without the context, we can't know if this textual alternative is valid. Most of the time, the alt attribute must be empty because the image got only a visual value. It's just decorative. But when the compiler do the checks, we can't know if it has to be empty in this particular context. And this context is needed for many, many rules. To conclude, we can say that, yeah, Svelte is already a good citizen of the web because it tries to help developers to build accessible web application and a more accessible web. And in the future, I think Svelte can go a bit further and try to get the context while performing accessibility checks. It will not be possible for everything, but in some cases, the context is just the hierarchy of HTML tags. For example, about the headings level, we can simply check if a level 2 title is well preceded by a level 1 title. And this is possible because in the compiler, for each element, we have the parent node. So maybe the next step in accessibility for Svelte could be to implement new checks by looking at the HTML semantic. Thank you. Thanks for your attention, and thanks to all the people who have contributed to make Svelte such a great product. Goodbye.
Hey, that was a great talk.
Yeah, I think it's a really important topic too.
Definitely.
I appreciate that Svelte like does that out of the box. Although if you really like know the accessibility requirements, it really like Svelte does not cover like the kind of ground that you need to. So it is nice to see this kind of a thing where he's improving on you know, ways of adding. So I expect that Svelte will actually get really good at this probably at some point.
Yeah, it makes sense also because you can compile that stuff in.
Right. Yeah.
All right. Next talk, we're going to learn about forms. So let's see here.
Nice.
Hi there. Thank you for joining me here today at the Svelte Summit. I'm Tane Piper, a creative technologist and open source developer, and the author of Formula, a reactive forms library for Svelte. So the good news is you don't need a library. Svelte already has several APIs that allow you to make any HTML element reactive. There's a few ways to do this, and I'll show you a couple of simple examples. But here's some code first of all to show. The first one is the bind directive. This allows you to bind to properties of HTML elements and your custom components. It allows you to pass a value from a parent to a child component, and the directive is a two-way binding. So when you make a change in the child component, this will also update the value in the parent component. The second is the on directive, and this provides a way to add event listeners for things like DOM events, such as clicks or mouse overs, or in our case, the form change event. It also allows you to subscribe to custom events emitted by your Svelte components, such as the dispatch of the added event that we have here. So to show the examples, here we have a very simple component that takes two values and adds them together. As you can see, when I click the inputs here, we see both the values changing and we get the added value. We are binding our values to the component, and here we're listening for the added event, which we get the total from. Our component itself, we're listening for the form change. When that form change happens, we dispatch an event where we add the two values together. And to change those values, we bind them to the input component here. We also can do a third way, which is not a recommended way for Svelte components, but could allow you to migrate existing code or work with third-party libraries, and that is to bind an element to a variable and then to use the DOM API. You can do this with bind this. Just to briefly show you an example of it, here we have a component, which is 2 buttons which we can click, and here we are outputting our value from the component being updated. In our component, we bind the this to element property here, or a variable, and once we have our component mounted, we have full access to the DOM. So we can use query selector, we can add event listener, but here in the end we are still dispatching our event from Svelte. Svelte stores are also reactive. Svelte provides a fully observable pattern, which you may have seen in something like other libraries like RxJS. The pattern allows you to create a single source of truth that other code in your templates can subscribe to. In this example here, you can see we create a writable store with 2 values, and we subscribe to the value changes and dispatch our added event there. With the store, we can also bind the properties of the store to our input values. So here you can see we're adding both total value 1 and value 2. This allows us to decouple the domain model from the user interface. It also means we don't have to listen to any specific events. So for example, if we wanted to replace these components with a different one like a range selector or a custom component, we can do that and we should still expect it to work. To show this in an example, here we have the same component. Here we have, we're binding our values and we're listening to our event. One thing you'll notice here is that we just are showing the output here, but changing the values does still allow us to see the updated value here. If we uncomment this code here, you'll see why. Because we are passing a value in, we're not two-way binding it. So when we actually set the value to the store, here on the mount, the only thing we are emitting is the added event. So if you are using stores and you are passing in values, that's just something to be aware of. So before using Svelte, I was working a lot with Angular, and I was building quite a few applications with both template and reactive forms. And when I came to Svelte, I wanted to bring over some of the power of reactive forms, and this resulted in Formula. Unlike the Angular implementation, the library is actually designed to work out of the box with any HTML5 form and use the properties of that form itself. So what does Formula provide? It provides an action which can be used with the Svelte use directive. The action, once bound to an element, will allow the formula to look inside that element to find any input elements, and it looks for the property name. From that, it allows it to generate a dynamic store. This uses Svelte stores, and these stores contain both the data model of the form and the additional UI model that we generate. So for example, you can access the current values of the form as the user changes it. You can also get access to initial values and values at submit time. And with the UI model, we have things like validity states and errors, the touched and dirty status of fields, and there's also form level validations and if the form itself is valid. It's zero configuration by design, so like I say, it's designed to work out of the box with HTML5, and here I'll just show a very basic example of that first with our same component. So here you can see we've gone back to the original component. We have our two-way binding, and we're just listening to our event here. If we look at the component though, you can see here we are importing formula, and here we create our form object. We access the form values store, and we also access the validity store. Here we're just binding our values as we were before. So when we make the change, we see the update. But you can see here we're also getting the updated added value. How this works is we have our form values store, and here it's already dynamically generating the store based on the name property of our input here. You can also see here we have a validity message. Here we don't show it if the form field is valid, but if it's not, we'll show a message here. So for example, if I delete this here, you'll see we instantly see the HTML error message for an empty field. And just to briefly show here in the console, you can see as I make changes in the form, you're getting the live values here. Here we just subscribe to it in the console log. So this allows you to build reactive applications based on your input. But what does Formula also provide? It has additional options to enhance your validation, to enrich your data, and to enrich the UI. And to show that, I have a bit more of a concrete example, which is a sign-up form. So here you can see just very basically in the app, if we have a user, we're going to show our sign-up form. Otherwise, we're just going to show another welcome page here. So in our component, with Formula, we're accessing more of our stores. We have access to the enrichment store, form validity, and if the form is valid. And we also want to get our submit values at the submission time of the form. The first thing to notice here is we're actually passing some default values. The reason for this is Formula generates its stores at runtime, so it needs to analyze your form and build the store from it. Here you can see we're using the optional operator because at this time the validity store does not know what fields are available. But by providing a default value, this allows Formula to generate your store ahead of time. The first thing here we have is our messages. This is useful for internationalization or domain-specific messages. The standard for an empty field is that you it gives you please fill in this field. But here we're going to give it a custom message. So now we touch our field. You can see that we have the service requires you enter a username. We can also do enrichment on our data. Here we're going to take our password and we're going to generate a password strength property. That's going to be a value, which is a score based on the strength of the password. And then what we'll do is we'll use the enrichment in here to set a meter value. So if I start typing in here, you can see that we're updating the meter. We also have a max length on here, so a min length, sorry. So you can see that we also require a minimum of 8 characters, and you're dynamically getting the error as we update the values. We also have our validation for fields. Here for our username, we're going to have a specific domain that we require. So if I put in, for example, my own email address, you'll see here that I can only sign up with this here. And as I delete this, you'll see that also we get the error messages from the browser regarding this being a valid email. So if I take another email address and we put that in, you'll see it's now valid. For the password, we're going to put a very simple password here, and we'll click on our password match. And here you can see we have our form validation. So here we are checking the values to see if the two fields match. And if they don't, we give an additional error message, which we can show in our UI. So finally, we're going to agree to our terms and conditions. And as you can see here, our form is now fully valid. Here with the disable button, you can see that we subscribe to this is form valid value. It's Boolean, it's either true or false. And then now we're going to also submit and use the store to dispatch our user. One other API that Formula provides is it provides an API for dealing with collections of form data. So if you have something like a data table, here you can see we have a row of a form which has some information. And what we're going to do is we're going to add a new row to this. Okay, and we're going to assume that Rich's favorite color is red. And if we go to our console here, you can see that as we subscribe to the value changes, we get our array of fields. So if you're doing something like a data table or a list of data, Beaker is the API that allows you to handle that. So thank you for watching, and I hope you enjoy the rest of the summit.
Cool.
Yeah,
I feel like
that was nice.
Getting a good form story is so important to any framework for getting used widely, because it's like 90%.
Definitely. Yeah, kind of. So at the first Svelte Society Day, I also did a talk on a form using actions as well, which is kind of funny. And there was this, I think there was this time when there were like 4 of these libraries that came out, one of them being this one. I really like this one. My own form library just like died from not being updated. So I'm glad someone picked up the torch.
Sure. Good. Yeah, no, it's great to have that kind of thing.
Yeah.
I think the Svelte world is still lacking somewhat compared to React because they've got such a lot of people working on that problem.
Yeah.
Yeah, that's great.
Next talk is going to be about a low-code tool, Budibase.
Very trendy nowadays, low code and no code.
Definitely.
Excited for this.
Hey everyone, hope you're enjoying all the great talks at Svelte Summit today. My name is Martin, and I'm going to talk about the low-code development approach and how Svelte is a fantastic framework for building these kinds of tools. I'm going to talk a bit about what we're building at Budibase and do a bit of a deep dive into our technology and how we're leveraging Svelte at almost all points of the stack to build a great low-code tool and experience for our developers and our users. Bit about me. As I said, my name is Martin. I am the co-founder and CTO of Budibase. So first of all, what is low-code? The definition here is that low-code is a visual approach to software development, and you can abstract and automate away every step of the application lifecycle to streamline delivery. So low-code, it doesn't aim to replace code necessarily. It aims to augment the development experience. So you can write code for the really custom parts and the really interesting parts that need a certain amount of flexibility or performance, but you can abstract away those repetitive, more boring, more predictable tasks and come out with an overall better development experience. So what is Budibase? Budibase is an open source low-code platform built primarily for developers, designed for speed and customization. So Budibase allows you to build internal tools, and it has its own internal database built on top of CouchDB, as well as the ability to connect to lots of external data sources. So lots of ones you see here: Postgres, DynamoDB, MongoDB, for example. Budibase lets you take your data and convert it into living, breathing web applications that you can use inside your business, inside your organization. So the actual low-code platform that we're building at Budibase is divided into 2 parts. We have the builder, which is the user interface you use to construct your applications. And this here is a screenshot of the back end or data side of the builder. So from here, you can set up your tables and your data entities and things like that. You can set up relationships, you can create columns and rows, and you can also connect to external data sources from here as well. We then have the front end part, or the design, and that's where you build your user interface for your application. So this lets you build UI on top of the data that you set up in the previous step, and you can create charts and tables and lots of different UI components that are bound to your data, as well as static UI components as well. So essentially what we are trying to accomplish when we're building a low-code platform or an application that builds apps, we want to build a visual definition for a software application and essentially be able to model that whole application as in a textual format, so JSON or XML or whatever it may be. We then have the consumption part, which is the client, and that then reads that definition and turns it into a living, breathing web application. So we need the following characteristics to do this. We need something that has no runtime. We need something that's lightweight, portable, of course. So we can take that definition and save it to all different places and have that portable definition of an application. We need something that's performant. We need it to be simple. and we need it to be reactive. Obviously, there's a lot of data dependencies going on, and we need things to update when other dependent parts of the UI update. For example, a input changes and a table that relies on the value of the input updates when you change it. And ultimately, we need something that is compiled. What we're doing here really is we're taking that textual definition. In Budibase's case, we use JSON, and we want to convert that into an intermediary format, which will be Svelte, and then Svelte then outputs the kind of raw JavaScript, or in the case of a compiler architecture, almost the native code of your application. So what we're kind of doing here is we're almost using Svelte as bytecode, that intermediary format that I mentioned before. So the builder creates that textual definition, and we can represent an entire web application as JSON. That gets consumed by the Budibase client library, which in itself is a Svelte application. And then we finally get our fully constructed web application out the other side. So this means that users can build their whole app in this visual way, and then they get an actual web application out the other side. And this entire builder here is built with Svelte as well. So our whole builder UI is built with Svelte, as well as the client applications it produces. We use Adobe Spectrum for our styling and our design system, which I'll talk about in just a second. We use Routify, which is an excellent library for file-based routing, and we use that for our builder. And then we use Vite for development and hub module reloading, which has been great. So I touched on our design system there, and it's built entirely with Spectrum CSS, but we also use the excellent Svelte library as well for a kind of workbench. And that means we get a holistic view of all the components we have, as well as their APIs, and it makes it really, really simple to see all the components and even Svelte actions and things like that that we have at our fingertips when we're building Budibase. So Budibase applications are made up of 3 core UI parts. And in this case, we start with the smallest, which is components. So components, a button or a container or a heading or a table. Screens are things like your home screen or your profile screen, and represent the kind of main body of the screen in a web app. And then we have layouts, which are wrappers around these screens. So you may have a top navigation layout or any kind of custom layout you want, and you associate a screen with a layout. So it's really just a wrapper around that screen. So here is a static definition of one of those screens. So this is the way we actually store this in the database. We have an ID and the layout that this screen is associated with. And then we have a bunch of props. So you see some CSS props there, as well as the components that are in the screen. And this children array here, which just contains the child components. So this just gives you an idea of the way that these UI elements are represented in JSON format. For routing, we use the Svelte SPA router, and it takes a JSON definition of routes that comes from the database. And that's how our applications know where to route to based on the URL. So that the client-side routing is kind of built into the applications that Budibase produces. Okay, so I'm just going to show a quick demo here of screens and layouts of how they work. So we click in and we're going to create a table here. We're going to call it orders. And we're going to create a few columns. So item, which is just a text field, and then the quantity of that item. And this is just some dummy data here. And we'll create a row just for test purposes. And then we can go into the design section. And from here you see some screens are created, but we're going to go in and create a custom layout just to show how layouts work in Budibase. So we create the layout, and we'll add a headline in here just to make it painfully obvious that it's a custom layout. We then go back to our screens, and we can click into one of the screens here, and we can change the layout, and we can change the styles, so we can change the padding there and some other options. And then we can actually change the layout to this custom layout here, and you can see how the layout wraps the screen. And then we just change it back to the normal one. So that's just a quick example of how the builder kind of works, and you change the properties on the right-hand side. You have these different screens and layouts, and it's a flavor of how you build applications with low-code platforms. So I want to touch more on components. You saw in one of the previous slides, we showed a static definition for the screens, and that's actually how they get stored in the database. But what we have here on the left is the definition for a component. So in our case, it's a button, and it shows all the different settings that you can have on a button. And then what happens is the builder reads this, and it shows all the properties on the right-hand side. So by defining this static manifest of component properties, that's how we know which properties every component takes when we change them in the builder. And just show an example of that in action as well. So we have the same app as before, but I've clicked a button here, and you can see I'm changing the text of the button. I can set it to disabled. I can go into the design props, again, add some padding. I can change the font. I can change the weight of the font, the size of the font. You have really the full power of CSS at your fingertips here. We can set gradients, change the background color. And you can see how we control the properties of that UI element by using that sort of visual experience on the right-hand side. So what I've shown you up to this point has been fairly static. We've just shown buttons and changing properties in a button, and some static screen definitions. But a web app isn't necessarily useful until you have the ability to provide data to it. So almost every component in Budibase is a presentational Svelte component, in that it just takes properties. Data is actually fetched by a utility component that we call a data provider. And this is where Svelte reactivity comes in really handy. It fetches data when things change. It has, we also make heavy use of Svelte context as well. So the data provider wraps components and then passes the data down in context. And this is a simplified definition of what the code looks like for that data provider. You see we have that reactive action here for refreshing the data source. And this is comes in particularly useful when we've built a fairly complex web application and we want all the interrelated data dependencies to update each other. So you can see how we take these textual definitions and then feed them into the Svelte application to create an actual web app. So a good example of a component that relies heavily on the data provider is a repeater. A repeater is really just a list that you bind to a data provider, and then it will render a row for every row that the data provider gets. So say you bind to a SQL query that returns 10 rows, you get 10 blocks in your repeater, and then inside that you can put whatever you want, whatever UI elements you want, and just bind to the fields from the query. And we'll just show a quick example of that now. So we are going to create a table here, and we're just going to upload a CSV just to give us a bunch of dummy data. We hit create, and we can page through some of that. You can see that we have that data in there, and we just have this home page. So I'm going to create a data provider and bind that data provider to the books table that we created previously. We then create a table and we bind it to that data provider. And you can see that the table gets rendered, and with all the data that we set up in the previous step, we can set a limit on that. change sort order. And again, this is all controlled through those props that we define in the component manifest. So if we delete that table, we can then go and create a repeater. As mentioned previously, we bind it to the data provider, and then inside the repeater, we'll just create a card, and we can take the heading of the card and bind it to one of the fields, in this case, the company name of the row. We can then bind to the auto ID. So you see we have the full array of fields that are available here, and we have full control over which data gets bound. And that data provider component is so fundamental to Budibase in that it's solely responsible for fetching data from whatever source you define. So this is the top level Svelte application that will actually consume the configuration that we saw previously. Notice how we set up some context here. So there's the SDK, the component context, and all of these are passed down to any component that comes underneath it in the tree using Svelte context. We then have this sort of provider wrapper component here, and then we just render a tree of components. And you can see here how simple it is to actually express that using Svelte. I would wager that it would be considerably more complex to do anything like this in many other frameworks. So I talked a bit there about rendering the tree. And the way we do that is we have that full module of standard components for Budibase, and we import that, and then we iterate through that JSON definition, that JSON tree, and take the identifiers for the components and then render them using their component constructor and the Svelte API. And again, you can see here, we can use the Svelte component helper, and we can express this in quite a simple way to do something that, in essence, is actually quite complex. So let's tie it together by showing a full application. And here we're going to connect to an external SQL database, in this case Postgres, and then use data providers to bind that to tables, and then show the app in action, the actual Svelte application that gets created from the builder. So we just set up our connection to Postgres. We just put in some configuration parameters here. We hit save, and then we add a query. So we're just going to query out a bunch of people from database, and then we do select all from people where name equals, and then we need an argument in here. So we'll just add a dynamic parameter, and we do that by defining the name and a default value, and then we can use our parameter in the query by using this curly bracket syntax. We then run the query for testing, and then just save it. So we can now use that in our front end. So if we go in and we create a form, because what we're going to do here is we're going to set up a text field so we can search against the database and then bind the table to the result of the search. So we'll create our text field, we create our table, we then bind our form to the query, and then we bind our text field to the name, which was our argument in the query. And then we go in here, and what we're doing is we're just binding the value of the input to the argument in the query. So when that changes, it'll execute the query against Postgres again. Let's just pad this out to make it look a bit better. And we can give it a test. So if we type in hello, that's actually doing a query against the SQL database and giving us our results. So let's see the app in action. We get login for free with our platform. You log in, and then there's your Svelte application, which is tied up to a SQL database, and we can then search directly against the database. And you can see how the Svelte reactivity comes into play here, where we just enter some stuff into the input field, and the results get updated in real time. So one of the things that we want Budibase to be is super extensible. And that means that developers should be able to write code in their own tools outside of the builder and then import it back in. So there's a few ways that they will be able to do that. One of which is component libraries, which we want people to be able to build in Svelte, build their own components, build their own charts and tables and things like that, and then import them directly into the builder and provide that definition of the prompts that we saw previously, so they can be controlled through the builder. Templates for apps, their own external data sources through, right now obviously we have Postgres and MySQL and a whole bunch of others, but we want people to create their own integrations, whether that might be through SendGrid or Amazon SQS or a whole host of different integrations that could be plugged in. Authentication providers, we want people to be able to write their own middlewares using something like Passport.js and authenticate against a whole host of different providers. And then automations, which allow people to run tasks in response to things that happen in your application. For example, send an email when a record gets created. So when it comes to future work on the platform, I mentioned earlier that we have been using Vite for our dev experience, but the long-term plan is to eventually move to the fantastic SvelteKit and essentially completely migrate over to that. So we're hoping that'll happen over the next number of months. We'll start to leverage some of the really cool stuff that SvelteKit offers. We also want to do more compile time optimizations. So the more eagle-eyed among you there may have noticed that we iterate over that JSON definition and we use the component constructors, but a lot of that stuff is happening at runtime. So the more that we can move into the compile step, the more performant, lightweight, and generally better the apps that Budibase produces will be. So we see ourselves eventually maybe hooking into some of the compilation APIs in Svelte and hopefully starting to leverage some of the more low-level stuff to get the best possible result out the other end from the builder. We love Svelte at Budibase, and we love working with it every day. We use it for, as I mentioned, almost every facet of our stack. And so far, we are extremely optimistic about the future of Svelte as a whole. It fits our use case really well. And up to now, it is more than production ready with our experience. We've had very little problems with anywhere we've used Svelte, even the sort of more early stuff like Svench. We also find that the way that you develop apps is fundamentally different with Svelte. There's no need for endless libraries. You don't pick a framework and 5 or 6 libraries to go with it. The batteries included nature and the simple APIs actually make it less hassle to just write a certain thing yourself rather than pull in a clunky library to do it for you. And we really like that programming model. As I mentioned before, Svelte is super powerful for building low-code and no-code platforms. The compiled and simple nature of it makes it a fantastic bytecode for low-code apps. And thank you very much. Enjoy the rest of Svelte Summit, and thank you very much for listening.
That was awesome.
Yeah, I liked it.
Low-code tech in general is like making the world more effective at stuff.
Yeah,
and
definitely the future.
Yeah. So how have you found, because you work at Budibase, right, Kevin?
Yeah, that is true.
How have you been that is true. So how have you found that kind of, because you mentioned in Discord that you really enjoyed the stack, the Adobe CSS stack and Ratify, and in Svelte.
Yeah. So before I joined Budibase, I really had no idea about low code or no code stuff at all. Really, I didn't know what it was. Well, I'd heard the term, but it's one of those things that as a developer, at least for me, you kind of like, nah, I don't need that. Why would I do that when I can build it myself? Pretty much, right?
Sure.
But it's actually pretty powerful when you take a look at it, and I like it a lot. The stack, it's very nice. I mean, it's all Svelte on the front end, so I get to work on Svelte all day. That's nice. Yeah, the Spectrum is nice as well. So I mentioned in the chat that we've been rebuilding a component library to use Spectrum fully, and that's been a treat as well. So we've almost like implemented the Spectrum design system in Svelte. I'm not going to say we have done it, but because there are a lot of work around that, but we're getting there at some point.
Is it published
hopefully.
anywhere?
Yeah, it's in the it's all open source. Yeah, so you can go take a look at it. Yeah, if you want, you should definitely play around with it.
Awesome. Yeah, I will be. Cool. So we've got the only talk with an emoji in the title next.
Yeah.
And then we've got the update on SvelteKit, which I know everyone's quite excited for.
Yeah, I think everyone's excited about that. All right, I'll put on the Zwoosh YEAHHH Shabam, Whimsy and Motion talk. All right.
Hi, I'm Ron, and this is Zwoosh YEAHHH Shabam. Whimsy in motion. That's a lot of words, but the main ones are whimsy and yeah, because we're going to have a bit of fun with this talk. So, what is whimsy on the web? I'd say it's a measure of added playfulness, usually visual. It could be a quirky font, it could be a whimsical art style, or even a well-placed animated GIF. You might replace a straight line with a bit of wiggliness, or introduce transitions to some static icons. In all cases, the purpose of whimsy is to add delight. Here's how some folks have done that. Jason Lengstorff exploding his head. Wes Boss greeting users with wide screens. Josh Como's call to action figure. My site activating dark mode. Cassie Evans following your mouse around. So as you can see, Whimsy takes on many different forms, and this talk focuses on motion. But how do we leverage Svelte for that? Well, Svelte was born on news sites in a manger surrounded by interactive articles. So fortunately for us, it's had transition functions out of the box since version 1. And to take you through some of these tricks, I wanted something more exciting than a few boxes to move around the screen. So motion warning, things are going to be flying all over the joint. And there's no rapidly flashing lights, but there is a single, slow, very bright flash towards the end. I'll warn you again once we get there. And the most frenetic, exhilarating, outlandish web experience I could think of was a landing page for a file converter. There's a basic before and after comparison showing example file sizes, an input button for files, a button going to the About section, testimonials for social proof, the aforementioned About section, and a back to top link. Now, you might think this before and after slider is bugged, but if you input a 2.3 megabyte JPEG, you're going to get a 2.3 megabyte JPEG. It's a landing page with a 100% conversion rate. And we're going to spruce it up using tools in the Svelte toolbox. Now for your own sites, you might be worried that adding Whimsy will turn your whole site into a circus fair and be too silly. But you don't always have to go all in at all times. Just the same way we have progressive enhancement, we can have progressively enhanced Whimsy. PEW for short. Instead of feature support though, it's based on your willingness to be playful. So let's start with something simple like this H1 over here. To quickly run through the structure, there's the header, testimonial, About section, and footer that we saw earlier. In the header, we have the before and after component called compare, and the convert animation in its own component, and the file input button. In the testimonials, we have testimonial component for individual testimonials. We have the panel that was the board that housed the heads, and we have everyone in their own Svelte component, which is actually an SVG. We also have Svelte stores, utility functions, and all the code that's managing the IndexedDB that's running behind the scenes. So let's dive into the header and whimsify that H1. There it is. For this little bit of motion, we're going to combine two things, an app prop and an in transition. The in transition is just a fly. We're moving from the left, going for 1.5 seconds and getting a bit bouncy towards the end. The real magic is in main.js, where we use the app prop. So head on over to there and add this little prop and set it to true. What this does is trigger any transitions that aren't contained in an each, if, await, or key block, and do it on page load. So if we head on over, refresh, and Whimsy. If all you want to do is add a dash of motion as people come in through the door and go, hey, we're not completely static and lifeless, that's all you have to do. Have fun exactly once, then carry on with the rest of the site, business as usual. You may have heard that good design goes unnoticed or that it's invisible. That applies to layout, typography, color. When it comes to motion, you can definitely be noticeable and visible. Just be in theme and don't be jarring. There is one rule of thumb though. Don't get in the way. Here's the compare component. We could add a transition that flings the handle in for a bit of fun and to hint that it's interactive. Let's see what it looks like. Well, watch what happens when I try to grab the handle before it finishes. The way it's been implemented, it prevents expected behavior and gets in the way. Users will wait 2, maybe 3/5 of a second before they get frustrated. So no matter how much you like your animation, it's not worth it. So let's comment this out and have a look at something that users would like to have. Their heads. Sooner or later, if you muck around with web animation, you're going to run into SVGs. So first off, if you weren't already aware, SVGs aren't binary gobbledygook. They're structured markup. So if you can write hypertext markup language, you can write SVGs by hand, and you can make them reactive with Svelte. In fact, to convert an SVG into a Svelte component, here's how you do it. Rename it to .svelte, and for step 2, marvel at the fact that there's no step 2. Let's head on over to our panel SVG components. You'll see we have a slot where our user's head belongs, but you can't apply Svelte transitions to a slot. So the trick is to apply a DOM wrapper, which in SVG is the group component signified by G. We've got another simple fly transition, this time coming up from the bottom. Let's see how that looks. Whoop, fresh, and ta-da! Now, the second half of the equation, of course, is detecting when the panel is in view to trigger the transition. You could use scroll position of the window, you could use top value of the get bounding client rect, or you could use intersection observer. That's what I've chosen to use. In util.js, we just have a Svelte action that runs a callback you provide whenever the element you provided is intersecting enough. And to use the action, you use the action. And this here is just saying, once it's 75% in view, set intersecting to true. So if we scroll to 75, there's Raj, and there's the other two. Q is coming along a bit more now. Pew pew, if you will. Now, I have to warn you about this next section. We're going to have to spend a bit of time with some disturbing imagery. Viewers aged 200 and below are advised to seek mental health if needed. Bear with me, it's for educational purposes. Physics-based scrolling to animation. That's what we're doing. Sounds cool, huh? Svelte, once again, makes this super easy for us because it does it all right out of the box. So let's head on over to our About component. To create fancy scroll linked animations, just bind a value to the Windows scroll Y. So first, declare scroll Y, add the special Svelte window element and bind scroll Y to that, and then value self of it. Here I'm just shoving it straight into a transform property. So to see how it works, ta-da! Whoop, woo, whoop, woo. Scroll linked animation in 3 lines. But wait, there's more. We can make this really whimsical by adding physics, which doesn't mean we're going to have physics collisions and fluid simulations. I tend to think of it as momentum. Import spring from the motion module, set a variable and provide options to it to your liking, create a reactive statement that changes whenever scroll Y changes, and finally, value yourself of it. Look at that. Hi there, hope you're enjoying my Svelte talk. I just created a scroll-based, physics-based animation in just 6 lines of code. Ha 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 ha. And now, you have the power to do the same. But with a buttload of power comes a buttload of responsibility. You might have noticed these commented out lines as we've been going through the code. Let's enable this one now. And you see everything's the same except that the X distance is surrounded by this motion gate function. Not all users can or want to see things jumping all over the place. So if they've set prefer reduced motion, we should respect that. So if that's the case, this function will return 0. Everything else is the same, that it's a fly function and the duration is 1.5 and that it's going to bounce out only the X distance. I've just set that preference on my computer, so let's see how that H1 transitions in. If someone has prefers reduced motion set, then that X value is going to be 0 and they get a fade instead of that bouncy effect we had earlier. In main.js, we query the preference using window.matchMedia and then we set it to a store called reduced motion. And just in case the user changes that preference before they've reloaded the page, we also listen for the change so it's always up to date. Now, the reason we've put it here in main.js is so that all our transitions are aware of the preference. And that includes the intro transition that we added earlier, because that loads immediately and we want to make sure prefers reduced motion is respected right from the beginning. Over in stores.js, reduced motion is just a custom store with a gate function. It's a gatekeeper for hire that sets everything to 0 if reduced motion is true. Otherwise, you can set the fallback to whatever you like. So the store itself is just a Boolean. The gate function returns 0 if prefers reduced motion is true. Otherwise, it lets the gated value through. And for both the gated value and the fallback, you can set it to whatever you like. So why bother with all this when we could just set all transitions and animations to none? Well, the preference is reduced motion, not devoid of motion. Confer with your audience, but the main problem motions are ones that are too fast, too large, or unending, which means we can still fade things in and we can still use small motion like a tiny transition when you press down on a button. If we just disable everything for users with accessibility preferences, we'd end up with something like this. So in our About section scrolly head physics thingy, we could gate the spring value. In the testimonial panel, instead of gating just a single value, we could use the store boolean and conditionally apply the entire options object. So if someone has reduced motion, they'll get this fading transition. If they don't, they get this standard bouncy flying thing. In a moment, we're going to animate the converter's progress with a squashing animation, and we'll disable that for reduced motion users. It wouldn't make sense to display squashing as a status message. So in that case, we'll fall back to something that makes more sense, depending on who you ask. So squashing animation. Right now, when you convert a file, it kind of just hangs there. Then into convert.svelte we go. When the component is mounted, it shows a box until conversion progress is no longer true, and then it replaces it with a link. We've been using fly transitions and fade transitions, but sooner or later, you're going to want to spread your wings a little and do something custom. So to add a little pop to the finish and give the box some character, we're going to do just that. Here's our custom function. When the conversion's finished, we transform the box from a squashed, short, and wide shape and back to one that's 1 by 1 in dimensions. The translate Y makes the box jump from below 0 as if it's popping up, and the rotate just gives it a bit of a wiggle. Elastic out gives it that animated life kind of feel. We used it before in the testimonial heads as well, and in my opinion, it's the best easing function. It undulates and spills over the min and max values, so it's just got Whimsy written all over it. And for reduced motion, we return the original fade function. Add the transition to the box. And let's see how that looks. Boing. That's definitely a 2-pew animation. But we still haven't done anything to show the progress of the file conversion yet. Once you start making more complicated animations, you'll inevitably hear hallowed words like staggered and chained. And you can reach for external libraries for that, but if you've been following along, Svelte gives us enough tools to do that in-house. So, showing file progress. There's a lot going on here, so it's probably best you just saw it with your own eyes. Convert a file. And that's how converted files are made. It looks convoluted, but that's what I do, and I want to show you guys how far you can stretch these ensemble type transitions. Okay, so there are 3 main ingredients to this: transition events, class directives, and index-based values. Starting with transition events. When this fade transition finishes, it's going to fire this transition event, which starts the whole unboxing progress. And with unboxing in progress being true, it chains to this whole block, mounting it. We have an object with length 4, which we're using as a range, 3 for little shoes and 1 for the big one. And because the index begins at 0, the third one is, well, index 3 is the big shoe, which applies this class directive. And using that, regular old CSS, that does all the beginning. For positioning though, we have to use inline styles to make use of the index. If it's 3 and the big guy, it's 25% from the left. Otherwise, for each of the smaller shoes, each shoe is going to be further offset than the last. 42.5%, 62.5%, and 82.5%. The transition that actually moves the shoes flies down from above, and instead of an in or out transition, we're using the full transition so it knows to fly back up on the way out. The juicy bit though is in the delay. In the same way that the left positioning was offset by the index, the timing of the shoes is staggered by the index-based value here. Each time one of these shoe transitions ends, it checks for 2 things. If it was the 3rd shoe or later, start shaking the box. If it's not the last shoe, continue unboxing. Otherwise, set unboxing in progress to false and unmount the whole block. And that brings us back to our original finish transition, which we transitioned from wide and short, so it looked like it was transitioning out of a squashed state. To cater for reduced motion, we skip the shoes and we fade out the boxes more smoothly. For your efforts, you get custom staggered chained transitions in Svelte. Finally, I want to make a point about footers. The footer is where your users reach after they've read all your writing, seen all your photos, mulled over your design, and checked out what they came for. This is the time to sneak something in. Since this is the last transition, for fun and demonstrative purposes, I'm going to make this back to top link egregiously excessive. How much whimsy can you shove into a back to top link? This is mostly the native web animation API and not Svelte code, so I won't go into it. But take one look at this and tell me you don't know that some serious is going to go down here. A lot of things are going to happen, so motion warning, large areas of the screen are going to move around and there'll be a bright flash. Don't try this at work. Bet you fortunately haven't seen that before. So there is such a thing as too much whimsy, or at least too much motion. And because it's so fun, it's easy to be reckless and shove whimsy into every nook and cranny. If all you have is a hammer, everything looks like a nail. The point of this was to show that from a quick and easy fly transition all the way to unmitigated chaos, you can find a place for whimsy. I hope this all gave you tricks up your sleeve or ideas to add whimsy to your work. There's so much you can do in so many places, and Svelte makes it so much easier. I hope you all make more wacky stuff. On Twitter, I'm Ron Valuted. The repository is public. The demo is equally public. I'm Ron Au, and thanks for watching Zwoosh YEAHHH Shabam. Whimsy in motion.
Wow, wasn't that fun? Oh, what are you wearing? Do you have a hat now?
Whimsy.
Oh, right. That's amazing. I love his talks, man. His last talk at the other Svelte Summit was also amazing.
Yeah.
I'm gonna post it in the chat if you haven't seen it yet. Yeah. So fun story here. I already posted this in the Discord, but Ron actually didn't manage to finish his talk because of some issues. So he gracefully managed to send it to me like 2 hours ago. So
yeah,
that's nice. Good on him.
Good for him. We all benefited from the.
Yeah. And then everything was top notch.
Yeah.
All right. So I think we're here for the last talk of the day, and that's the SvelteKit update. Should we just get into it?
Yeah. I'm excited.
Yeah. All right. Let's go. Just need to find the file.
You need to find the floor button, I think.
Where is it?
It's
not here. Ah, did I misplace the file? Oh no. Crap. Now I'm panicking.
Quick, technical difficulties screen.
Can you imagine just like me losing this?
Why don't you take a 2-minute break and just put up the main screen, and we'll or we can even take a minute. Yeah.
It's not going to take that long. I'm going to find it.
Yeah.
Forgot what I named it. Oh, it was going so well up until now. I knew something had to. Oh, there it is. Let's see.
Yay.
Yeah. All right. Here we go. Here we go.
Joe says, "We need you dancing in the meantime."
With a SvelteKit status update, because no one wants to hear me talk about anything else these days. Just to get the bad news out of the way, first of all, we are not at version 1.0 just yet. Really wanted to get there in time for Svelte Summit, but there's just a little bit more that we need to do before we can deliver a really polished experience. But the good news is I think it's really going to be worth the wait and that you're going to enjoy what we've built. Thank you so much to everyone who has contributed and tried it out so far. If you would like to become one of the beta testers, then just keep watching the video and you will find out how. Now, some of you might be wondering, what is SvelteKit? Well, Svelte without the kit, as you probably know, is a component framework. It's a way of building little bits of reusable user interface. But what it isn't is an answer to the question, what next? How do I take these bits of UI and build an app out of them? For a long time, we had two slightly half-hearted answers to that question. We would point you towards the Svelte template, which was built on top of Rollup, and it didn't really do a lot. It was flexible and it was simple and you could get into it quite quickly, but it didn't answer a lot of the questions that you would encounter as you built your app. The alternative was Sapper, which did a lot more of the heavy lifting for you, but it was a little bit inflexible and a little bit too opinionated. SvelteKit aims to fill that gap and provide a de facto standard way to build apps with Svelte. Some frameworks delegate that to third parties. For example, React has projects like Next and Vue has projects like Nuxt. And those are all well and good, but it means that if you're building an app with React or Vue, you have a difficult decision to make before you can actually start building your app. And if something goes wrong, you might not be working from the same playbook as everyone else using that framework. At the other end of the spectrum, we have things like Angular and Ember, which are app frameworks to begin with. The flip side there is that there is less flexibility and you don't have third-party experimenters who can elevate the community as a whole. Svelte wants to have both. We want to have this ultra-flexible core that can be used in projects as diverse as Jungle and Plentico and Elder and Routify, but also to have a blessed fast path for development, and SvelteKit is intended to be just that. So what does it mean to say that SvelteKit is an application framework? Well, to a large extent, it boils down to having strong conventions. We use file system-based routing, which is powerful and flexible, but also really intuitive. We have a predictable, easy to navigate project structure. We have built-in ways to achieve common tasks. And the things that don't need to be unique between different apps, generally speaking, aren't unique. They're taken care of by the framework, which means that you, the developer, can spend more time on the things that do make your application unique. It means that we have a pre-configured development environment. You don't need to waste time writing build configs, hot module reloading, TypeScript, all of that stuff is taken care of. And we also have solutions for deploying the application to different environments with the flexibility to accommodate any more that are created in future. And because it's Svelte, it's designed to scale down as well as scaling up. It has a built-in router, but you can disable it if you don't need to use it. In fact, JavaScript is entirely optional in SvelteKit. And because it's Svelte, you don't pay a hefty upfront framework tax. There's also a slightly more philosophical answer to the question, what is SvelteKit? And that is that it is an answer to the critiques of modern web development that have been surfacing in recent years. It's become quite popular these days to decry modern front-end development as being absurdly complex and brittle. And there are three basic factions that we can identify. The first of these factions is the sort of back to the land movement of artisanal HTML and CSS, people who reject tooling in all its forms. And to be honest, I don't take this group particularly seriously. They say they reject tooling and yet they still use version control and dev tools and editors with syntax highlighting. So they've just decided to draw an arbitrary line between what they consider to be tooling and what they don't, that to be honest, just makes it harder to build stuff. At the other end of the spectrum though, we've got things like Phoenix Live View, which is a server that sends deltas to the page over a WebSocket that means that you don't need to have any logic running in the client at all. It's super cool and I recommend at least spending some time on the website getting familiar with the concept. But it does have some fundamental limitations. Your app can't work offline, for example. It's not really suitable for anything involving 60 frames per second animation because of the latency involved in data coming over the network. And I haven't researched it, but I would expect an app built that way to have greater bandwidth usage and things like that. Nonetheless, it's really interesting stuff. In the middle, we have people who suggest using traditional frameworks like Rails with a little bit of JavaScript sprinkled on top. And these are perhaps the most vocal and the most convincing people. Again, though, I think that this approach has some fundamental limitations. I would say that the flagship app of this movement is Hey, the email app from Basecamp. And I'm a Hey user. I love the product philosophy. I think it's a really great idea, but I don't love the app. I find that when I'm using it, the UI is a little bit sticky, and I've heard from people in places like New Zealand and Australia that it's essentially unusable for them because every interaction requires communication with a server. It gets a great Lighthouse score, but it turns out that's not strongly correlated with a great user experience. Another app that's commonly cited in this bucket is GitHub, And I'm always surprised that people want to use that as an example, because frankly, it is one of the buggiest apps that I use. I have to hard refresh GitHub constantly because I have learned that I cannot trust it to not show me stale data constantly. And the other limitation of this approach is that either your team has to be fluent in 2 languages, the back end and the front end, or you end up having a split between teams that is catastrophic for productivity. You start needing to have meetings to get stuff done. The thing is, no other platform besides the web expects developers to write the initial view in one language and then subsequent updates in another language. Having the app run close to where the user is has important benefits. You get instantaneous interactions, you can keep stuff in the client storage, and we can free ourselves from the idea that navigating around an application means teleporting between discrete pages rather than navigating a continuous space. This is a design space that we haven't really been able to explore yet because our imagination has been limited by our tools. All that said, there are some valid critiques of mainstream front-end development. We do ship too much JavaScript a lot of the time. If we're not using server-side rendering, then we're harming SEO and initial page performance, and we're mandating the use of JavaScript. I happen to believe that most apps should be mostly functional without JavaScript, and that is very much not the case at the moment. Single-page apps and their server-side rendered cousins don't handle long sessions well. This is something that we need to get better at. And frankly, our tooling is pretty darn overbearing. So SvelteKit is our best attempt to respond to all of these critiques. We want to show you that you can build your app in a coherent way with a single language, using conventions that are widely understood by the users of the framework, that scales down to single-page brochure sites and up to highly ambitious applications, that frees you from the limitations of traditional web development, but with none of the downsides of modern mainstream front end. All right, so with that preamble out of the way, let's take a tour of SvelteKit. We're going to begin by going over to kit.svelte.dev, and I want to take a moment to acknowledge the beautiful design and illustration work here by Akeem. Apologies if the pronunciation is off. I think this is absolutely beautiful work, and we're going to be overhauling the Svelte website as well in the near future. This has all of the documentation, and if you have a Sapper app, there is a migration guide for you as well. But for now, we're just going to go down and copy the quick start down here. So I'm going to open the terminal and do npm init svelte at next because it's still in beta. Obviously, once this is released, it'll just be npm init svelte, and then we'll give it a name of a folder to write to. First thing we see is a warning. This is beta software. Expect bugs and missing features. The same thing kind of applies to this talk. There are some things that I'm going to show you that will almost certainly change before we hit 1.0. So it's asking me which Svelte app template to use, the demo app or the skeleton project. We're going to use the demo app this time. Once it's no longer your first rodeo, you might want to choose the skeleton project instead. For now, we're just going to hit enter. Not going to use TypeScript right now, or ESLint or Prettier, but those are obviously things that you can set up if they're useful to you. So it's created the app. All that remains is to cd into the folder npm I. It'll just take a second. Then we can do npm run dev -- open, and it will open the app in a new tab. Okay, but I'm actually going to close this and open it in a code editor so that we can look at what's going on under the hood. Okay, so the app's now running in the VS Code integrated terminal. It's a pretty straightforward app. We've got a little home page here with a welcome banner and a counter, because what kind of demo app wouldn't have a counter? And it's telling us to try editing source root index.svelte. That is the component that defines this page. So we'll open that, source roots index. And I'm just going to hide the file explorer so we can get a better look at what's going on here. And you'll notice that this basically resembles what's on the left. We've got some markup here that describes this area, and we've got an H2. And if we do what it says, try editing that and then save, you'll see that it updates basically immediately. In fact, if we turn on autosave like that, I've got it set to a 1 millisecond delay, then you'll find that basically every keystroke results in an instant update to the page. Once you've experienced this kind of immediate hot module reloading, it's really difficult to go back to any other way of working. So the counter component looks like this. This is all the code that is involved in making that nice spring animation. Down here we've got some styles, and a really cool thing about the hot module reloading in SvelteKit, thanks to Dominic and Rixo, who built the Vite plugin for Svelte and Svelte-HMR respectively. If we make changes to the styles but don't make changes to the rest of the component, then we always preserve the state and we only update the styles. So if I just set that to some high number there, and then find the, here we go, the color that controls that, the orange of that number 15 there. Let's make it green or something. And then if I use the color editor in here, I can just like click around and find a nice different color. I think I'm going to go with the deep purple. I think that looks pretty cool. And it's instant, and you keep your state. It's a really magical experience. All right, let's build the app with npm run build. Vite's going to package everything up. No adapter specified, it's saying down here. We'll come to that in a minute. For now, it says npm run preview, so let's do that. So now if we reload this page, we're looking at the production build of our application. Let's go over to the about page. This is a SvelteKit app, blah, 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 npm init svelte at next. We did that. The page you're looking at is purely static HTML with no client-side interactivity needed. Because of that, we don't need to load any JavaScript. Try viewing the page's source. Okay, let's do that. Right-click, view page source. And you can see here that we've got some style sheets that have been linked, and we've got some markup that looks familiar, but there's no script at all. Let's take a look at the source code and understand why that is. So the about page is easy to find because it's a file system based routing, so we know exactly where we're looking. About.svelte. We can see that at the top here, we've got this block saying export const hydrate equals dev, export const router equals browser, and export const pre-render equals true. And let's explain each of these in turn. Firstly, what do we mean by hydrate? Well, hydrate is what happens when the client-side JavaScript loads in the page and takes over the HTML that was server rendered. And on this page, because we don't need any JavaScript, we're turning it off in production, but we still want to be able to hydrate in development so that we get hot module reloading. And if you're not hydrating, then the only thing that you need to load JavaScript for is the client-side router that is bundled with SvelteKit. If you turn that off, then you don't have any JavaScript at all. Here we've got export const router equals browser, which doesn't mean turn it off in all situations when you're on this page. It just means turn it off when you're server rendering. And what that means is that if we're on the about page and we refresh, then when we navigate away to another page, that's not going to be handled by the client-side router. It's going to be handled by a traditional page reload. And if you look at the reload icon up here, you'll see it spin when I click on another link, like so. If I go to home, you saw that turn to a cross briefly. If I go back, then you don't see that because client-side navigation is happening. And because the router is now initialized, if we go back and forth between these two, again, we don't see a full page reload. It all happens client-side. Finally, we have export const pre-render equals true. What that means is that because there's no dynamic server-side rendering that needs to happen here, whichever adapter we end up using, no matter how we end up deploying our application, we can bake out this page as static HTML. All right, let's take a look at the to-dos page. So it's a very standard to-do app. I'm going to tap here, do this, do that, do everything. And if we refresh the page, we'll see that the to-dos are still there. In fact, they are being server rendered. We can verify that by viewing the page source and searching for do everything. And so you can see the markup is there. It's actually on the page. The data is being stored on api.svelte.dev, which is a Cloudflare worker that we've spun up so that you can test this out when you clone the app without having to set up a backend yourself. So let's take a look at the source code for this. Again, it's easy to find because it's file system based routing, root/todos/index.svelte. And we can see here that we have this load function. And a load function, it's something that runs when you server render the page, and it also runs when you hydrate the page in the client. But we're not fetching the data twice. We're fetching it for server-side rendering, but we're not fetching it again for the client-side hydration, although we would fetch it if we were to navigate back to this page from somewhere else. And I'm going to show you how that works. Down at the bottom of the page, we can see this script type equals svelte data, URL equals todos.json. And the contents is basically the result of requesting that data in the first place. It's been serialized and added to the page. So we're not serializing application state like some frameworks do. We're serializing the resources that the page depends on. And there are a few benefits to this. It guarantees consistency between server and client renders. It saves network requests because obviously everything is baked into the page. And it's actually not wasteful because the beauty of compression algorithms like gzip is that data that appears multiple times in a document is essentially free. So even though this looks duplicative with the markup, we essentially get it without having to pay for it. And we can, of course, inspect that data directly by going to localhost 3000/todos.json, and we can see the raw data that powers this page. So let's take a look at the code that is generating this list of to-dos. In SvelteKit, you don't just define pages inside your routes, you also define what are called endpoints. These are functions that respond to requests for data. So this index.json.js, because it's in the to-dos folder, corresponds to todos.json. And you can see that we've got a function called get and a function called post. I'm trying to minimize the terminal so that we can get a look. And so when we visit todos.json, we're invoking this get function. And you can see that we're calling an API, which is defined in the same directory. And it's calling api.svelte.dev with this request, todo/request.context.userid. And that comes from a file called hooks.js, which we'll go over and take a look at. Hooks is a place where you can put code that is going to run on every single request. You can export a get context function, which takes the incoming request and turns it into what we call the request context, although we're probably going to change the name because we've got a lot of things in SvelteKit called context and it's a little bit confusing, but for now, let's just roll with it. So right here, we're passing the cookies attached to the request, and if the user already has a cookie for this site, then we store it on the context. Otherwise, we give them a new one that's just a random number, essentially. And then later, once the request is complete, we add a set cookie header to the response, using that same user ID, applying it to the entire app, and marking it as HTTP only because all your cookies should be HTTP only. This handle function, this is essentially the meat of your entire application. You don't have to define it. If you don't, then it will fall back to a default, which is just to render the request using this passed in render function. But if you want, you can manipulate the request in various ways and you can manipulate the response. So here, if we've identified that this is a new user who doesn't yet have a user ID, that's when we apply the set cookie header, and that makes request.context.userid available to every endpoint, including the one that's generating the to-dos. Now let's talk about forms, because this is something that a lot of us get wrong a lot of the time. I'm going to go back to the to-dos page and I'm going to disable JavaScript on here. Go over here, down to disable JavaScript. I'm going to reload the page and I'm going to add another to-do. Hello. This works without JavaScript. If I turn JavaScript back on and reload the page, then this works with JavaScript, you'll notice that this time when I submit it, the to-do is going to have a nice client-side transition, like so. Now, it's interesting to see what's actually happening under the hood when we post that data to the endpoint. Let's go back to our to-dos endpoint and put some logging in this post handler. Console.log request.raw body to string. I'm going to bring the terminal up so that we can get a good look. Clear the terminal so that we can see it more easily. I'm going to add a to-do here, test. And you'll see we get this, this multi-part form encoded payload when we submit the form using fetch from the client, and I'll show you what that looks like in a moment. If we now disable JavaScript and refresh the page, add another test, this time it looks like this. We get a completely different encoding of the form. And this is really awkward to deal with as web developers. Like if we're trying to make something that works without JavaScript, but also can be progressively enhanced with JavaScript, it's a bit of a pain if you need to worry about parsing these different body types or installing the correct body parsing middleware, etc. So SvelteKit takes care of all of that for you. We can replace the request.rawBody with request.body get text. And this time, regardless of whether JavaScript is enabled or disabled, we get the actual data being passed to our endpoint. Let's take a look at the actual markup involved here. Here we have a form with an action that points to the todos.json endpoint and has a method equals post. And that is all you need to have a functioning form in SvelteKit. We could delete the rest of this, which we'll look at in a second. And the whole thing will continue to work. It still works. Right, and it still works has been appended to the bottom. And that's because HTML forms work without JavaScript. It's one of the great things about them. And again, I think we should be building apps that work without JavaScript as a default. But it's a better user experience for the users who do have JavaScript if you can, rather than reloading the page after you've submitted some data, if you can progressively enhance your app with some native client-side behavior. And that's where Svelte's actions get really useful. I've added an action to this form called enhance. Enhance is this really easy way to add client-side behavior to a form without breaking the browser defaults. I'm just going to go and take a quick look at that. So the way that actions work in Svelte is you pass in the element itself and some options, and this function runs when the element is created, and we can return some logic that gets run when the element is removed from the DOM. And so what it's doing is whenever we submit data via this form, we prevent the default so that it doesn't reload the page. We create some data using new form data. And then if a pending function has been specified, we call it. Then we perform a fetch, and we either call the result function if it succeeds, or we call the error function if it fails. So for this new to-do form, we only have a result. We haven't defined the error function, which is a little bit naughty. But this is what's going to add the to-do to the end of the list without reloading the page if we have JavaScript available. We create the to-do by posting the data to the API, and then we just update the list accordingly. And after that's happened, we reset the form. And just to show that one more time, and it's been added there to the bottom. And we can also use this technique to perform optimistic updates. These toggle buttons here, if I click these, then they update immediately instead of waiting for the data to go to the API and come back again. This is the form that's making that happen. And again, we have an action to do to-do-uid.json. And then we have this slightly odd thing, underscore method equals patch, method equals post, before we invoke the enhance action. So here's the thing about forms in HTML. You can only use the get method or the post method. For some reason, forms don't let you use patch or put or delete or any of the other methods that form HTTP. And we've looked into this and the reasons aren't particularly convincing. And so what a lot of frameworks do is they allow you to override the method. And a common way of doing that is by appending this underscore method equals addition to the query string parameter. And so we're doing the same thing, and I can show you where that's taking effect. Back in our hooks.js file, we're actually intercepting the request and we're overwriting the method if the request query has been specified. Ultimately, I want this to be part of the framework because I don't think it's stuff that we should have to worry about when we're building apps. But for now, this is kind of useful because it shows you some of the flexibility that you get with Handle, that we can actually manipulate requests on that level by overwriting methods. So anyway, in this case, rather than waiting for the request to come back, we're just going to execute this pending function immediately, and it's just going to set the done state of the to-do, just like that. And so you get that nice instant feedback. Okay, so the final piece of the puzzle is what do we do when we want to deploy this? Well, we saw earlier that when we built the app, it told us that we needed to add an adapter. So let's do that. Let's install the Vercel adapter, svelte.js/adapter Vercel. And then I'm going to go into my Svelte config and I'm going to add that adapter to my config. Const adapter equals require Vercel. I have no idea what's going on with these messages down here. Go away, I'm trying to do a demo. Ugh, VS Code, leave me alone. So we're just going to call the adapter, make a new instance, and then pass that to our Svelte config. This time, if we do npm run build, I know what happened. It's because I installed the latest version when I should have installed the next version. 1 second. Try building again. And you can see now we have this Vercel build output folder up here. This has a static folder with some static assets, including our pre-rendered pages, the index page and the about page. We don't have a todos.html in here because that is going to be dynamically rendered by this serverless function, which is defined in here. If I now use the Vercel CLI, I should be able to deploy this. Let's just type Vercel and see what happens. Yes, please. Do it in my personal scope. No. Svelte Summit demo. It's right here. I'm going to leave the settings alone. Okay, it's given me this URL where I can check on the deployment progress. Hopefully this won't take too long. Okay, so just under 30 seconds and we now have a production version of our application working on Vercel. And of course we can navigate between these pre-rendered pages, but we also have the dynamically server rendered to-dos app with a brand new set of to-dos because obviously my cookies haven't been transferred from localhost. 1, 2, 3, magic. All right, so let's wrap this up. There's a bunch of stuff that I haven't been able to show you in this talk, and there's a bunch of features that are still to come. But hopefully some of what I've shown you is exciting. And if that's the case, we would love to have your contributions as ever. So I hope to see some of you on GitHub and Discord. Thank you for watching.
That was exciting.
Yeah.
I don't know. I don't have any words.
It makes me a bit jealous because now I have to go on portal maps across, and I'm dying to do it, and I have other stuff to do. So,
yeah. Let's see here. See if Rich is ready. And can you nod if you're ready? Yeah. All right. Hey.
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 Hey, gang.
Welcome to the summit.
Thank you. Thank you, and congratulations. It's been a terrific day.
Yeah. Thanks. It's been a lot of fun.
Good Whimsy.
Yeah, that talk was great.
Thank you.
Sorry. All right. So, does anyone have any questions for Rich? I have one.
This is in Discord, everybody. We might
I should have that open in a separate window.
Yeah, that was good.
I can help keep track too.
Cool. Let's check.
I don't know if you caught the puppets, Rich.
I did, yeah. I missed a bit of the middle of the conference, and I'm going to have to catch up later, but I saw that. It made me
They seem to have struck a chord.
Yeah.
Been posting puppets all day in the Discord. It's great. There should be a custom emoji for a puppet, for the snake puppet.
Yeah. Mm-hmm.
Oh, nice. Right. Let's see here.
So Rich, when do you think SvelteKit 1 is going to be released?
Oh,
going straight for the
yeah, right.
Yeah.
Jugular time.
I mean, if you'd asked me a month ago, I would have said April 25th for sure. Like, what could possibly go wrong? But it turns out it's just like really hard. There's a lot of work that is involved in building a thing like this, and work being work and life being life, stuff sort of gets in the way. But like the fact that there is so much to do, I think is kind of the reason that something like SvelteKit is so valuable, right? Because all the things that we're putting into the framework is stuff that you would have otherwise had to figure out in your apps. And like the hope, the idea is that as you're using it, you're not even really aware of all the stuff that it's doing for you. It's like they say that the best visual effects in movies are the ones that you're not even aware you're seeing, because they don't take you out of the story. You're not like thinking, oh, like that was maybe the computer. It's just like seamless. The idea is that when you're using SvelteKit, it'll be so seamless. Like all of the design decisions that have been taken, hopefully are going to be the sort of obvious in retrospect. It couldn't have been any other way thing. Well, actually, they're the result of like fierce discussion and experimentation among the core team and people who are currently trying the beta version to get us to that point. And all I can say is, bear with us, please.
And if you have strong opinions, go and share them on GitHub issues, right?
Absolutely.
Yeah.
And there's been a ton of really great feedback on GitHub already. Like I remember when we first opened up the repo, because we were developing it behind closed doors for a little while, because when something is very kind of still up in the air and you're not sure what shape it's going to take, it's much easier if you can do that without prying eyes. And we did that for a while. But the thing about private repos on GitHub is, unless you're paying for them, you only get a certain number of minutes each month to run your actions. And we like making heavy use of CI to do our tests and everything. And we keep running out of our minutes on like the 4th day. So eventually, like having turned off the Windows test runners and the Mac OS test runners, eventually we're like, this doesn't work anymore. We're just going to have to open the repo, thinking that we could sort of do it on the sly and would have a little bit longer before people started to notice. Within 25 minutes, there was a post on the Svelte Reddit, on the subreddit, saying,
they're fast.
Come on in, guys.
And there was the whole secret, the secret, what do they call it? The docs, the unofficial docs appeared
Yeah.
Oh yeah, McGregor.
Yeah, which are absolutely terrific. I mean, Greg has got a real flair for writing documentation.
Definitely.
And like he's now on the core team, so
he's now one of us.
He is one of us. One of us. Yeah.
I saw a so there was a funny comment left somewhere on some issue or some PR about letting in the barbarians.
Right.
That was funny.
Yeah.
All right. So we have some questions here.
I'm seeing quite a bit of conversation about why hooks.
Look, just because React decided to take that word and use it for in some strange way doesn't mean that like we shouldn't, like the rest of the programming community shouldn't be able to use it the way that it was intended. Like a hook. This is what a hook is. It's a way of hooking into a life cycle or a program, the execution flow, and like get context and get session and handle, like these are hooks. They're not React hooks, but I feel like that we should refer to hooks in React as React hooks, like maybe with a little TM symbol afterwards, because they're the ones who chose to take the word and ruin it.
Yeah. All right. So one question here that popped up is it's prompted by the Snape puppet. What Hogwarts house would you be? What do you think?
I mean, someone's gonna have to tell me, because I'm not a Harry Potter person. Which is the good one?
You can actually take an
which is the
online
best
test
house?
which will tell you which one you're in, and it's written by JK herself. Well, it's the one on the Pottermore site is by JK herself, and I know because I wrote it. So basically what it is she wrote a spreadsheet of all the answers and stuff. When you fill that in, it goes through all the columns and goes that one. So that's the official answer. It's worth doing.
Did you actually work on that?
I actually wrote it, yeah.
That's hilarious.
So what you're telling me, Anthony, is you created the sorting hat.
Not quite, no. The whole back stuff is all JK.
Sure.
All right. So can we expect more adapters? People are asking about AWS Amplify. I saw
definitely. Yeah, so we started with adapters that like we already know people use platforms like Vercel and Netlify a lot, and they were just like easy targets to begin with. Cloudflare Workers is one that we're particularly excited about. Begin/Arc is one that we've made a start on, but there's a little bit more to do there. But all of these things are sort of Lambda-ish or Lambda adjacent, and so Lambda is certainly going to be well supported. We're very excited about Cloudflare Workers, not least because a core team member is now a developer advocate at Cloudflare, Luke. Yeah. So it's always nice if you know that if you need to kick up a fuss about something, why isn't this working? Then we've got a direct.
Yeah. I was actually, I almost like messaged him today to complain about some login issue on Cloudflare, but then I decided maybe I shouldn't.
Yeah, the poor bloke doesn't know what he's got in store. We're gonna abuse that connection.
Yeah, he was basically a developer advocate for Cloudflare though before this.
Yeah,
especially
right.
Super Cloudflare fanboy, and that's. I mean, I love Cloudflare too, but I can't find my way around it at all. Like it all goes way over my head. But because Luke is A, very enthusiastic about Cloudflare, B, legitimately a genius, and C, the most generous and kind person any of us know. Like he's sort of brought us all into the Cloudflare fold as well. And a nice thing about having good Cloudflare support is we should be able to support Deno or however the hell you say it really straightforwardly as well, because I don't know if you've seen the Deno deploy service that's it's in beta at the moment. Deno.com deploy looks really interesting, really exciting. They're basically using the Cloudflare adapter API, but it's their own implementation. They're not just wrapping Cloudflare. They've actually built their own Cloudflare equivalent thing that is powered by Deno, and we should be able to support that really easily, which I'm excited for.
That's pretty cool.
So yeah, we're definitely going to have more adapters, but the idea is that the adapter API will allow you to very easily build adapters for any platform in future as well. So we're not going to try and have like a comprehensive set and you have to come to the official Svelte adapter for platform X. That you can just go away and write your own adapter. That's the plan.
Yeah. So it's,
I think
more
one
like,
of the,
go ahead.
I was going to say one of the reasons that the Begin and Vercel adapters actually existed is because I believe that it was easy to use that API that Richard built, and it was, because I managed to write his adapters quite quickly. So,
although it's changed a lot since then. So
it has, but it's got simpler if anything, right? It's become a lot simpler. There's no manifests or anything anymore, so it's actually really testament to that a good adapters API. So
yeah, we've got a little bit more work to do on the adapter API, because there's things that we want to maybe implement, like maybe you want to have functions that only handle particular routes, so that you've got isolation between those different things, and like stuff like that is going to involve API changes. So that's one of the reasons that we're not at 1.0 yet, is because we need to nail that stuff down.
Yeah, I was going to say like documentation for writing adapters, probably a good thing to have.
Yeah, really good one to do.
And so I noticed during your talk you hinted a bit at maybe doing that use enhance thing as a built-in feature in SvelteKit.
Yeah, we've got to figure out what that integration looks like. It definitely should be part of SvelteKit, I think, in some form. But at the same time, like you could take that action and you could use it in any Svelte application anywhere.
Right. Yeah.
The tricky part is that if you're submitting a form without JavaScript, then you're going to get a response that is probably not going to be that useful to you. If you're doing the same submission with a fetch, right? Because in the example of that to-do app, when you post to todos.json, you don't want to just load the list of to-dos. Like you want to go back to the to-dos page and see the UI that's built on top of that data. So what happens is the endpoint, that todos.json endpoint, it will actually redirect you back to to-dos. But you don't want to do that if you're posting the data via a fetch. You actually want to get the data back. You want to get the new to-do that's just been created in the traditional REST fashion. And if you're going to do that, then you need to be able to differentiate between fetches and non-fetch submissions.
Right.
And so the adapter and the endpoint, they need to be kind of coordinating to some degree. And so like we've got to figure out what level of integration feels right and is going to make this sort of thing turnkey. Because I think it really is important that it's not any extra effort to build forms that work without JavaScript. That it's really easy to build the Node.js version first and then build the enhancement on top. Because right now, what tends to happen, and you see this like when you look at, I read a thing the other day in like, I don't want to call them out, but like the Next.js docs, they have like this thing about using forms in Next, and they describe this best practice, which means breaking the form. Like they've broken the form. It no longer works without JavaScript. And I saw another blog post just yesterday that it was about like adding types to your React form handlers or something. And again, it broke the form, because this is what like culturally we've become accustomed to, is that if you're building something with a JavaScript framework, then you just stop caring about users without JavaScript, which like it's really a marker of privilege. And as a community of web developers, I think we should do better, because this is one of the things that the people that I was talking about who decry modern web development attack us for, and rightly so, is that a lot of this stuff works without JavaScript frameworks, and you have to actively add stuff to break it, and that's kind of what we're doing at the moment, and it's not great. We can do better.
It is a bit weird.
I think also somebody posted that link that you mentioned in a bug report somewhere, where do your users have JavaScript? And I think that's really, really worth reading for everyone if it's not been posted again, just because we can't guarantee that anyone has JavaScript.
Yeah, and it's not people disabling JavaScript. It's people on weird Wi-Fi networks where they manipulate the traffic, or people on the subway and they got the HTML, but they went into the tunnel before they could get the JavaScript.
Yeah.
Like stuff like that happens all the time, and Like everyone is a Node.js user some of the time.
Yeah.
Everyone is a Node.js user until JS loads as well. So
yeah,
I
recently
an example of like us, like Australia or places like with that context, right?
Right. Yeah.
Like, yeah.
Yeah. There are people in Australia.
Yeah. Well, the global community, right? Like some stuff is handled differently in different areas, right?
Yeah.
Definitely. I've started recently using the Tor browser a bit, and that's one of those use cases where you don't want to use JavaScript, right?
Yeah, you have it turned off, don't you?
Well, yeah, I guess you can turn it on, but
But then there's no point
kind of
using
dangerous.
Tor.
Yeah, exactly.
And people will start finding out about all the shady stuff that Kev's doing.
That's a bad thing that people actually assume, right? Just because you're using a privacy tool, you should be commended for doing that. And everyone should do that by default, I think.
They should.
So
maybe
inspired by quite a few of the questions coming through Discord, Rich. What would it take to get people on Svelte full time? I mean, is there a way people can start donate, or how much does it take? And basically, people are curious about how you're managing to do so much as well as have a full-time job. And I think there's a lot of excitement to get Svelte moving faster and faster and faster.
I mean, the pandemic's been great because like none of us have a social life anymore, and that's very beneficial for open source. I'm really humbled by the fact that people are that invested in the framework, that people are talking about like what it would take financially. For me, it's not really about money. Like I really like my job. My day job is fun, and I wouldn't want to like not have that. I also think it's really important that the people who work on a framework have jobs that are not just about that framework. Like the fact that Anthony is like building stuff at a startup means that we get to see what the requirements of building stuff at a startup are. The stuff that I do at the New York Times, we have very esoteric requirements, and that kind of makes its way back into the framework. And like all of that diversity of experience is very beneficial when it comes to figuring out what stuff to prioritize and like all of that. So I don't think it would necessarily be in the framework's best interests for that not to be the case. Having said that, like I totally take the point about development velocity. We have an open collective, and people do support us through that. And so far, we haven't really found a ton of ways to spend that money. But we are like actively thinking about like how we can use that to triage our issue list and maybe put bounties on some stuff. And I guess all I can say is that we're thinking about this stuff too, and like we want the development velocity to be as fast as possible, but we also don't want Svelte to become like some VC funded like faux SS. Did I just coin that? Faux SS?
Yeah, I think you did.
Oh, I like that. That could catch on. It feels like there's more and more of that these days. Like there's a lot of people working on open source software, and then like you discover that there's a business model behind it, and I'm always a little bit skeptical about like whether or not that is ultimately in the best interests of the software itself. And I don't want Svelte to become a thing that is run in the interests of the people building it. I want it to be a thing that is run in the interests of the community at large.
That's nice. Cool. All right, so some questions here. What's your opinion on stuff like Svelte-NodeGUI and Svelte Native? Is that fun to see?
It's fascinating to see. It's so much ingenuity in getting something to work that way, because like we didn't design Svelte with those use cases in mind, and yet here we are. Like apparently it works. I haven't used NodeGUI yet. I've dabbled with Svelte Native, and it's terrific, but I haven't used NodeGUI. I'm excited to give it a shout, not just because of the Severus Snape sock puppet, just because it looks really fun. And you know, maybe there are ways that Svelte can make it easier to build those sorts of integrations. Yeah, I'm all for it.
Okay. Nice. Right. Do we have any other questions, or should we?
So I think one that's come up a few times actually is what are the thoughts on incremental static regeneration?
Yeah, I'm still not 100% sure what the value proposition of incremental static regeneration is. Like, what's wrong with cache headers? Can someone just explain, like M5, why you wouldn't just serve content dynamically but with a cache header? And as long as the cache header includes the word public, then you know it'll be cached at the CDN layer. And like, isn't that kind of the same thing?
Anybody in the chat want to clarify what the intention with incremental static regeneration is?
Kind of feels like this might be one of those, like, it sounds cool, someone is doing it, and it's the new shiny thing, maybe. But
yeah, like
in reality,
I know
it doesn't
that,
have any.
I know that Next has this thing, but I couldn't work out if it's a Vercel specific feature or if it's something that works anywhere. I don't know. I'm waffling because I don't truly understand what it is. There is an issue open for it on the SvelteKit tracker though, and there's a bit of a conversation happening there. So if people like are invested in this feature, then I would go and search incremental static regeneration on the Kit tracker and find that issue.
I mean, none of us can even actually say it straight because you get your tongue gets stuck halfway through. So I mean, you know, but yeah, exactly. So on the GitHub, let's take the discussion there for this and figure out what it is that people want and how we can get there.
Cool. Here's one that got a lot of upvotes. How do you handle a full-time job and building a framework, or how do you feel about it?
Well, I've been very fortunate over the last few months in that my day job and my hobby have overlapped a lot. So for those who don't know, I work at the New York Times in the graphics department, and I spent most of the last year working on our coronavirus tracking project. And towards the end of last year, we reached a point where our existing project just wasn't handling the workload. And we wanted to add county level pages for every county in the US, which is 3,000 plus counties, so that we could give people information about the risk levels in their local area. And like the way that it had been built up until that point, it just wasn't going to work at all. And given that we were using Svelte in the tracker a lot already, it made sense to me that we would use a Svelte-based static site generator. But it had to have like the flexibility to operate with our CMS and everything. And I figured like the easiest way to get flexibility is to like be able to be writing the thing as we're using it. And so for the last few months, we've been building the tracker using SvelteKit, and the things that that we've learned from using it have gone directly back into the framework. And so I've actually been able to spend time, some of my time working on SvelteKit in order to get the thing that I do at work to function. And so that's been a nice little journey.
A dog fooding experience.
Yeah, extreme dog fooding.
That sounds nice. Sounds like a lot of fun.
Just yeah, you also like you really learn where the pain points are when like your coworkers are in Slack saying, "What does this error mean? Come on."
Yeah, speaking of errors, this is going to be a weird segue into accessibility, but
make it work.
It's some kind of warning, maybe. Are we gonna? Is that something that you might work more on with SvelteKit in some way? I don't know if that's even possible. Maybe that's more of a Svelte question in general.
So it's certainly possible. Like once you have like a more predictable project structure, and like you have a better sense of like, what it would take to, you know, you can reliably like build and serve the application and then navigate the application because you already have like this common foundation. like we have the CLI and we have a predictable project structure. So in theory, you could do things like open a browser and start like programmatically navigating around and discovering areas of like the text and the background have too low contrast or something like that. These are things that you can't really do just by statically analyzing a component in isolation, which is how all of our accessibility checks work at the moment. It's not something that we're actively like working on at the moment, but I think like this is one of the things that kind of fall out of having this common foundation, is that you can start to solve problems at a more holistic level like that. At least that's certainly my hope.
Yeah. Sounds good.
Hey, just quick tangent. Somebody put Discord user Lee Rob posted a pretty good link to the ISR stuff, smashing.
Oh, so that's Lee from Vercel. I recognize the handle.
Yeah. So
really,
just FYI, you can look at that.
Cool.
Cool. So I've got a lot of projects in Sapper that are running with a lot of users, and I need to figure out how to migrate it safely over to SvelteKit. So what's the story there? Because I've heard some good things about the story. I haven't read too much into it.
So it will be a manual process. There's no sort of magical wizard that is going to automatically convert it.
I thought you were the wizard, Rich. Come on.
Well, so if you go to the website kit.svelte.dev/migrating or /migration, one or the other, there's a list of like the steps that you need to go through, and it's not an overwhelming list. The file system based routing is very largely the same. Your Webpack config, you can just delete that, get rid of it. You need to install some dependencies, remove some others, and rename a couple of files. But I think other than that, there's not going to be too much to do. All of your preloads become loads. That's changed. And if you have like a custom server, then you'll need to put that logic in your hooks.js file, or like middleware.js if we succumb to the demands of the crowd to rename it.
So that sounds quite exciting, because the changes are more and more, even though it's kind of a new code base, it's more and more kind of similar, smaller migration changes. Do you feel like you're zeroing in on the perfect way to build a web project, or do you think this is kind of like a local minima?
I mean, everything is a local maximum, and until it isn't, I guess. It's our best attempt to answer that question right now. Like, obviously, people are going to discover new techniques and new ideas, and in time, maybe we'll incorporate those, and it will involve some design changes. I mean, I can't imagine that in 2025 we're still going to be doing things exactly the same way that we are now. But yes, it does feel like we're sort of converging on a pretty good point. We've kept all of the things about Sapper that people like, I hope, but we've jettisoned the limitations. I'm feeling pretty good about how the design's shaping up.
Just the developer experience alone is just mind-bogglingly good. So feels just so right.
Yeah, I mean, it's been really nice to be able to start from the position of having unbundled dev server tools like Snowpack and Veep.
Yeah.
Like even though it's very new and like we are taking a little bit of a leap of faith with these things,
right,
it feels like we're setting ourselves up for the future. Whereas like if we're starting a new thing and then like even if we were building it on top of ES Build, which is fantastic, and SvelteKit does use ES Build under the hood, like ultimately you're buying into something that is going to it's going to add more overhead as your app gets larger and larger and larger. But with these new tools, like there's no overhead. Like your app can get as big as you like, and your server is still going to start up instantly. And I'm really excited about that. Like it feels like we've collectively just had this moment of clarity, and we're moving on from the last 5 years, and it feels great to be able to just like discard all that baggage.
Yeah, what happens is you have like all these sort of slime mold kind of apps that like have grown into dimensional proportions that are huge. And like anyone who works on those level of apps knows the pain points that you have with like large builds or anything that's really huge. this solves all that.
Yeah.
Yeah.
It's really great.
It's slick.
Yeah. All right. So it's getting late. We've been here for 6 hours and almost 20 minutes. That's almost as long as last time. And we swore we wouldn't have it as long of an event as last time. I guess we.
Congratulations for people who tarry.
Yeah.
Yeah, we can have a discussion later about how you got through it. How did you survive this long? Did you have like gel pouches and protein bars and
Yeah.
Was it just beer?
So probably.
So there are still some more questions. So perhaps we can do that in the clubhouse kind of space.
Disc house.
Discount, whatever
After
it is.
party. Yeah.
The after party. Perhaps people could ask us questions later.
Yeah, so there's a Discord channel called Svelte Summit, which has got a funny different icon, and it's Discord's version of Clubhouse. So we're going to give it a go and see what happens.
What is it actually called?
I think it's called Discord Stages. I think it is. I'm not sure.
Yeah. I'm
But it's
gonna
kind of
stick
cool
with
looking.
Discord Clubhouse. That works for me.
Yeah.
Right, so I'm gonna remove you guys from the window here and just end the event. Thanks for coming on, Rich. Yeah, thanks for joining us. Bye, guys. Ooh, all right. So we're done. We're finally done. No, I want more. If you want more, you should definitely head to the Discord and hop on the Discord stage channel. You can probably find it in there pretty easily. And so before we go, I'd like to again thank our sponsors, Filevine. Filevine's a tool for handling client workflow and document management. It's the work operating system for professionals, so check them out. And they're also hiring Svelte developers. Ooh. So I'm gonna drop a link in the chat about that. And next up we have GitPod, and they remove all the friction from the developer experience, so you'll always be ready to code. And they make the software development more collaborative, joyful, and secure. They recently migrated their website from Sapper to SvelteKit as well, and that's open source. And in addition to that, Mike will be joining us on the Svelte Radio podcast in a couple of weeks to talk about the migration. So that might be something to look out for. And lastly, we have Budibase, which is a low-code tool that helps you build internal tools on your own infrastructure in minutes. And they're also hiring. I guess we are hiring because I work there. So yeah. The Budibase itself is open source. So I'm going to post a link to that as well. And right. Lastly, I want to thank all the speakers for making their talks. I'm sure it was a lot of work, and we hope to see you submit stuff for next time. And of course, all the organizers that have really helped me a lot. Last time I did a lot of the stuff myself, but this time around I've had so much help, and it's been great. So yeah, with that said, goodbye and take care.